Okay, so we can make a start. So I would like personally first to welcome you to the ProVE 19th edition of the ProVE conference. It's an honor for us to organize this when Louis and Amide, who fortunately can't be with us today for personal reasons, have approached us to organize ProVE this year in Cardiff. I think we took that as a challenge, but we're here now. So it's truly my pleasure really to welcome you here in the city of Cardiff. Cardiff, a city that has over 2,000 years of history, starting as a fort, Roman fort, 2,000 years ago, then becoming a big port during the Industrial Revolution for the export of coal, to the vibrant city that Cardiff is nowadays, trying to engage with the information society, with the smart cities, challenges, etc. I hope you have a chance to have a grasp of all these aspects. We have a very exciting program. I think my colleague Tom Beach will introduce you the program in a few seconds that we have in terms of activities, etc. during the 3 days. And we also have an exciting program of very exciting papers, which Louis has kind of assembled and put together in the form of proceedings. Thanks for that, Louis. So really, I hope everyone will enjoy the conference, and then pass over to Louis really to give an overview of the program and what's coming ahead. Okay. Thank you, Yasin.
So, on behalf of the program committee, I would like also to welcome you to this 19th edition of ProVE. So it's already 19 years that we are running this conference, and one nice feature is that along these years the conference has kept some fundamental characteristics that distinguish it. So one of them is that we always have tried to keep multidisciplinary and interdisciplinary perspective in this event. So trying to integrate and cross-fertilize ideas coming from different disciplines, different areas. So this is a very important aspect of ProVE. A second interesting characteristic of this conference, and you have probably seen it in the title, that is called Working Conference. So a working conference is a concept introduced by IFIP, one of our sponsors. That means something between a conference and a workshop. It means it has to be small, according to the concept of working conference. Less than 100 people always, that's the purpose, because the idea is that not only to have presentation after presentation, but to have discussion. So, like in a workshop, we want participants to freely engage in discussion of the topics that are presented. This has been always the case in ProVE, and hopefully this year you will also contribute to this, to keep this characteristic, because it's the best way for all of us to learn more and to get more ideas how to proceed. The last characteristic that is very relevant for me is that ProVE has always influenced research directions and collaborative networks. So the main topic that we have suggested every year is often a starting point for different groups in this community to emphasize research on those topics. This year we have chosen a topic that is maybe a surprise for some. It came from the fact that nowadays artificial intelligence is permeating all areas of activity more and more. So more and more we have systems that are more autonomous, more intelligent. So we thought that, okay, we are talking about collaborative networks, so why not collaborative networks of systems and systems that are intelligent and autonomous? So we came up with this topic. But like in previous editions, what happens often is that the main theme that we suggested every year does not attract many papers on that year, but it starts a research stream. And in the following years, we can see more and more papers on that topic. So we are pretty sure that the same will happen with the topic that we suggested for this year. Like the topic of last year, we could see more papers coming in this year. So the same, I hope, the 20th edition of the conference will see lots of papers on cognitive systems. Furthermore, for this year, we also try to start 2 new initiatives. One is we have a number of invited position papers. That is something new in our conference. We didn't have this in the past. And the idea is to have some senior speakers presenting overviews of some topic and mainly giving us suggestions on new directions on that topic, new directions for research. So this will be a very important contribution to help our community to set up the future direction. And the second, let's say, new initiative will happen tomorrow afternoon in the special session of SOCOLNET. The idea is to discuss what can collaborative networks, therefore, what can we do for the challenges of the Agenda 2030 of the United Nations. Probably some of you are aware of this agenda that identified a number of important societal challenges. And we picked some of them, and tomorrow we want to have kind of brainstorming activity in groups to discuss what can we contribute to this area. So we are really looking forward to the contributions of all of you for these challenges of the society. Now I would like to thank the local organizers, Professor Yasin Resby and his team, and especially Tom. I've been in constant contact with Tom during this year, exchanging hundreds of emails, several emails per day, and I'm very pleased that everything went very smoothly. So they did a perfect job on organizing the event and brought us to very nice facilities and so on. So I really thank you for taking this important job, and also the University of Cardiff for hosting this event. So I think that from the side of the local organizers and also the program committee, everything is set. So now the only thing that is left to make this memorable event is your active participation in the sessions. So I really would like to encourage you to not be just listeners, but to actively participate in the discussions in all topics. Because the conference is small, but this means that all of you can attend any session in principle without difficulties in understanding. And keep in mind that we want really to encourage interdisciplinarity. So don't be afraid of asking questions about a different area, because this is what can enrich collaborative networks. So thank you very much.
everyone. I just wanted to run through a few of the local arrangements just before we get started. So as we can see on the screen here, this is just the main layout of the rooms we're in. So where you registered is just down there. Near to the registration desk is ladies and gentlemen's toilets. This big round room here is the room we're in now. And we've got two breakout rooms that we're using today. Breakout room 1, which is just out through that door over there, or you can use the corridor that runs just behind. And breakout room 2 is the room that you had tea and coffee in this morning, and that will be set up for presentations for this afternoon's sessions. For our coffee breaks, we'll be having tea and coffee in the cafe room, which is just down the corridor. Turn right and turn left. There will be signage up to direct you, and it'll be in the cafe that we will meet for tea and coffee tomorrow morning and Wednesday morning prior to the sessions beginning. The registration desk, will be having someone on the registration desk at pretty much all times, so if you get lost or have any questions or queries, then that can be your sort of first point of call. Just in terms of fire, there's no fire drills planned of any sort, so the fire alarm shouldn't be going off. In the event of a fire, leave the building through the entrance you came in with, back down the steps, and meet just on the far side of the road next to the park. In this room, you've got 2 exits on either side should you need them. And if that does happen, the university security team and the fire brigade will turn up and give further instructions about when we can come back in or what we have to do at that point. When we go for lunch, we're having lunch in Aberdare Hall, which is just a short walk away, a few minutes away. So we're here now. We literally just walk up the main road, to the left, go up to the end, and Aberdare Hall is here. It's a big red fronted building, so we'll be having our lunches in there. As well as myself and Yassine, we've got a few helpers here over the course of the few days, so please feel free to if you've got practical issues, speak to them. So Carla will be on the reception desk, and we've got Andre who's doing our filming, Corentin and Julia who are also helping out for various things. Wireless access information is all in the conference booklets. If you're academic and have access to EduRoam, then you can use EduRoam, but if you're not, then there's a CU guest or visitor Wi-Fi that you can do. You have to log in, put your phone number in, so if it's an overseas mobile phone number, please include the country code, and then it will send you a text message with a username and password that you can use to log into the network. Any issues, let one of us know and we'll get it sorted. Carlo at the desk, if you need to book a taxi, we'll have numbers, etc. that can help you out with that. One last thing about the stuff you'll have, you should all have your conference packs, which has the booklet about the conference, the proceedings, some pens and other bits and pieces, and some note paper. We had one minor issue in that the USB sticks got stuck in customs for several days. They arrived at about 8:30 this morning. So if you were here before 8:30 and didn't get a USB stick in your pack, please go back to the reception desk and pick one up. Essentially just a little branded USB that has a copy of the proceedings on it. There's also a link to the proceedings directly from Springer on the conference website, but that only is valid for something like the first 30 days after the conference. After that you have to have a Springer account to get access to it. But the proceedings are all on the USB if you need them. Just one final note for those presenting in a given session. Pretty much all the sessions come immediately after a break. So in each of the rooms, one of the team will be around to help you load your presentations onto the computers. So if you're presenting in the next session, if you can go to that room just before the session begins, and one of us will help you get your presentations loaded onto the computer, just to help with the smooth running of the session. We've got some social activities planned throughout the conference. Tonight, pretty much straight after the conference finishes, there's a short boat trip up and down the river to see some of the sights of the city. So we'll walk down to the park, down to by the castle, we'll jump on the boat there, have a quick boat tour, and then we have our evening reception, which is in Aberdare Hall. That's where you have your lunch. So there'll be nibbles and wine available there after the conference finishes. And then Tuesday night, tomorrow night, is the conference dinner in the castle. Meet at the castle at 7 o'clock if you want to have a tour. Cardiff Castle is a lovely historic building. The castle has agreed to provide us with a tour for those that want it. So if you want to have a tour of the castle buildings, meet at the castle at 7 o'clock. If you're not fussed on having a tour and just want a dinner, then arrive by 7:30. So the castle, we'll see the castle tonight. We'll meet just at the entrance there to go on in at about either 7 o'clock if you want the tour, or 7:30 if you don't. So, thank you very much.
Thanks very much. So that leaves us with the first plenary session, so review chain session. So that you will introduce our guest.
So it is really my great pleasure to introduce to you the first technical presentation of this conference. The topic is about blockchain. Blockchain has been around in the recent years as a very hot topic, and we believe that collaborative networks and blockchain can have a lot to do with each other. So it's a pleasure to his hands that he has a very large experience in research and development in both the areas in collaborative networks, where he has been active for many years and he has attended some of the ProVE conferences before. But one interesting characteristic of Hans is that he is always very concerned with social applications, social impact of research. Therefore, I'm very pleased to have him here today to give us this very important overview of blockchain.
Thank you very much, Lewis. Thank you. Right. If you don't mind, I would like to take a seat. See how it works. Yeah. All right. First of all, I would like to thank you very much, Lewis, for inviting me for this this talk. And it's a very interesting topic. Probably all of you have heard a lot about blockchain. It has a lot of interesting aspects, not only from the technical point of view, but also from the organizational, social point of view, business point of view. I got involved in it relatively recently, last year, where Dutch Blockchain Coalition has been starting, and I'm currently a member of the Blockchain Governance Working Group, where we are looking at governance issues related to blockchain platforms. That is not really the topic of my talk, although it will touch upon some of the aspects. The objective of my talk is more or less to provide an overview of issues, and especially research issues. At the very end of my talk, I would like to devote some time to it. So please, Lewis, if I maybe 10 minutes before the end, if you warn me really to focus on these issues, if I haven't done so myself, or maybe 15 minutes. So, yes, my background, I'm an engineer, but I moved into finance in the 80s already. So that is now becoming very interesting because the work of Oliver Williamson, for example, transactions, organizations as sets of transactions, Jensen and Meckling and others, and Ronald Coase, not to forget, who is the founder of this idea of organizations as nexus of contracts. That is now becoming very relevant in terms of how blockchain is working in organizations, so I will have to say a few words about that as well. I became very much involved in collaboration from the point of view of collaborative working environments, for example, but also in networks, how people are working enabled by technologies in networks of organizations. And, I'm pleased to take up that issue again, and I hope we can have a good discussion afterwards as well. My objective is really to work on a research stream, a new research stream. I mean, lots of work is being done in this area already, but I would like to have the ambition to collectively discuss what the opportunities of this research topic are for SOCOLNET, for ProVE in the coming years. So that is the overall ambition. Blockchain is a very new, relatively new topic. It has potentially a lot of impacts. Its origin lies very much in the peer-to-peer protocol for transactions developed for Bitcoin, proposed by Satoshi Nakamoto in 2008 in his really famous white paper, which is available on the web. It is very interesting reading. It is very well structured. It's a relatively short paper where he is presenting all the main concepts in a very appropriate manner. I wouldn't say easy to read, but it's really very well structured. Satoshi Nakamoto is, of course, a pseudonym, which most of you will know. It's still unknown who's behind this. The concept has been taken up by lots of people. For example, the Tapscots have written an interesting book about the blockchain revolution, where they propose the concept of Internet of Value based on blockchain. The idea that blockchain is enabling decentralized exchanges of value. Currently, there are a lot of working applications of blockchain technologies. However, these applications are mostly, apart from platforms, which we address anyway, they are mostly in a limited scale. A lot of piloting is going on right now, and a lot of organizations are involved in it. Wider scale applications in practice are relatively scarce. Also, it is a very important topic for research even, so we'll come back to that in the end. How to integrate blockchain technologies in the information systems of enterprises. How to do that. So a lot of software companies are now working on these topics, proposing architectural approaches and so on. How to arrive at solutions, but a lot must be done in that area. That also has to do with standardization, interoperability issues, and so on. We'll touch that also later on. Blockchain also has a potential of being combined with key technologies like artificial intelligence, Internet of Things, and other technologies, data analytics, for example. There is a lot of work to do in that area as well. The topic which is central today is how blockchain will affect organizations, the structure of organizations, the processes, the networks, the collaboration activities in and between organizations. That will be central. And from there, I would like to identify a couple of key challenges from business, societal point of view, and define some of the areas of research. So, let's see how this works. So I would like to touch upon a couple of issues. First of all, I would like to begin with what is blockchain and what kind of applications are we seeing right now appearing in practice. I would like to touch upon the benefits of blockchain and using that as a basis to look into how blockchain is changing organizations and networks of activities. I will have to say a little bit about business models based on blockchain, a very interesting area where many aspects will come together. But that's really an open area for research for the upcoming years as well. And finalizing with what are the key challenges and interesting research topics of blockchain. So, what you can see here on this picture is that expectations of blockchain are really very high. Blockchain, at the same time, people are really driving activities and becoming a little bit impatient sometimes, which you can see because of blockchain. I don't know if I can, yeah, I think it's somewhere here. Blockchain is already in the trough of disillusionment, as it is called by Gardner. But, you know, that is just one point, whereas blockchain is made up of many, many, many different areas. And so we have to be very careful with such kind of pictures which provide only an overall opinion of market analysts. Whereas we know that many, many different things are happening in practice, in research, and piloting, and so on. So what is expected is that it has a lot of prospect. For example, there's a study from PricewaterhouseCoopers telling us that around 80% of fintech companies are expecting to adopt blockchain as a part of production system or process by 2020. Okay, that's nice to hear. And especially in the financial industry, a lot of activity is going on, of course, we know that. But there's a lot to do. The next picture is this picture is providing a somewhat more detailed picture of what's going on with blockchain. And here again you will see that blockchain it's made up of many topics, and many of these topics are in the initial stages of research, development, so it's really emerging, whereas experience is going to be developed in a number of other topics like ledger technologies, like applications in banking and finance and so on. But the large-scale applications are still more or less lacking and are expected over the years to emerge. On the left side, you see the perspective of business, and on the right hand, you see the perspective of technologies like smart contracts, like data security technologies, decentralized applications, which is really very fundamental for blockchain. The DAOs, the so-called decentralized autonomous organizations built upon smart contracts. These kind of technologies are really in the process of emerging and being researched, and it is still some way to go until full realization. That is what this picture is telling us. I think it would be good to talk also a little bit about the key players in the blockchain ecosystem. This is an overall overview of key players. In particular, I would like to point to the platform players who are enabling users to develop blockchain applications, for example, built upon smart contracts, distributed applications. Ethereum will be very well known as such a blockchain platform initiative, initiated by Valerik Buterin, a couple of years ago. Very young, very extremely intelligent person, as it looks to me, who has built up together with a core group of people this platform initiative, which is capable to support people and organizations to build decentralized applications running on that platform. Hyperledger, which is looking very much to cross-industry development of blockchain applications. Hyperledger, IBM is very much involved in that as well. It originates from Linux software. Neo, which is looking at smart assets based on smart contracts and looking at digital goods applications, exchange of digital goods. Coinbase, which is very much focusing on currency, digital currency exchange. The R3 Corda is very interesting and important as it brings together quite a number of financial companies, around 100, in global consortium looking at digital ledger applications for the financial sector. And of course, due to the interest that Bitcoin has brought us, financial institutions are very much interested in the wider applications of blockchain technology as well. And so a number of banks, but also stock exchanges and other financial organizations, insurance companies are deeply involved in blockchain. Venture capitalists, of course, and also computing companies like IBM are very much on the forefront. IBM, they are not only partnering in Hyperledger, one of the originators in Hyperledger, but also building up their own blockchain program to support enterprise solutions. Governments and regulators, of course, because blockchain brings a lot of issues in terms of security, legal challenges, and so on, which have raised the interests of governments, of regulators. So it is important that governments are aware of these developments. They're often also already deeply involved in blockchain applications themselves, because blockchain has a lot of impact in providing government services. Think about social security, think about identity issues related to passports or driving licenses and so on. But there are many, many applications in the domain of government services as well. And of course, standardization organizations like ISO, they are very much involved because of the apparent issue of interoperability across blockchain platforms, across blockchain applications as well. This has become a very important issue for the standardization organizations. The governance issues are important also from the point of view of standardization. And it is taken up both at the international level and at the national levels of national standardization organizations who have started up already working groups and standardization committees to interact with the global level on standards, especially related to interoperability. Of course, the ecosystem is much more complicated than I can show here. This picture, which I found on PitchBook, presents kind of market mapping of blockchain activities around key areas such as transactions and payment services and where is it? Enterprise blockchain solutions, just to show you that in reality many different parties are involved in blockchain activities. I would like to touch a little bit on the basic principles of blockchain before going to the organizational issues. I have to be short because I mean it is a very complicated technology. At the same time, the principles are relatively clear. So I would like to present a quite superficial picture of what blockchain entails, and then looking at some of the application areas before going to the organizational issues. Well, the basic principles are that blockchain technology is very much like a distributed ledger technology, where transactions are being recorded in a cryptographically secure manner. into chains of chronologically linked and, transactions. And there is a participant network around such a blockchain activity which enables the validation of transactions at the level of blocks. And that is a very complicated process. I will say a few words about that only. But that is the reason that the participants are willing to do that, so to say, the business model behind it is because they get compensation in terms of tokens, for example, Bitcoin currencies. That is driving the process of validation very much. This is a very superficial description. I'm very much aware of it. Any one of you who would like to go deeper, I can recommend countless sources, countless really. There are some very good books, but many, many papers, many blogs. It is really very lively discussion everywhere, white papers and so on. And I've really spent some time the last couple of months to create an overview, and there's really a lot available which explains all the details, the mathematical details, but also the mechanisms and so on. So, if we look to a simplified scenario here, and I should say, these principles which I've been talking about enable that there is no need anymore for trusted intermediaries. So, because of the participant network is doing the validation of all these transactions, you can disintermediate. The role of normal intermediaries like notaries or banks or insurance companies can be cut out of the whole system. So it's not right. It's not really 100% the case, of course, right now. And we see that many of these intermediaries are jumping on blockchain because they can develop added value services on top of blockchain technologies. But that's another story. In principle, you can cut out the intermediary layers in transaction systems. So it enables very much peer-to-peer economies. That is a very important concept, peer-to-peer. And it also enables decentralized organizations which are based on smart contracts, software rules, which are depending on events or what else, and then taking some kind of action. Actually, it's rule-based enterprise, but at a very decentralized level. So, and that also generates very, very new business models at different levels, at the level of companies, at the level of intermediaries, but also at the level of supply chains, at the level of network organizations as well. We'll come to that. This scenario, think about management of ownership of real estate, where after any transaction, the ownership is changing from one person to the other. For example, you are buying a house, another person is selling the house, you need a notary, you need a bank, and so on. Parties must agree, a lot of information is sent from one party to the other, and so on. It takes a lot of time, all kinds of contractual aspects. So it is maybe not with the house, but with normal transactions, it really takes a lot of complexity. Think about workflow between companies and banks or international transactions. That is sometimes a lot of paperwork going from one organization to the other. So it can be very complicated. But in the blockchain scenario, you would have a common database, secure, which contains all the transactions, all the information in terms of a chain of digital files which are linked to each other in blocks, and where every transaction is being validated by the network of participants based on cryptographic rules, based on validation algorithms. So that is called consensus mechanisms, consensus. And the parties who are doing that are called miners in the Bitcoin network, also in other blockchain platforms. So this database is shared, it's distributed among all parties involved in the initiative, at least where we have open blockchain networks. Anyone could be a participant, but the business of mining has already taken off. So many people have bundled their forces into their computing power in mining platforms that are taking a share of this whole business. So all of this means that we don't need trusted parties in principle. So this is a little bit and this comes from the paper of Nakamoto, this picture. I wouldn't go into the details, that would take me too much time right now. So, but those who are interested could look into the paper to find out what the principles are, how cryptographic technologies are being applied, public key technologies, private key technologies, hashing transactions, comparing the hashed transaction with a kind of working with the consensus algorithm to create a hash of these transactions and comparing it with the original transaction hash, and trying to solve the puzzle which enables the validation. So it's a kind of comparison with a puzzle, very difficult to solve. So a lot of computer power is really needed for that, in order to do that. And within the network of participants, everyone is trying to solve these kind of puzzles. And in the end, the solution for the transaction is part of a block added to the existing block already. It's time-stamped. It is validated so that it can be attached to the chain, and then the process can start again. Right. The important invention now is also smart contracts, because smart contracts can be run on blockchains. There are, as I said already, software rules enabling transactions which are based upon some event. As soon as the event is triggered, a rule is set in motion. And this is how a decentralized autonomous organization in principle could work. And there are already very good examples for that. Basically built upon the Ethereum platform. Ethereum platform is generating more than 80% of all decentralized autonomous organization activities right now. So this is really a key innovation for blockchain in terms of its application potential, for example, combined with the Internet of Things, with data analytics. It is able to fulfill a very important role in Industry 4.0. Think about inventory management, logistic applications, and so on. Yes, I think I will skip a little bit and go to the types of blockchain architectures that we currently find right now. I already said that we could distinguish between public blockchains, like Bitcoin, like Ethereum. In principle, everyone could participate to such blockchains as a miner or as bringing in transactions. But we also have private platforms, which, from the point of view of governance, are differently structured. Only particular persons or organizations could be a member, so there's a membership process. There's also a coordination process. There are rules, governance rules. So the whole issue of governance applies mostly to private or as it is called, permissioned blockchains, like the Hyperledger blockchain, the multi-chain, Ripple. Interesting here is the consortium blockchain. It's a particular type of private permissioned, it's a particular form of private blockchain where we see quite a number of interesting examples already. Not only at the global level, there are 3 consortium, which is bringing around 100 banks together to work on blockchain applications for the financial industry. We also see a lot of consortium blockchains appearing at industry level, where industries, for example, in the supply chain want to work together. They create a private blockchain which is consortium oriented and which is governed by certain rules. So there we have all kinds of issues that are also quite common to the field of collaborative networked organizations. We see a lot of partner selection issues, governance of the network, as I said already, membership issues, voting, all kinds of governance issues are important in that area. So, and then we also have blockchain development platforms. A number of organizations are offering the tools which enable, for example, the private, or let's say the consortium-oriented blockchain actors to develop their own applications. So basically you see parties such as Ethereum, Hyperledger, R3 and Ripple and others offering the tools that enable you or consortia of organizations to build their own blockchain application. Okay, so far I think it's sufficient to have an impression of blockchain. I should now really be quickly move to a couple of application areas. Well, I just would like to show you this picture, which is presenting application areas in many, many sectors from the point of view of impact and feasibility. So what is in the middle means relatively feasible, relatively high impact. A lot is going on in insurance, in financial industry, but also manufacturing becomes very important. The public sector is highly important, it's really a driver because of the government interest in blockchain as well. And yes, well, in the paper, which is in the proceedings, I'm quickly sketching a couple of applications already. For example, in various sectors like finance, think of micropayments, or peer-to-peer lending, so you don't need an intermediary. You just set up your transactions with another person or another organization directly. And blockchain is an extremely attractive technology in order to facilitate such peer-to-peer transactions. But if you think twice, you see these peer-to-peer transactions everywhere. For example, in education, certification of your key documents can be done in a peer-to-peer manner. And then you can resolve all the problems which arise if intermediaries are in between you and an organization where you want to apply for a job or where you want to apply to do your studies and so on. Real estate transactions, for example, it's a very interesting area of work. Insurance, where smart contracts really have a lot to offer, because insurance is often conditioned upon some event which is happening. An event. So think about how an event is triggering a process of transactions at the peer-to-peer level. So a claim is being defined, Then claim processing must be done. Refunding activities must be carried out. But also identity must be verified and so on. So it's easy to see how the principle of peer-to-peer can be applied in these kind of applications. Also, sharing economy applications are very much possible without a centralized intermediary like Uber or Airbnb. There are some interesting models already in using Uber type of services, but not through Uber, through a peer-to-peer mechanism. I have one example in my slides, but I will come to that a little bit later on. Think about transactions regarding intellectual property. Actually, nearly everything can be translated as a transaction. If we look to how organizations are functioning, it is, from the formal point of view at least, you can identify countless transactions which can be handled peer-to-peer without intermediaries. Right, I will skip a little bit, just showing you that, whoops. Financial sector, of course, is very important for blockchain applications, not just because of Bitcoin. We have to, I'm not talking about Bitcoin, I'm actually talking about the technology behind Bitcoin, which has a much wider application potential as you have seen right now. For example, capital market transactions, transactions regarding options or puts or whatever financial derivatives, they can be structured in terms of smart contracts. And so there we see the possibility, the potential of decentralized autonomous organizations. It raises, of course, many other issues like security, like vulnerability, systems vulnerability, resilience issues are being raised as well. So we should really be aware not only of the potentials of blockchain, but also of the risks and vulnerabilities that could emerge. Because actually we don't know how it works out in practice, because we haven't seen these large-scale applications yet. But let's think about how it would work when stock exchanges are being handled through decentralized autonomous organizations built on smart contracts. And think about the crash which happened in 1987, due to automatic trading mechanisms already. It's a little bit similar, no? So we have to be aware of the issues that are brought up in terms of systems complexity, but also systems vulnerability, very much. Just to mention that identity is an important issue from the blockchain perspective. Wouldn't go deeper, but those who are interested in peer-to-peer identity management could look into the sovereign activity. Very interesting activity going on. A large consortium, global consortium, is building up applications for peer-to-peer identity, which can be governed by any single user. So you can decide as a user who would receive which kind of information concerning your identity. So there's a lot more to say about this, but we won't have the time. Industry 4.0 is a very interesting application area for blockchain, of course, and we see a lot of potential of combining it with artificial intelligence principles, like blockchain-enabled supply chains, like smart contracts in inventory management, linking inventory levels to logistic activities and so on. Well, I mean, we could easily design such scenarios. In terms of the logistic activities, there is a very interesting activity going on. It's still in the piloting phase, collaboration between IBM and Maersk, building up a trading platform based on blockchain, and in terms of container transactions, it promises a lot in terms of cost efficiency and removing all the intermediary levels. Right, I found this picture also, which is presenting a number of prospects if it comes to application potential of blockchain to manufacturing. We have to be aware that a lot of these activities are in the piloting phase. Before a blockchain pilot really becomes a reality, we will be a couple of years away from that moment. So that is still, so more or less, a number of quite successful pilots have been run, for example, in workflow management, in business process management, in logistics, but scaling up from pilot level to real-life application level is really a big challenge. Could also be interesting for research. One of my students at the Radboud University is looking to adoption of blockchain, adoption potential, and the transition phase from piloting to real-life activity. I've seen many other comparable activities at universities going on, so that might be interesting to look at as well. Okay, I'm skipping a little bit, and maybe these slides could be made available. There are many applications going on in healthcare. This is a pilot in the Netherlands called My Health Log. It's about simplifying the process of home care administration between all kinds of parties sending letters and emails and so on. You can simplify it by using blockchain technology. What we see here, by the way, is that the intermediary level is not completely disappeared. There's still an insurance company involved in it, but overall the process has been simplified. And the outcome of this pilot, which was run by National Healthcare Organization in the Netherlands, is that substantial cost efficiencies can be achieved and that such applications are really feasible. So it's really a candidate for large-scale implementation. And the same can be said from pilots going on in energy, using energy markets, for example, and so on. At the government level, oh yes, this is an interesting one as well. This is one example how blockchain is capable to transform digital markets into peer-to-peer relations only. Open Bazaar, very interesting activity, which is running, and it enables you to directly interact with others to buy or sell goods, or what else. The transactions are validated. Bitcoin is the token which is stimulating the validation process. And, well, this application has some interesting special aspects from the point of view of contracting. It uses recording contracts, so readable, text readable and translatable to software, which can be brought in then in smart contracts. And it is also using multi-signature escrow, using a third party, which is involved right from the beginning in the transaction, in case there is a conflict to be resolved. So dispute resolution is part of it. This is also already an interesting example of how, at a very decentralized level, organizations could work out. And as I said, a lot is going on in terms of government pilots. This is an overview. This is an overview of government-oriented pilots in the Netherlands. A lot is also at the municipal level, at the national level. Think about social security applications, passports, driving licenses, mostly. But these are really pilots, not yet full-scale reality. So now we have to go to the organizational side. Organizational impacts will be relatively clear, but we have to make some distinctions. Organizational impacts are clear at the organizational level. Some intermediaries will be affected heavily, of course. But also, if we look to the business processes of companies, they will be affected. For example, the management of business processes, the coordination, some of the intermediary functions will be affected as well. And that could lead to quite some changes in organizational structures of companies. So this aspect of disintermediation doesn't only work in between companies, but also at the company level itself. Because think of management as an intermediary layer, coordination activities in project management. It still remains to be seen what is the essential impact of blockchain at the level of companies, at the level of how teams are working, teamwork, collaboration across teams at the international, at the global level, for example. There are some examples already, and I think my friend Wolfgang Prinz is also working on these CSW applications in team support, in collaborative workspaces, and looking at the way blockchain technologies could be integrated in collaborative workspace environments. So that is a very interesting area of work as well. Look, still, I'm skipping this a little bit and going to this picture, which is quite complicated, but my message actually would be that we have to be aware of the reason of existence of organizations. Yeah? And there we can learn from some of the old theories I mentioned already in the beginning, like Williamson's organizational failures frame, agency theory, which is looking at the issues between principals and agents, issues like incompleteness of information, uncertainty, complexity. Because we cannot just say, well, let's replace an organization by a set of contracts and let's use a blockchain to automate everything what's happening in organizations. There are some reasons why organizations exist, and I think we have to think about whether these reasons are still valid in the time to come. And already, if you look to history, we see a lot of different types of organizational forms. Clans, some of you will remember the work of William Ucci on clans, markets, hierarchies, identifying what the reasons are that we see clans, that we see hierarchical organizations, where we see networks or platforms, communities. Come to that later on, in crowds, in the modern times, ecosystems as we call them. And Tom Malone has done a lot of work in the end of the 90s in looking at the role of information technology in shifting the boundaries of organizations. And driving, if we project some of the newer technologies into these pictures, like big data and digital marketplaces and smart products, and also we could move in blockchain technology here, we see that the boundaries of these organizations are shifting to the left. That we see typically forms of connected organizations emerging based on blockchain. But culture and human behavior still remains very important as a reason of existence for organizations where we need 5 minutes. Yeah, okay. So I will skip a little bit more now. There are some interesting forms of organizations coming up, like common-based peer production networks. Some of you will remember the work of Benkler, who has worked on these concepts of common-based peer production, very decentralized forms of social production, which enable collaboration across large numbers of people. And we see a lot of application potential for blockchain here as well. But it will also raise a number of other issues. How to address community governance, for example. Will there be some rules of membership, or will they disappear if we would integrate blockchain technologies in such concepts? This is still very much open for research. The CAPS program has been very instrumental in raising some of these issues, but has not really built up applications and tested them in practice. So that is really something that remains to be developed, and possibly we could make an argument for going much deeper into this area of work. I would like to move to a couple of challenges and research issues. The best thing I could do is to move to this picture, the last two slides. Actually, there are quite a number of challenges here in the field of blockchain. Business model challenges. What will be the business models for organizations who want to work with blockchain technologies? But also, business model is a concept we should use at the ecosystem level of platforms. What will be the business models for these platforms? Of course, these platforms like Ripple and Ethereum have their own business model based on tokens, tokenization, very important concept. But how will it work out with consortium-based collaborationships? How to address governance, partnership, value streams, and how to allocate these value streams. Incentives within the organizations. That is quite an open area of research, at least from the organizational and social point of view. There are also countless legal issues, and people like Bright and Primavera de Filippi have done a lot of work to bring the legal issues to our attention. How to balance rule of code, smart contracts, with rule of law, what's happening in reality, interactions between people, how to balance it, based on blockchain. The concept of commons-based peer production was known already around 10 years. But what will blockchain technology imply for such concepts? What is the synergy between these existing information systems and blockchain technologies? How to create the synergy? How to resolve the legacy issues? How to address interoperability, standards, and so on. How to address the acceptation and adaptation issues of adopting blockchain technologies into real-life organizations. And how to motivate people. How to create new types of organizations and how to design such organizations. Well, these are countless challenges, and maybe we could discuss them later on. I would like to end up with a couple of final remarks, also some warning. Blockchain is a technology of autonomy. It's a technology enabling decentralized autonomous organizations. It's driven by technology push and by the desire for autonomy. If you look to the culture of these blockchain enthusiasts and experts, it's the culture of technology and it's the culture of autonomy, which is very good. But in reality, we are dealing with human organizational issues, with trust issues, with criminality issues, with all kinds of complicated issues, with resilience dynamics. So there might be limits, or at least constraints, to apply blockchain and artificial intelligence in organizational settings, and how to discover these. It's a process of learning and experimentation. So we would need research into how to experiment with blockchain technologies in real-life settings, how to design, redesign, adapt organizations, the process of adaptation. From a technical point of view, I'm certainly not an expert, but as far as I know, blockchains cannot be changed. You only can add blocks, but you can identify all the transactions that have been carried out in the past. So that is a very important application of blockchain, that you have a database available.
The classic example of that would be famous Toyota SOCOLNET. When Toyota entered data, I think it was $9 million in replacing the SOCOLNET on every mark of certain
Okay.
because
Yeah.
they couldn't identify which ones had been put in.
Yes, sure. That's a very nice example. Thank you. Yeah. Yes.
Yeah, thank you for your presentation. I have two challenges, and I want to know what do you think about. We hear it. You have a blog where every information is stored, and if you got some personal information or privacy-related information, so how do you handle it? The right of forgiveness. So, if someone wants to forget that data exists, how to delete? You cannot delete. But how you handle it in the blockchain? You have to delete the whole blockchain. So this is a challenge. I think there's no solution.
Yeah, well, in blockchain you are not identifiable as a person. You are anonymous. Sorry?
You can store privacy information.
Yeah, you can store privacy information, identity information, for example. But you can define who is able to access it.
Okay, but you cannot change. If you want
No.
the system to forget, you cannot do it.
Yeah, probably you're right. Yes, yes. It might be a drawback, yes. But there are many drawbacks. Many of them which we haven't. Do we want all of this? That came in my mind yesterday evening when I was thinking about today. I've read an interesting book in Dutch about the state from Paul Flissen. He's a political science. He's talking about right to forget, right to be intransparent, in transparency. It could serve some objectives. No? It serves also some bad objectives. But full transparency, would we like that or not? It's a very real question. Anyway, blockchain has some safeguards here, but you would need to go deeper into the technology to understand them. In principle, you cannot change any information on the blockchain, so it's fully transparent, but it's also protected. But there could be instances where, well, there have been some vulnerabilities, not in the blockchain technology itself, but in smart contracts. Some of you will know what happened with the DAO application, which was really hacked because of a vulnerability in the smart contract software. So things can happen, but not really in the underlying blockchain technology itself.
Yeah, Hans, thank you very much for this beautiful overview on this potential. And I think everybody of us is dreaming about these potentials. But let me put some questions from a technical issue. So I like your first point, experimental approach, learning by doing. Do you know anybody or any approach how to get an idea on the limits of the blockchain? Because, for example, we are working deeply involved in all kind of smart factories. Yeah. And there is a definition saying about the latencies, the volumes, the data, and all these, which limits the information that you need, for example, for blockchain. We know that the PC, the IT power is enormous behind this. Yeah. And for example, if you're gathering data from a machine in seconds, whiles, you will gather data which will lead at the end the blockchain approach as a limit. Do we have any idea on how others are approaching this? Is there any research to be done on this?
You mean the limits?
Yeah, the limits of blockchain, just to understand, because this is a beautiful landscape, and if each and everybody of us is now going to this landscape, all of us, we will have to learn where are the limits, and then following the Gartner hype cycle, we are getting down into the valley of tears. Just
Well, limits are definitely there, even in technology, for example.
what are the main limits for you?
Scaling up the technology.
Yeah.
Interesting area that's being worked on, but it's not resolved. So it has some technical limits as well. I would say, could there be also organizational limits to using it? And there are, I think if we would sit together with a couple of people looking into this, we could identify a number of them. And these are also research topics, for example, governance, coordination. Because there are, and how, I mean, if you talk about smart industry, I'm thinking about consortium blockchains. But there you have to define the governance structure. So who will be a member, who's allowed? And it is also vulnerable, because the vulnerabilities that you wouldn't see in public blockchain because of the mining, constant mining by lots of miners, you wouldn't see in consortium blockchain, because there's a limited number of participants who have many more possibilities to misuse the blockchain network. And that has to do with the large numbers, the specific way validation is carried out through the hash algorithms and so on in the public domain, in the public blockchain network, versus the much more limited blockchain applications where validation is carried out very differently. So, yeah, I think the organizational limits are not well researched. This could be an interesting area. In fact, yes, in fact, I had too little time for the last part. Stupid, but the last part is the most interesting to look at. What is the conference title? Collaborative Networks and Cognitive Systems. What is the new balance which we will see between AI, blockchain-enabled systems, and humans working together? What will be the balance? I think we shouldn't think about it in terms of good or bad, although there could be some bad aspects, but things are moving on, so how to create adequate governance structures around all of this, and also finding out what is workable in practice. What are the new equilibria which we will see between? Of course, I was studying in the 70s, 80s, did my PhD in the 80s. We were studying man-machine communication, man-computer dialogues, how to design these dialogues. But later on, things have moved forward, of course, incredibly. So now we have a new balance. So what will be the new balance brought in by AI-enabled systems, blockchain-enabled systems, in terms of human behavior, human responsibility, teamwork, collaboration, and so on? That's a very attractive area. Yeah?
Yeah, we've not talked about the talents in terms of, I mean, I've started to see jobs appear now in blockchaining and cryptology, and are the universities keeping abreast? You know, with this new, should we be teaching this?
Yeah, well, what comes to my mind is that there are a number of pilots going on in terms of education. I think there's a very good group. John May, is he known to you? Open University, he's working on blockchain applications and education, certification process. He has been studied, I think last year or 2016, by the Joint Research Center in Seville about blockchain applications in education. So and currently in the Netherlands there's a pilot on certification enabled by blockchain, so that people can apply easier for jobs. The information is stored in a very secure manner. It cannot be tampered with. It's of course a very important characteristic of blockchain. And also so that you don't need an intermediary to check the realism of your curriculum vitae, your certificates, and so on. Well, a lot can be said about it. But talent, and how it is being used to create jobs, to apply for jobs, it's a very important application.
So we are in UK, I would not like to disturb the cultural punctuality. So I think we could take the opportunity outside to talk with Hans, and now we have a coffee break. So let's thank him again for his presentation.
Planned. Unfortunately, two of the presenters couldn't make it because they had visa problems, but they have sent their presentation. So we have two presenters available in the room and two presenters who have sent their presentation. So we start with the first presenter on the schedule. So I'll take you through this. The title is Optimizing Humanitarian Aids for Marketing Influencers Advertising in Social Networks. A large presentation and
in my presentation, and I hope you find this topic interesting. The topic is optimizing humanitarian aid for regulating influencer advertisement in social networks. On October 12, 2017, an earthquake with a magnitude of 7.3 happened in western Iran, with at least 630 people killed, more than 8,100 injured, and almost 700 people homeless. Immediately after this earthquake, governmental organizations
my presentation, because this one is very much focused on IT perspective. So the main goal in general is how all the systems that are going to support the execution of a virtual enterprise should be kept running all the time. This work has been developed especially by Mr. Rock Becerra. He's my PhD student, so unfortunately he couldn't come. So I'm trying to replace him, especially because resilience or fault tolerance is a very detailed technical topic. And instead of when I decide to present this, so I decide to skip very technical details, because in the area of distributed systems, there are so many algorithms, so many techniques, so the presentation would be too boring. So the main idea is to provide you the rough idea about how we are facing this issue. So generally, the initial context, when there's a given business demand, so in principle there will be a virtual enterprise which is going to be composed or to create to cope with that. So there's a kind of business modeling using BPM tools or some equivalent ones. And then from VBE, a virtual organization breeding environment, a set of virtual enterprises are formed. So for each one is created somehow a kind of workflow which will control the execution of each virtual enterprise. So some companies can get into, some companies can leave during the virtual enterprise life cycle. And during this execution there are many systems which, in concrete terms, many functionalities of their systems should be invoked all the time during the execution of the virtual enterprises, including some functionalities provided by, let's say, business or IT partners. Well, the idea. So, and each functionality, so each of them can be and will be normally involved simultaneously in the execution of many virtual enterprise, many systems invocation. So, there are two main assumptions in this work. The first one is in the context of IT preparedness, which is a must when a partner decides to be member of a VBE and then to a virtual enterprise. So they have to share resources. In our case, to share their systems. And another assumption is that considering the increasing usage of service-oriented architectures in the systems nowadays and in the integration strategies adopted by companies, so we are assuming that all the systems that will support the virtual enterprise execution will be somehow wrapped as services. So all their systems are exposed as services. Especially in the case they are going to be shared with other members. In this case, what does it mean? So the particular or the individual workflows of each virtual enterprise will access all the members' services that are required to execute the given virtual enterprise. This means that when I create this virtual enterprise, a set of services are discovered, selected, and bound to the business processes involved in the execution of the systems, and then this invocation will naturally invoke the services which are previously stored in what we called the VB Services Federation. It's a kind of logical aggregation of all the members' services, which in turn will access the local services deployed locally in each member. So this and all this creates, let's say, a very complex scenario from the computing point of view, represented by a very large-scale distributed and cross-boundary VE system, which is temporarily and dynamically set up to support the execution of each virtual enterprise throughout its life cycle. So there's a kind of different set of services which will be composed for each virtual enterprise. So what's the problem? The problem is that in these great systems, in these great service-oriented systems, several faults can happen during the execution. For instance, both in the systems themselves and individual services. And new partners can get into the VE, and other partners can leave the VE. So this system is not static. So this composition of services should be dynamically adapted as well. So our goal is how to support the system's recovery in the case of faults and evolving services, and of dynamic changes in the VE composition, considering that there will be several simultaneous VE in execution. So for that we have developed a resilience architecture and a prototype as a kind of proof of concept to demonstrate the ideas. So a definition about what resilience is, so it refers to guaranteed operation of the system under control, and it's recovering the presence of faults. Not only, let's say, recovering anyway, but respecting acceptable costs. Of course, I won't read this. It's just to show that there are many works in the area. So this area of fault tolerance and resilience in distributed systems, so it comes from decades. What are the problems? That quite a few, or basically none, works have developed solutions devoted to VE-like scenarios, so these kind of dynamic systems, and service-oriented based systems. So what all that works have done, very nice contributions, but to very specific issues. And besides that, the fault tolerance or resilience, or the resilience problem itself is considered NP complete. It's a very hard problem. And so there are many assumptions and simplifications in the solutions that the guys have provided. So what you have done to some extent, based on some, let's say, comparisons and take advantage of these individual contributions, we have tried to combine the best things out of, let's say, these ones, and have adapted them to this scenario, which have some, let's say, particularities. Oh, sorry. So there's a column here, what you have stressed. So this is written in the paper. So what we are going to support and what we are not going to support. So the developed architecture itself. What's the basic rationale behind of this? One of the typical problems in the fault tolerance area is all the solutions gets very, let's say, overweighted. Very heavy solutions which turns the problem NP. So you can spend lots of time to recover the system. So the idea is to split or to divide, to distribute the solution into, let's say, many instances. So, which means that there's a kind of individual resilience solutions for each virtual enterprise. So, because you have, let's say, many virtual enterprises running simultaneously, so in the case of one instance of the resilience system, for instance, crash, the other ones keep running. So there's no centralized system. Even the resilience system itself is also distributed. So there's no central points of fault. Our, let's say, proposed resilience system controls its own execution. So it's a kind of self-resilience as well. So we have combined many techniques. So actually we didn't invent any new techniques for that. So we just took advantage of the main ones. There's a distribution of responsibilities. What I mean by that is that there's some recovery actions which actually are not up to the SOA layer to deal with. They are of the responsibility of, for instance, the network middleware. A very important point is that one of the techniques, or I mean, one of the strategies that we want to exploit is to replace a service, for instance, when when another one, for instance, gets crashed or have problems. For instance, there are some services running. In the case a given one has problems, so we were trying to find some equivalent one in the services federation to replace this member. And for that, there's a big, let's say, assumption, which we assume that all the services are somehow wrapped using a reference model for business process modeling, which is in this case, in this proof of concept we have adopted the UBL. Basically, what is UBL? It's a set of, it's a huge business process model developed and maintained by Waste, involving 6 to 8 business processes. So in general terms, it comprehends all the transactions necessary in a supply chain, which is a kind of virtual organization. And just to have an idea, what does it mean? In fact, for example, just an example about this business process called ordering. So actually, it's a composition of many individual processes which regulates the transactions between two given members, two given companies. And me as a company, when I develop my services or I have functionalities to support the execution of such processes, so I have different functionalities or services that have to be developed. For instance, in the case of this ordering business process, so one of these 6 to 8 processes, these have 8 different activities, which means that, for example, ordering BP is just a part of the business process that will be involved in a given virtual enterprise. For instance, a real virtual enterprise will involve purchasing, ordering, request of information, so many kinds of business processes. Each one has a kind of diagram like this. And in order to execute each one, so all these services or functionalities should be involved. So during the execution of all this, the resilience system should be, let's say, observing, monitoring what is happening. And in the case of problem, they should try to recover from this. So there are many things to be supervised besides the services themselves. So when you develop or conceive the system, there are many entities involved in this service-oriented global architecture, which means that besides the services itself, there are many other, or some other entities that should be also, let's say, monitored. There are some kinds of, during the SOA composition, there are some activities that should be, let's say, also monitored. For instance, when a service is being discovered and I find a given service, but before it's going to be, before it gets into execution, for instance, this given service can crash. So I should try to recover from this even before the VE gets into execution. And there are different kinds of faults involved in a service-oriented scenario. So it means service and existence, service and availability, and adequacy, so things like that. So all this should be somehow dealt by the system. The resilience system should monitor the VE before its execution in order to guarantee that once the VE is under execution, all the services and all the other systems entities are, let's say, are running properly, and of course during the VE execution. Because classically, most of systems or resilience or fault tolerant systems take care only when the system is already running. The prototype. So that architecture was implemented in a sort of modules where each part refers to, so before the VE is under execution, when the VE is under execution, so the roles or the different actors that should be involved during these resilience processes. Many tools, many ITs and open standards have been used to implement this. This is just to, let's say, to provide a look on the combination of many tools. The algorithm of the resilience. How many minutes do I have? Yeah, all right. So generally, we used this reference model of resilience provided by IBM. So basically, I start monitoring all the processes. So monitor, so this is the M. Based on this monitoring and based on the problems that I have observed. So I try to analyze which kind of event, which kind of problem I have. Then, based on this, I start planning what should I do to recover the system. And then the execute part. Basically, we have what you call expansion cycle. So when I have a problem in a given service, I try to find an alternative within the virtual enterprise. If I cannot find it within the enterprise, I try to find in the VBE federation, and in the worst case, I try to deploy that service. So I have a replica of that service in my own server, instead of trying to execute them in that server, in that original service, in server. And also, I can relax some quality of services constraints. So I assume that once we have made all these actions, the system can be recovered. Of course, there's no optimal solutions for everything. In the very, very worst case, okay, I should, let's say, cancel my virtual enterprise or relax some business requirements, etc. Of course, I will not stress this. I decided to put this just to show that there are some graphical user interfaces involved during this whole process. For instance, an assistance activity to help partners on wrapping their legacy systems to UPL ontology and business process reference model. The running set of XML statements to invoke services, some configurations that I can do to control or to better control the system, a set of alternative services that are found during the execution of the resilient system. So I can choose one, which is for me considered the best one, or even leave to the system to decide which is the best one. So the BPL file generated. So, as I mentioned, the system runs automatically and permanently. So all these graphical interfaces are actually used just to help me to observe what is happening, but they are not, let's say, necessary to be used to, let's say, to run the system. Evaluation. So we are finishing. We have tested this, so we created a kind of, let's say, a hypothetical virtual organization. So it's a simple one, composed by three members. So each one was previously set up with a business process to be executed. So this business process also involves the customer. So there's a transaction where the customer asks something for a given member, and this given member tries to hire two other members to help him to execute what the customer has ordered. Well, I'll not stress at all this. So it's just to show or to explain what was the simulation environment we have developed. So, but it's important to mention we have created 100 simultaneous virtual enterprise. They were created at each second, and there are some constraints in terms of response time. And we have added on purpose and randomly different kinds of faults each second, 30 seconds. So we have tried to perturb the system, and then I try to find new services to replace the problematic ones, or to get that service that is running there and to try to install, to deploy it in my local server. So that's the environment as well. So it's not, let's say, a big environment. So up to 30 gigabytes were enough to support, say, all this scenario. So this is important to say because normally the developed prototypes or models to support fault tolerance and resilience that we have seen in the literature, let's say, they have a tremendous difficulties in terms of scalability. So the more, let's say, virtual enterprise you create, the more memories, etc., are necessary. But because our system is completely distributed, so these problems, let's say, is pretty much decreased. So, in the first strategy, to try to replace, to find a solution to recover from a problem where a given service or a set of services, for instance, get crashed. So the system succeeded in almost 100%, so in this case 98%. So the system could recover respecting the QoS level specified for this virtual enterprise. And in terms of local deployment, in 93%. Conclusions. So we have developed a system or a contribution to a topic that is not much investigated in the literature, combining virtual enterprises and service-oriented architectures. We didn't invent, let's say, techniques for that, but instead we have combined it, adapted, and used lots of them, and then feed them in this large-scale, dynamic, and heterogeneous service-based environment. So we have assumed that partners should wrap their services, so it's a kind of IT preparedness for partners to become members of VB and then to virtual enterprises. So the system, so the results of this prototype showed the potential of this architecture. So this scenario is, we consider as good enough compared to the previous to the results provided by the other systems in the literature that you have reviewed. And of course there are some issues that we could not support. And these issues that we could not support, some of them are these ones. So we are planning to support these in future scenarios. For instance, stateful services, it's a huge problem. So we try to create some contributions to this. So far, our prototype doesn't support anything about security. There's a problem when you are, for instance, trying to replace a service, but if that services are somehow held or locked in to a given technology, for instance, a database, of course, there are some restrictions for that. And to implement the knowledge part of the MAPE model, so far we just implement this part. Knowledge means what we can learn and evolve from what you have, let's say, observed in terms of resilience. And there are some new tools that nowadays have been developed, but so far we have used, let's say, some previous versions. Perhaps in the future we can improve even better, let's say, this. Yes, all right. Thank you.
First of all, congratulations. I think it's a very nice work, very ambitious goal that you have. Yes. One question is, you mentioned that when you cannot find a service in the VE, you can look into the VB. But that usually implies that you have to negotiate with the potential new service provider if they are interested in joining and so on. So how do you link this aspect?
Well, thanks for the question. It's an assumption that we have adopted, is that once you are a member of a VBE, you must, let's say, wrap their services, your services adopting a given model. Once you have that, if you have, let's say, your common working principles that you have somehow signed when you get into a VBE, you are, let's say, you have the willingness or interest to share your services. Of course, there are even some business models that you can, let's say, that can be created out of this, because, for instance, traditionally, you have all your local services isolated in your local silo. And they are there just for your only purpose. Well, but what else, for instance, if you see that I can rent my services to you in order to help you when you are going to execute your system? That service is not yours, but you can, for instance, pay like a SaaS model, in the case you are, let's say, interested to maximize your return of investment that you have did when you develop your service. So you can make profit, let's say, renting your services. Okay, but of course it's an option. Yeah, you're not, let's say, obliged to. So it's just an assumption.
Just a quick question, Ricardo. I mean, you mentioned ontology. I mean, how do you work out the semantic between your services? I assume you resolve these on the fly, or
Yes, well, actually, I'm going to explain this in details in my presentations in my presentation tomorrow. But roughly, yes. Basically, there's a previous phase. So there's one, let's say, a specific module to help how partners should wrap their services and make a mapping with this UBL reference model. So then the semantics part are somehow solved.
My final question was no more question. We had an interesting presentation this morning from Hans Schaffer about blockchain. So the question is, how scalable is your resilience model?
So unfortunately, I could see that presentation, let's say, in the morning. As I tried to mention, so all the parts of the systems are distributed. So when I create a virtual enterprise, so a virtual enterprise is a composition of different processes. For instance, purchasing processes, ordering process, well, many things. Okay. There will be one BPL file, so one execution file for each of this part. So if I have, let's say, hundreds of virtual enterprise running simultaneously, I will have, let's say, hundreds of BPL files in other entities running. Of course, the only problem, to some extent, is the amount of memory that I have. Of course, but if I have, for instance, a virtual machine running on top of many servers, so this problem can be mitigated. The other problem would be if I would have just one, let's say, centralized system, and then the scalability would be really a big issue. That's one of the reasons we have decided to distribute all the architecture to mitigate this problem.
Thank you. Thanks so much. So the next presenter is unfortunately not available, again for the same reason, for visa purposes. So we had a presentation, so this one.
Good morning, my name is Brian Morgan from EMT in Alex.
Can I have an interview, Andre? Yeah, you want one?
Can you sign it, please?
Sure.
Collection of photographic material and qualitative material related to buildings in particular and the state of the building, so the physical system in this case, which obviously was coupled with a preliminary on-site investigation and satellite imageries and 3D laser scanning on site. And then, in particularly for this work, I carried out a specific literature review to have a more detailed idea of what exactly collaborative networks is and how it relates to the urban network in general and to disaster management in particular. And then, based on this review, I managed to identify the dimensions which would be involved in the mapping. And based on this, and in parallel, I've been trying to divide the mapping in different categories and different levels in order to apply them to the satellite imagery. And the final stage, obviously, is the identification of the stakeholders and virtual nodes that have been composing the socio-organizational system in the overall urban network, and then their influence and how the resilience of the framework itself can be improved, acting on a more effective decision-making procedure at the socio-organizational level. So, as I mentioned before, both resilience and collaborative networks are involved, and just for the sake of coherence, I'll provide a very brief definition of what I meant in this situation for collaborative networks. So, collaborative networks in general is defined as a set of autonomous entities which they work, as the name says, together in order to achieve value creation and based on trust and data sharing. And in this case, in particular, dealing with urban context, the nodes will be divided in two main categories. So they will either belong to the social organizational domain or to the physical domain. In this case, obviously, there will be physical entities, so for example, buildings. Instead, the social organizational network will entail stakeholders and technical figures. And instead, resilience is, I think that, yeah, there is plenty of research as we've seen in the previous presentation, and is broadly identified as the system capacity of coping with a disaster and being able to preserve its functionality during and after. So, a brief review over, let's say, the existing literature in relation to collaborative networks coupled with resilience and disaster management highlighted that there are not so many papers actually and not so many researches addressing these domains altogether. Instead, there is a richer literature that involves collaborative networks with disaster management separately from resilience coupled to disaster management. And for example, there are already existing online tools for say, identifying the land uses, and I propose, here the hyperbole of Bologna, and there are several approaches for example, the quantification of resilience from a more numerical perspective, and for example, Musiali here proposes a quantification of resilience based on a multidimensional mapping as well, but specifically addressing the built environment and in a smaller area, let's say in a more restricted area. And nonetheless, there is a shift which is taking into account a wider approach, and there is a strengthening, actually there are strengthening their approach that are trying to address the issue of being able to involve all these topics together. And in particular, the objectives of this analysis will try to, as I anticipated before, it will be to try to understand which are the overarching nodes of the social organizational level and their interaction within the network, and specifically their influence based on the decision and the collaboration between them, the influence that they can have on the physical system, and how this affects the final resilience to, in this case, to the earthquake. And it's so this is the overview of the let's say more in detail of the methodology and in particular of the network that I mentioned before. So the overall urban network, as I said, can be seen as the differentiation between a more virtual network, which is composed of the social organizational entities and the nodes, and their influence on the physical networks, which, as I said before, involves physical entities. So, for example, the structures, buildings, so the infrastructures, and the different energy-related authorities. So, in particular, this figure highlights that the different aspects of resilience and, in general, of disaster response involve different phases. So, in particular, in relation to the disaster prevention, these two networks are strongly related because, as the name says, prevention is functional to try to develop strategy able to cope with the disaster, and we can see the effect of the prevention being mutual between the two networks, because obviously the two systems inform each other specifically in this phase. Whereas over the post-disaster response and the recovery is mainly univocal, because the social organizational network will act on the physical network, and let's say the effects of this will be visible in the following disaster occurrence. And the multidimensional mapping in particular will act in the sense of informing the social organizational network based on the actual condition and state of the art of the physical network. So specifically in the error based one, which is the one that I will consider as a real case scenario, we will see how different dimensions will be mapped, and then they will highlight the influence of the virtual nodes on this on the physical network. In particular, the map dimensions are written in these circles here, and based on the review I identified 5 dimensions, which are basically construction material in general technology, building functionality, damage typology, the infrastructural system, and network and connectivity more in general, and the damage level. So in the center, instead, you can see the resilience phases based on the literature. Again, they are mainly 4, which are disaster prevention, disaster propagation, post-disaster response, recovery. And it's a cycle, obviously, because when the disaster will happen, all the phases will start together and again. So these domains have a different effect on the phases because, for example, like the construction material will mainly be influenced by the constraints that, for example, the stakeholder and the local authorities will impose on the designer, and obviously this will have a strong impact on the final design of the building, and obviously the final design of the building will be the one that will ensure the building to be resilient or not when the disaster will occur. And obviously this, let's say, the overall building structure will be affecting mainly the 3 phases of disaster prevention, disaster propagation, and the recovery. In particular, disaster propagation, there is nothing apart from the building itself, because once literally the building has been realized, is the only element that can actually done with this technology in place, the propagation of the disaster. And when obviously this phase starts to be affected, we will have the damage level, so the damage occurring physically to the building. And in particular, where there are more domains occurring at the same time and overlapping, which means that there will be obviously a stronger need for a collaboration between the different social organizational nodes in these particular areas. So, for example, the more important, we can say that are the prevention and the post-disaster response. And this is consistent with the general disaster management, let's say, methodologies. So, looking more in details at the maps, the first one that I'm presenting is the road network and connectivity. So this is the area of Old Bayshore, the central area, because the northern one and the southern one are not accessible because the infrastructural system was completely not viable. And as you can see, the road network are mainly constituted by 1 road and 1 secondary road, with just a tunnel that unfortunately collapsed. And the main issue in this case was that both ways the roads were affected by rockfalls or they've been destroyed, and even the emergency rescue systems didn't manage to access the area, and this obviously led to a higher amount of victims, and the civilians themselves had to actually act in terms of to replace the emergency rescue services. So obviously this shows and highlights a strong lack of planning prior to the design, because this type of infrastructural system entails that at the planning level there was a lack of collaboration probably between the urban planners and the local authorities, because probably a wider planning and a wider study between different connections between the city would have probably led to a higher level of connectivity and redundancy of the infrastructural network. And the second map I'm going to introduce is the one that relates to the damage, and in particular I put, but it's not necessary to go through this in detail, I just put it for information. This is a qualitative damage scale that I developed based on review of the ones that I cited here, and I identified mainly 6 level of damages, and as you can see, the majority of the building, and let's say even more than half, if not almost all of them, they basically achieve the highest level of damage of the qualitative scale, and this is due to the fact that there were very poor construction technologies in place, and in particular this is also visible from the damage typology, because the damage typology and the damage level are consistent in the sense that the buildings that encountered the highest level of damage, in the sense of structural damage, they were the ones who actually also were either indeterminate in terms of damage typology, or in encounter foundation failure. So indeterminate means that they were so damaged to the point that it was impossible to determine which was the cause, so they basically reduced to debris. And the foundation failures itself, it's quite clear that it entails a complete lack of geotechnical investigations prior to the disaster, because some of the buildings, for example, they basically sank in the soil. And obviously, from a collaborative network point of view, this highlights that at an overarching level, so at a more planning level in the urban network, there was a lack of, again, of collaboration and strategy between the different authorities, and probably the financial constraints were so tight that the designers themselves were unable to introduce more stronger technologies, or for example, provide piles, considering that it was like a liquefaction prone soil. And the other map that I analyzed and I developed was related to the building functionality. In particular, what I wanted to highlight was if there was the presence of any strong stakeholders, so in terms of public buildings or public infrastructure in the area, which was not actually the case, because the majority of the buildings were residential with a few buildings for education and some cultural centers and a hospital, but in the southern part of the city. And it's quite relevant to highlight that no fire brigades were highlighted in this area, no fire brigades were identified. And this is quite relevant because usually, specifically regarding strategic buildings, which are usually compulsory in building regulations, they are designed for a longer lifespan, which means that they are supposed to be able to cope better with the disaster and have obviously more, let's say, stronger technologies in place. And this was not the case, especially for the school, which were completely collapsed. The last map that I want to show is related to the construction material, and that was basically functional to highlight whether there was, let's say, a correlation between both the financial constraints and the budget holders' notes that might have influenced and might have affected the overall level of resilience. But in this case as well, there was no correlation, so an overall lack of collaboration, an overall lack of resilience in general was highlighted. So the majority of the building were reinforced concrete frames, but they, as you probably have seen from the map before, they had the same level of damage more or less regardless of the construction technology in place. And so moving to the discussion and the conclusions, overall, an overall lack of collaboration at the socio-organizational level has been highlighted, and this obviously shows that there is a lack of planning and a lack of strategy in the sense of understanding the vulnerability of the area and trying to understand which is the best strategy to cope with it. So in this case, the multidimensional mapping was particularly useful in the sense that it provides a useful methodology to understand in different contexts, because obviously it's a methodology that can easily apply in other different contexts, to highlight which are the faults at the higher level, not just obviously dealing with the physical system. And obviously this highlights as well that especially in this area, which maybe they don't have the same financial means of stronger communities, it's important to sensitize the local community and the social organization and everything in general in order to foster a more comprehensive strategy in addressing resilience and not just relating to one domain, but addressing the influence of the different actors and the different nodes within the overall urban network.
When you mentioned the relation between the social organizational network and physical network, my understanding it could make a lot of sense. But then when you gave the example of the physical network, you included there the water management authorities, the gas authorities, and then I got confused because these authorities are not, let's say, physical system. They should be in the other layer.
I don't want to make it too much physical, so I try to be more generic, but obviously in this case is more regarding, let's say, the networks themselves. So, for example, the energy networks, the infrastructural networks, so the piping, physically talking, which obviously can lead to disaster chain as well if it's not well managed.
The authorities should be the other layer, right?
Let's say that, I think that, in this case, probably yes, but I try to make it a bit more generic in order not just to, let's say, mention network every time and try to be a bit more comprehensive in regards to other aspects as well that might have been, I guess, important in that domain.
Thanks for your presentation. Very nice talk. By the way, I'd like to talk with you later on because I'm working on this subject too. But my question, well, I have, let's say, some questions, but I'll stick this one about governance. So, because all these actors that are involved in a given asset, right? Well, they have different levels of power, information access. You know, how this can be controlled, or how do you intend to manage these different powers?
You mean how influencing is each actor in the sense of the overall result?
Exactly.
I guess that is probably very site-specific because there might be, let's say, local situations and situations in which, I don't know, a specific actor is more important or is more relevant than the other one. Yeah. I guess, that is something that actually I didn't consider here, but it's something that it might be interesting to involve, because I think that in the context of China, for example, the government is very strong and it retains a lot of information, so obviously the power that the government has in that context is particularly relevant. Maybe in other situations in which the sharing of information is more available, other authorities have, let's say, more power as well, and let's say the overall information is more available in that sense, and that's why probably collaborative network is so important, the topic of the data sharing, because obviously who owns the information obviously have the power to do things with that. So for example, one of the problems that I had in that context was finding the information practically, and I had to rely, let's say, on the satellite maps or even like some signs that were in the site and they were indicating which building was what, because it's very difficult to find, for example, for structural analysis, even the maps or the plans of the buildings and the details. So I think that, it's a very interesting topic and it might probably have to be considered like separately. But it's true. Thanks.
Just to elaborate between on the governance, which is a very interesting question. I mean, because the case study is in China, and so you did mention the problem of access to information. Everything is closed. We're dealing with the system. So I think it's a big challenge in the context of this research, and maybe that's I fully agree with Ricardo. It's an avenue for further research. But the question, which I'm opening up here, how do you operate in an autocratic system where access to information is closed and access to systems is very opaque? So I don't know whether you have had any solution in that respect. Based on your experience, because you've been to that site, you visited the site, and you talked to the authorities.
I think that, my solution was try to find as many information as I can in everything, basically, that I could see, which might be too simple, but that's the only solution that I have, because obviously when you can obviously have information in other contexts, you try to gather information through what you can see and through the things that you have already available. So I think that obviously in other contexts, for example, in which, I cited the Imperable in Bologna because I'm from Bologna as well, there are online maps and it's quite easy, I think, in France as well, in Germany. There are more open communities in which you can find online the information that you need. but that's obviously is too simple. And in that case, yeah, I think that it would be probably, let's say, it would be probably important that the researcher, I think as well, would address this kind of topic in order maybe to kind of lead these communities to be a bit more open and try to make more, and try to sensitize the people and in general the governments to share more information and obviously make the technicians able to cope with the specific vulnerabilities of the sites. Because I guess that obviously if, in that case specifically, since the soil was I think a particularly relevant topic, and the majority of the building collapsed because of foundation failures or differential settlements of torsional behaviors, which obviously were caused by a lack of geotechnical investigations or the very trivial adoption of a suitable foundation system. I'm sure that this is something that can be avoided, but again, it's very hard to understand whether the fault is of the technician himself that, obviously made a wrong design, but I think that might be too simple. And probably the fault has to be found in a, let's say, a wider perspective, I guess.
Is you aware that one thing is to have access to information? Yeah. Another thing is you to be allowed to have access to this information, including problems due to regulations. For instance, the health area. So you cannot have access to many things.
Yeah, exactly.
Things like that.
Yeah, sure.
So this closes our sessions.
The first one will be presented by João Vilas Boas, and he's going to present the innovative enterprise architectures for deploying product services systems in SME.
Okay, cheers, thank you very much. So good afternoon everybody. I'm coming from Isqueté, Lisbon. I'm João Vilas Boas, and I'm going to present this assignment that was the topic of a thesis of a student of mine in the Masters. So this has to be with a very simple question. We are referring to companies in the ornamental stones sector, small and medium-sized companies, and there was this question about servitization, and I'm going to explain in a minute. So does it mean, does it make sense to use servitization for small and medium-sized companies in that situation? So we decided to develop a process of inquiring in order to answer to these questions. But a process of inquiring that approached the problem in a systematic way, as complete as possible, and in a supportive way. Okay, so we built first a module and so on. I'm going to explain that later on. Okay, so this is the agenda for the session. A typical traditional agenda for a research assignment in management. So I come from a management background, and I'm working on the interfaces of the areas. Okay, so that's why I'm here. Okay, this is the slide to position the context for the situation, which, as I told, we are speaking about small companies in ornamental stones, traditional familiar companies. And the case study is going to be a supplier of technology, advanced manufacturing technology. So when you see AMT means this, AMT is SME, advanced manufacturing technology, small company, okay? So the context that is being into place is more hostile, which means more complex and more difficult in general, due to globalization, and this has an increasing effect for small companies. So instead of the companies buying the technology, and the technology was more sophisticated and requiring continuous updating, there was this idea, why don't we make a kind of change between buying a product to a service. We pay a fee or rent per month or whatever, and the technology machinery, mainly we mean, belongs to the supplier, and we don't have those problems of dealing with technology, and we can focus on our business. Okay, So this is the context. Servitization means this, okay? The progress from a business model which is based on selling products to a business model where I buy a service, okay? So, as I was saying, the purpose of this assignment is to develop and test a conceptual module for supporting the development of the process of inquiring. This process of inquiring, we were expecting as an outcome from it the possibility, because we are in a project in industry, the possibility to apply it as a diagnostic tool. But a diagnostic tool not in the sense that consultants do, which is they don't have to justify anything, they just prescribe solutions. As we are in research, we are in academy, we said, okay, no, that's not our job. We have to provide an inquiring tool for making a diagnostic, but support it. Yeah? So that's why we developed this module that we call the enterprise architecture based on after Gartner semantics. Yeah? So this enterprise architecture, okay, here it is made up of three main activities or processes. Yeah, this is also supported. Everything is supported here. So this is based, for instance, in the Design School of Strategy, which was the first school in strategy, or also called the Harvard School. Yeah, where when we have a strategy, the next step is to implement it in a structure, in an organizational structure. Then if we visit the organization theory from a more sociological background, we see that one of the parameters of decision in the organizational structure is the technology. So you could ask, but why is it outside? Why was it made explicit? Because it is so important in this case, so we decided to provide some biggest level of relevance. Okay, so this is the approach we took. Yeah. Okay, strategy where we deal with the servitization thing because it's a new business module. Where should we position it? Here. Then there is an impact in the organizational structure. Which organizational structure do I need to support this business model? I can make a quick parallel with people that are supporting car breakdowns. Yeah, there is a network when I have a breakdown, so someone goes there and sorts our problem. So here it is the same thing. If I am a supplier of advanced manufacturing technology, one thing is to have customers that I have to support once or a while. The other thing is the technology belongs to me, which means that I am responsible for the technology to be always up, always working in proper and good conditions. So if something goes wrong, I have to be there immediately. Yeah? And I am a small company, I cannot do that. So what is the logic thing? To build up a collaborative network. That is the only thing we can do. Otherwise, how do we sort it? And then, of course, this collaborative network must have some specific technology for acquisition of data, because I don't want to let the machines be down and then go there after 2 days and fix them. No, I want to anticipate, if possible, the eventual breakdown. Yeah, so I need data. Big data, massive data, being broadcasted, yeah, internet or whatever, Internet of Things. I need sensors in machines to acquire the exact data that I need for my diagnostics. I need to process those data. I need to make my decisions in order to avoid machines to break down. So this is the reason why we then are going to, why we isolate this, and we are going to treat this in this new paradigm of Industry 4.0. Okay? So, propositions coming from the literature review. So we take a hypothetical deductive approach, which means that before, in advance, we must set the propositions or hypotheses. Hypotheses don't make sense here, so propositions are statements like hypotheses, but their purpose is to be discussed. The hypotheses are to say yes or no, and that does not happen here. So our propositions are, of course, to see if the so-called product service systems, which are another way to name servitization, are feasible and desirable for that situation that I've been telling about. Not only for the supplier of the technology, the service provider, but also for the customers, the industrial companies. Yeah. So, and what about collaborative networks? Yeah. So after the literature review, we concluded what I was saying that is described in that second proposition, and as well as the story about the technology that we call here digital business platform because of semantics, it's more adequate and so on. Okay, so is it required to support the collaborative network or not? Yes, we say yes, it is, because we all were reviewing the literature, and it is required also. So it does have a double impact. Yeah, it is also required for supporting the servitization. So we could say this is the push effect of technology, but there is a pull effect, because I cannot implement the strategy without technology. So I'm pulling technology, but technology itself, it provides a push effect. So we used a simple technique, data flow diagram, to, as you can see, these are exactly the same processes or activities that were in the previous boxes, but now they were expanded in sub-activities. Okay, so these processes or activities are the structure of our module. But then we are worried about the behavior, the dynamic behavior, and that is given by the flows, yeah, coming in and going out of the processes, because they are information flows that are transformed. So this is data flow diagram. It's flows of information that are represented here. All of this comes from the literature review. All of this is defined, yeah, and it came from the literature review. That's why I keep on saying it supported our module. Is it the best in the world? No, it isn't, for sure. Is it the only one in the world? No, it isn't, but it's our module, and it is supported. Okay? So we argue for its relevance. Okay? That's the best we can do. You had 3 propositions, yeah, but there were many more. But of course, I couldn't bring all of these here. Sorry about my Portuguese here. It's just to give you an idea. So this is just to give an idea that all these propositions are defined from the literature review, and then they were grouped in those 3 main categories, which I brought to this conference. Otherwise, we wouldn't finish in 1 week, perhaps. As you can see as well, we have those categories that I mentioned. We have those propositions initial, if you want to call them like that. And then the same comment to the research questions. Yeah, they were grouped in those 3 ones. This answers to a question that the reviewers made me. I had 10 reviewers, so they were very suspicious about this. So they asked me, why 3 research questions and 3 propositions? This is very, because it was a summary, because actually they were in a different number. If someone view that asked that question is here, they were different. But for convenience of the presentation, I summarized them to 3 of them. So it was okay. Then I said, okay, we are going to establish a process of inquiry that is supported. Here it is the linkage between the questions in our questionnaire and the propositions. Yeah, of course, this is just the overview, yeah, an outline, but this is done in the thesis. You can consult it. It's public. It's in the library. If you wish, it's in Portuguese, unfortunately, but there is a connection. Okay, so. It's supported when we go out to try to ask, for instance, to run a diagnostic to see, okay, let's analyze the situation of this company, yeah, as regards what we are saying. Servitization, is it adequate, and so and so. Does it have the conditions for a collaborative network, etc., etc. So we know which questions we are going to ask. Of course, that we can adjust them to the situation of the company. Some will be left out because it's a quite extensive question. Okay? So I already spoke a bit about this. It's an interpretive research paradigm, approach technical deductive, case study to try to those questions and those propositions came out of the literature review. Now we are going to the case study. Why? To try to not to confirm, but at least to discuss, to run a very previous exploratory discussion if in practice or in the field things at least are not conflicting with our ideas coming from the literature review. Yeah. So this is now we pass to the empirical case study. Yeah. This is a picture of the company. Yeah. Okay. A few data about the company. We called it Alpha. So it's a company that is it's established in the worldwide market. It exports most of the production. It's advanced machines with all the abilities to communicate, to loaded with sensors to gather the data they think that are relevant, with the ability of communication to communicate those data and so on. Okay? So at least at the lowest level, we do have some of the companies already, production, industrial companies in this case, already have the proper equipment for implementing whatever we want to do. Yeah? Okay, so now we are going to try to cross the propositions or check the propositions according to the findings. This was summarized for the paper, and here it is even more summarized, but it's just to give you a flavor, otherwise we'll go out today and I think you have more important things to do in life. So, as you remember, first proposition was products and systems are feasible and desirable for SMEs and for service providers, each service providers and customers, because there is a convergence of interests. So this was what came out of the literature. Yeah. When we were discussing it in the case study, we found out that servitization can have two stages. Yeah, we could say a basic stage, which is about adding up services to the product, but in that case, I still sell the product. Yeah, the product good, physical, yeah, the machine, yeah, but I have other stages, yeah, like with the photocopying machines. Today nobody buys a photocopying machine, yeah, we just buy the outcomes of it, yeah, okay, or we can assess it not for the number of copies, but for the results that I reach. So those are the two more advanced stages of serialization, and in that case it concerns service. I don't buy the product physical good anymore, I just buy the service provided by it based on the judgment of the results or the outputs. Okay, so we found out that the service provider, the advanced manufacturing technology SME, was already, and the customers, they were already offering services to complete the product, but that was not our point. Yeah, so there is still a requirement for what I call the advanced product service, which is really the second stage. Yeah? And there is room for that. Okay? And there are conditions for that, as requires the basic technology, which are the machines. Yeah? This would improve, of course, the competitiveness of the companies, because the industrial companies could focus on their business, which is about cutting and transforming. How long, sorry? I have 5 minutes? Okay, cheers. Which is about transforming stone and not dealing with technology. Okay? Moreover, there was some kind of transference of the experience in developing a technology from the shoes industry by that manufacturer, advanced manufacturer supplier or provider, which is already does have experience in this field, and if some factors, some risk factors would decrease, because we are speaking about small and medium-sized companies. I didn't say this, but servitization is for a while already in the marketplace, but just for big companies like Rolls-Royce, the power per hour, where they sell power paid as a service per hour. They don't sell anymore the engines and so on. Okay, but for big companies that is possible, but for small companies this is an innovation, because it hasn't been studied. Okay, so. And some reasons are here, because there are factors of risk, yeah? But, so if we act on the factors of risk, or at least if we are aware and try to avoid them, it is a factor on an advantage, okay, to know that. Second proposition about collaborative networks, yeah? Through virtual organizations and virtual organization breeding environments and so on, okay? So, the hostility of the marketplace, which means more complex and not so simple. The hostility of the marketplace led to that situation about the servitization as the new strategy, but that strategy required the virtual organizations, the collaborative networks by the end of the day. Yeah. So discussion. We have experience from consortia in this sector. Yeah, from developing projects in consortia to address the co-creation of technologies and so on. So this could be an advantage as well. And these consortia are already working in a kind of collaborative situation that is not exactly a collaborative network, but it can be developed into. So, that consortium includes not only the suppliers of the technology, but the customers, but even competitors and so on. That are competitors, of course. If there are several industrial companies, they are competitors. So associations of the sector and so on. So all those people, there is only one way they could articulate in a collaborative way. Because it's not anymore possible to develop the technology individually. So the task of these new technologies is much bigger compared with the previous one. The previous one was already big, which was about equipments, put the equipments more advanced with the sensors and so on. But this one is at a meso level, we could say, a higher level, at a higher level, and evolves much more. So it's impossible to do it individually. The only way to do it is in that way. I'm arguing for. The last research question, the last proposition, sorry. Is about technology. So the digital business platform, does it make any sense? So according to Gartner, there is a structure that should be followed, which is first, when we are going to speak about technology, start by having a full picture of my company, of the business. Otherwise, the technology can misfit the business module, yeah? So that is the enterprise architecture. Then there is the business architecture that in our case, it is the product service system or servitization, if you wish, yeah? And then it comes in our case, the collaborative network and the solution, the technological solution based on Industry 4.0 and so on, because it does have all the elements that are required for supporting the collaborative network. Yeah. So by the end, conclusions. Research questions were satisfied. Yeah. Yes to the first one, it's feasible. Yes to the second one, it's matches the challenges, collaborative networks, yeah, and we understood the role of technology, yeah. So there is a theoretical contribution. We argue that is our enterprise architecture, which was represented by that data flow data flow diagram. Research contribution, it's the systematic process of inquiry that I just outlined here. Practical contribution is a diagnostic tool that we can apply to assess the situation of a company and to check if it makes sense to go in that way or not, or to assess the gap and to say we need to achieve that purpose of implementing product services and whatever, we need this and that with some kind of support, with some kind of safe somehow. But there was an emergent finding, which is this data digital business platform, yeah, together with the collaborative network, does not only support the servitization, it could support other innovations in the business. For instance, we are also speaking about building information modeling. Yeah? And we are starting to work in building information modeling, and that is possible to do as well, because with the same VBE, the same virtual organization, virtual breeding environment, where that could generate several virtual organizations, some for PSS, others for building information modeling, so on. Okay, so this is an overview of my conceptual view of the digital business platform, where we could form it, for instance, in an automatic way. When there appears some kind of opportunity, I'm just going to finish, some kind of opportunity, automatically we could suggest some scenarios with the resources from the several organizations, or even professionals, or even from outside.
This is the first paper in the session, and I'm going to present our work done on the ProVE project related to virtual collaboration to support building information modeling for energy efficiency. So, in relation to the theme of the conference, which is collaborative networks, I think creating virtual environments is something that is now very important, especially in the construction industry, as there's a new paradigm to be implemented in the near future called Industry 4.0. Now, what Industry 4.0 means, nobody knows, but essentially virtual collaboration is something that can support the delivery of this Industry 4.0 vision. So I'll be very short. I'll introduce the research, I'll give a background on the BIMIT project, explain how we've created and how we've used virtual collaboration to deliver the objectives in our project. We'll explain some of the analysis we conducted as part of the project, and we'll conclude at the end. So, BIMIT project is a EU project looking at training for construction professionals. So, in construction, there are a number of very hot researching topics. One is energy efficiency and what are the methods to accomplish such energy efficiency. Now, recently, there's a lot of implications, and there's a lot of research conducted in the area of how can we use modern communication technologies and modern computer technologies to inform and to deliver this energy efficiency paradigm. Now, BIM is greatly addressing some of the benefits in the construction industry, and really what we're researching in this project, what are the methods and what are the solutions that BIM can deliver in order to complement or to support energy efficiency in the construction sector. But in order to do that, we need to find a number of skills and trainings and competencies for construction professionals which need to be BIM compliant. Now, BIM tries to leverage on ICT and building information modeling to upgrade the skills and capacities in the EU construction sector. Now, a segment of this work is presented in the paper, and it looks at how can we use virtual collaboration to create a BIM community of professionals that can enhance skills and enable BIM training, and more importantly, applied for the discussion today, is to enable in-depth analysis and gaps identification of skills and competencies involved in BIM training for energy efficiency. Okay, so what is important is there are two main objectives, right? So what we want to demonstrate really in the BIM project is to demonstrate the role of BIM in achieving energy efficiency. This is quite novel. I think BIM in isolation has been researched over the last decade. It can deliver a number of benefits. It can greatly support the exchange of information in the construction project, but the direct implementation for energy efficiency hasn't been entirely investigated so far. And the second objective is to determine what BIM trainings are required for professionals which later can support and deliver this energy efficiency for the construction sector. So for instance, I would like to understand what are the main roles which are required to deliver a BIM-based energy efficiency strategy, and what are the skills and the competencies associated to these roles for the same objectives of delivering energy efficiency. So obviously in this BIM sector there are some gaps and there are some problems, there are some unfinished directions which we want to initially determine. Based on this, we want to propose solutions and later on to create or support a portfolio of trainings which is accessible to the entire construction industry. Now, these are the steps really that we've approached in creating this BIM for energy efficiency agenda. So we wanted to open an online environment for consultations. We wanted to aggregate really some BIM knowledge and create a community of BIM professionals. Then we wanted to use some smart techniques or intelligent techniques which can facilitate the aggregation of this BIM knowledge and BIM data sources, and we've implemented this via a web crawler. And then we developed this framework of use cases or best practice use cases in the domain of BIM for energy efficiency in Europe, based on which we draw some conclusions and propose some new trainings and some new directions. So this is the virtual collaborative platform which we have developed. This is a research project that goes on in the last more than 6 years now. We've adapted this for to build really a data source or knowledge repository for BIM professionals, and we supported all sorts of things. We're supporting, for instance, a professional networking widget where professionals can participate and can be invited to contribute to this community. We have some tools, we have documents in relation to BIM for energy efficiency. We have a building and information modeling widget which contains a set of use cases as we've aggregated from the entire European countries, and we have a training widget. So I'll discuss this virtual collaboration and BIM services and BIM crawler aggregator. So the idea is to create this online ecosystem where users, practitioners, industry actors can register and can access information in the field of BIM. And then by this access, they can actually develop a set of skills and competencies to achieve a specific BIM profile. So the virtual collaborative platform has a web crawler which fetches information from a number of sources that we've identified and we've validated by a community of experts. So, for instance, you can see that we're fetching thousands of pages from different sources, and this really represents our knowledge repository, BIM knowledge repository, based on which we can assess skills, we can propose trainings, we can locate trainings, and so forth. So this is one of the underpinning services. The other feature of this is the network of users. So we have a community of users now, a few hundreds of users. They are registered and they contribute with their content, and they have access to our expertise. And more importantly, this is facilitated through the solution of social networks. So what we've done is we asked ourselves, for instance, I think BIM can have two dimensions. A dimension is static, where you have a the construction project. You have a BIM level, but BIM is something also very dynamic, and can be dynamic in the requirements part, but also can be dynamic in the solution part. So capturing these dynamics can be really, really important. And what we've done, we used social networks to capture these dynamics in the BIM and to create a community of practitioners and experts. So at any moment in time, a user goes to the platform and can search for other fellows in the field of BIM, of course on a particular interest, and it can access the Twitter and the LinkedIn profile, and then this is how we create this community of users and professionals in the domain of BIM. There's also this is also something that can be exploited later on by looking at the network graph and understand what is the degree of correlation between one BIM expert and another BIM expert, and which are the roles they are associated. And what this virtual environment also supports is a training repository and locator. So BIMIT project, the vision of the BIMIT project is to deliver training for professionals in order to address different aspects in energy efficiency. So what we have here, we have categories of trainings, and users can subscribe to these trainings, which come from all over Europe, and they can locate them and determine whether this training is addressing a skill or a competence that needs to be improved. Now, I think there's one side of the virtual collaboration. The other part of the virtual collaboration and this dynamic environment is to aggregate content and use cases, best practice use cases as identified in Europe. Okay, so in Europe there are a number of projects that have been in this field of energy efficiency. Some of them they've used BIM, some of them they haven't used BIM. What is important for us at this stage is to determine which are these projects and what aspects of BIM have they used, and what was the impact of BIM in this energy efficiency project. And based on this, we can draw some conclusion and understand, and then propose some trainings, or whatever strategies are required in order to improve energy efficiency. So this is the template that we use to collect the best practice use cases for BIM. This is a model of our collection template where we're looking at different things such as use case type, target discipline, building type. We're looking at objectives, life cycle from RIBA, and impacts. So briefly, this is how a use case looks like. This is a snapshot of 2 use cases that we collected. This is the repository of use cases. Of course, this is slightly larger. We have now 41 use cases that we use for the analysis. And these analyses are supported by energybim.com platform. So if you want to access this is the web address where you can register and add your suggestions or utilize the functionality as you like. So the first type of experiments that we conducted is to look at the objectives that these BIM use cases had associated. So for instance, from this portfolio of 41 use cases, we've identified that some use cases some projects they look to minimize operation costs. There are 9 use cases looking to minimize energy consumption, minimize carbon emission, minimize energy comfort, optimize energy performance, and there's very low interest in exploring the healthy buildings concept or dealing with energy profiles or water objectives in big projects. Now, when we're looking at use case type analysis, we found 4 different categories, mainly 3. So research and development was the majority of projects that are now going on in Europe. There are also 13 projects that we've identified as being real-world applications. There's one utilizing BIM guideline, and other projects haven't been identified. Now, when we're looking at building type analysis, so the question is, what was the type of the building used as a demonstrator or as a pilot case in that particular project? We found that BIM has been applied in 26 projects for public buildings, 7 for domestic buildings, 4 for commercial, and 3 for industrial projects. We've also looked at project types. So BIM is in majority applied for existing and new buildings. There's very few application of BIM for renovation and extensions. So for us this is important because 5 minutes. For us this is important because we want to understand what sectors of the industry we need to cover and what are the solutions to implement in order to cover those sectors. Now, we're looking at life cycle and life cycle assessment. So we wanted to see, to which life cycle stage a BIM project has been relevant or associated, and we see that majority of projects we apply for concept design, develop design, technical design, and in use. There's also very few interest in strategic definition or handover construction phase. And when looking at impacts, obviously a project, an energy efficiency, a BIM for energy efficiency project must have an impact, right? So it can use a technology, it can use some research findings, but it must have an impact. So the impact was reduction of carbon emission, increasing of energy saving, optimization of energy performance, and few other very interesting things, one of which is saving water and also saving time. So this is also something we're taking into consideration. Now, I'll simply discuss one more. So we wanted to also assess impacts, okay? So we wanted to make a correlation between impacts and, for instance, life cycle, and see impacts and the discipline, and impacts and the building type. And for instance, when we've measured impacts in relation to building types, we found that
the highest percentage of impacts come in the scenario where the BIM has been applied for public buildings. And there's very few impact when BIM has been applied for commercial buildings. In the other scenario, when we looked at the discipline, we found that for facility management, management is very popular and has great impact. When BIM is applied in architecture design, facility management, structure engineer, we found that great impacts can be achieved, including 50% savings in energy and 50% savings in water consumption. So I'll go straight to conclusion now and say this. The future is on virtual communities and collaboration, ideally with integration with Internet of Things, but creating communities of users where practices and knowledge can be shared and acquired is very important. In this paper, we demonstrate how virtual collaboration can be applied in the ISC domains, in the ISC construction, to determine gaps and requirements. We have recorded use cases, best practice use cases for BIM for energy in Europe. And really the question is, how can we integrate such virtual collaboration with Internet of Things and deliver a vision for automation in industries, this so-called concept of Industry 4.0. And probably another open question is how social networks can represent a reliable source of knowledge to inform developments of the projects or propose new solutions. This is the end of the presentation, and I'm waiting for questions.
Yes. Thank you. Thanks for the presentation. I have one question because what I do is I do research about energy information systems, but in manufacturing environments. And so, what we, or one of the topics that we do a little bit of research on is how to improve energy efficiency, of course, but not on the building scope, but within the processes. And if we are able to capture the data and drill down on, let's say, on component level of machines or on certain behaviors of workers, we can derive best practices, and hopefully in the future we will be able to derive those best practices somehow automatically, so that we can share the knowledge on energy efficiency best practices either within a big corporation or maybe even from company to company if they are willing to exchange. And in your experience from your use case research, do you think it's also possible to derive best practice energy efficiency based on the data that you have from the different building projects? So maybe right now you have a lot of public buildings, but maybe if you have a look at certain aspects, it's possible to derive best practices for commercial buildings as well?
We're actually looking into that. I think it's pretty much what we're trying to do. So aggregating knowledge in specific aggregating methodologies or solutions that have been implemented by others can be really innovative. So what we're trying to do now is, obviously, when you're trying to build something generic, for instance, right? So, for instance, understand about a particular concept or solution for public buildings and see whether this is transferable to commercial buildings. What you can do is you can look at commonalities, and really what we're trying to do is to increase this portfolio of knowledge or use cases as much as possible, cover as many domains or criteria as possible, and then try to specialize the solution or trying to propose solutions for other type of applications. Now, from what we have so far, we've looked into scenarios, right? So when you do energy efficiency, you have scenarios. So, for instance, what you can see is for a public building, you know, some scenarios are very common, and you can understand whether those scenarios can be transferred to industrial buildings or for other type of projects. But I think one of the problems that we encountered is that you cannot cover all the sectors, and secondly, you cannot find enough statistical, enough statistical evidence to say that your research is covering all the options, and your conclusion are generally valid. So I think this is something we've recorded use cases, but with the majority in public buildings and especially in existing projects. But what we are unsure at the moment is whether there are some other fields and some other aspects which we haven't covered. So, of course, the more your knowledge repository increases, the higher is the accuracy of what you propose for some other projects, and the better you can deliver a vision. This is what I found so far on this. I don't know if this somehow answering.
Yeah, it's okay. But because what we do, or where we try to limit our scope is exactly that we say, okay, we do not cover the building itself.
I see.
So that's why I was really interested in what are your findings.
So yeah.
In the context of your community, do you have any automatic mechanisms for assessing the quality of contributed knowledge?
More or less. That's a good question. So, when a user suggests a data source, a new site, for instance, from where we fetch knowledge, right? That particular source may not be valid, may be a fake. So what we've done, we've used professionals to validate that. So a source, we've received in our database a web address, but we investigate that prior to integration in our platform. So the moment when the crawler is applied and fetches information, we have a high degree of confidence that that particular source is relevant for what we do. So we've used experts, a community of experts from our portfolio of users to validate this, and furthermore, we've applied this for our ontology. So we've also validated the ontology that underpins this. For instance, a particular correlation between two concepts, for instance, BIM and energy, or BIM and skills and training. So experts have amended our automated ontology with their specialized knowledge in the domain. So I would say we've managed to cover this, but this is something that is interesting. Yes. We do rely on experts, yes.
Okay, thank you.
Hi everyone, I'm Joy Tani. I will present an optimization algorithm, the distributed optimization algorithm. This work is done at CAA East and supported by the two European projects, Pentagon and Cardiff. In this presentation, I will begin with an introduction that highlights the renewable energy sources used, and its advantage and disadvantage, and the need to a tree generation network. After that, I will switch to present our contribution of based on multi-agent systems and an optimization algorithm. And finally, I will finish by a conclusion and feature. So I will begin by the introduction. So now, in order to minimize the pollution, many countries integrate the use of renewable energy sources into energy systems. These sources are green sources, but on the other hand, they are intermittent resources and depend on the weather, like shown in this picture. So it depends on the weather, on the time of the day. Sometimes it stress the grid. So because there are many production, so there is a need to curtail energy. In order to minimize this issue, a tree generation district is needed. So a tree generation district is a district composed of three types of networks: the electrical ones that produce electrical energy, the gas ones that produce gas energy, and the heating ones that produce heating energy. So actually, in the literature, there are two networks connected together, but in our research, we connect three networks together via converters like heat pump and boilers, and we use storages like thermal storages and electrical storages. The thermal storage store water in order to satisfy heating demands, and the electrical storage store energy in order to satisfy electrical demands. So by definition, our goal is to integrate the renewable energy sources by minimizing the intermittency disadvantage, and by optimizing energy prices. This is done by using storage systems and tree generation network connected via converters. And in order to optimize energy prices, we use energy management algorithm in order to increase efficiency and coordinate all energy sources in the system. And it is done in a distributed way using multi-agent system. And to optimize, we use the ATMM algorithm. These two, the multi-agent system and ATMM algorithm, will be presented after. Now I will talk about our contribution. So this figure shows our system, the multi-vector energy coordination network. So as shown here, our system is composed of an electrical network shown in the blue. So in this electrical network, we have electrical utility, we have some renewable resources like PV, like wind, and a district storage. And this electrical network can be connected via power to gas to the gas network, shown this one. And this gas network can contain gas utilities, and it is connected via power to heat. For example, for power to heat, we have a heat pump to the heating network, and the heating network must contain, for example, consumers like baseline loads and thermal storage. And the heating network and the electrical and the gas network can be connected via gas boilers, and we have a gas CSP that is connected to the three types of networks. So we use a multi-agent system. Why a multi-agent system? Because we need a distributed algorithm. So a multi-agent system is a system composed of many agents. An agent is a software entity that is autonomous, so it controls its actions and can take decisions without taking into consideration the other decision of the system. It is proactive, so it can react within its environment, and it is social, so it can interact with other agents to achieve its goal. So we implement our multi-agent system using the ADMM algorithm. Why we use the ADMM algorithm? Because this algorithm can fragment the optimization into little optimization. So we can take less iteration to have the optimal solution. So the ADMM is composed of a net and a device. For us, a device can be, for example, a baseline load, or an external tie is a device. And a net, for example, it can be the electrical networks, the heating network. So the device and the net can do their optimization locally and send the prices, because we have to minimize prices. Send the prices to the net, and after when we have the optimal solution, they adapt this optimal solution. So if we go back to this picture, we can see, for example, for us we have we have an agent for each device. So the electrical utility for us is an agent. The district PV is an agent. Here the net is here. This one is a net, and this one is a net, and we have agent on nets. So we have to optimize the global objective function. So the global objective function is a function for devices and nets. So we have to optimize this global function. Then we have to model the devices. In this research, we take into consideration the thermal storage model and the converter model. So the thermal storage model is presented here. So the temperature at time t is related to the temperature at the time t minus 1, and some losses and some efficiency and power exchange. And for the converter, so to explain, converter is it relies two networks. So a converter, it can be a device in two networks. So it is an agent. Can be two agents, so it is an agent for this network and an agent for the other network. So the converter, the equation of the converter is here. So it takes an input, a power in input, and according and multiplies this power with efficiency and take it as power. So the device minimization problem is done according to this equation. So we have to minimize an objective function and send it to the net. And the net minimization step is done. We have to minimize an objective function for the net, and after we arrive to the optimal solution, so we adopt it. And now we simulate using J. We simulate two types of scenarios. The first one that we connect all the three networks together, and the second one we disconnect the three networks together. So we simulate, we test the price for three networks and the price for each network. And here the parameters of the scenarios. And now we can see that for the first one we test the cost for the electrical network and using scenario 1 and scenario 2. So we can see for the costs that are increased for scenario 2 because we use this energy to convert to the heating network. After that, we can see the cost of heating network. We can see that the cost of heating network is 0 using scenario 2 because it uses the converted energy from the gas network or the electrical network. And after we test the cost for the gas network, we can see for the scenario 2, the cost for the gas network is higher than the cost for the gas network using scenario 1 because in our assumption here, the cost for the gas network for the gas utility is much lesser than the other utilities. So it is used to be converted to heating network to electrical network. And after we tested the total cost for the networks, and we can see that when we connect the networks, the cost is minimal. As conclusion, in this presentation, I present our distributed energy management algorithm in a three-generation network. Our proposal optimize prices and maximize the renewable energy use, and connect the three networks. As future works, we plan to use a closed-loop controls that take into consideration at each time slot the perturbation caused by the system. So, and take it into consideration for the decision. And thank you.
What is the role for collaboration? We have collaboration with companies that are the owners of the different energy sources or not?
Yes. It is companies that own for example here, companies that own the electrical utility, companies that own the gas utility. So that's why we have prices here.
Is the collaboration also the level of the devices?
Yes.
What? Some big sensors, some like this. Simulation, but the simulation it was supported by the information system. The simulation that they performed was supported by an information system that did not understand the speed.
Yes. You talk about
Any more questions? Okay, thank you. We proceed to the next presentation by Colin. Proceed.
Good afternoon. My name is Mohammad Wasim Ahmed. I work as a research fellow at Cardiff University. The work that I'm going to present is part of one of the projects that Joel presented. It's Horizon 2020 project called Pentagon, and the title of the paper is Real-Time Energy Management Platform for Multi-Vector District Energy Systems. So when we talk about energy consumption in different sectors, then buildings becomes one of the top consumers of energy consumption. So overall in world, if we look at the figures, 40% of world's total energy consumption is consumed by the building sector, and the 30% of the total CO2 emissions are coming from the building sector. So in order to reduce this energy consumptions, there are different solutions. So one solution could be to use decentralized energy infrastructure, because they can increase energy efficiency. They also reduce losses, and they also allow us to use co- or tri-generation systems within the energy infrastructure. The other way of doing or reducing energy consumption is by using different renewable energy sources. But some of the renewable energy sources also introduce a level of uncertainty into the energy supply system. For example, your wind turbine systems or PV system. Therefore, the management of these highly complex multi-vector district energy system which is operated quite oftenly by different stakeholders, including different consumers within the network, is a vital challenge to overcome in a fragmented energy landscape. So all these different stakeholders, they work together with the same or similar objective in mind, that is to reduce energy consumption, or to reduce gas emissions, or to maximize human comfort within the buildings. But there is another challenge, which is because now these days our buildings are equipped with so many sensors. For example, a simple sensor within a building, within a room, could be the CO2 concentration monitoring, or it could be the dynamic facade sensors and actuators that are fitted within the modern buildings. And these sensors and actuators, they come from different vendors, and they use different communication protocols, which make it even more complex. So in order to overcome this challenge, there are different technologies available. So one of them is ontologies or semantic web technologies, which can improve the interoperability while reducing heterogeneity and can facilitate rapid exploration of information. So this allows us to easily fetch data, do knowledge discovery within the data, and discover different relationships between different modeled entities. So the proposed energy platform in this paper, it uses semantic modeling to allow interoperability of different data sources, which might be coming from different sensors, actuators, or different modules within the platform, and provides an additional level of robustness to energy management of multi-vector systems. So before going into detail about the platform, I just wanted to quickly describe the project. So the project is called Pentagon, and it aims at paving the way to new generation systems of eco-district, and by enhancing or by using different energy conversion technologies or system, and also by using a high-level integrated energy management platform. So there are three sub-objectives. So first sub-objective is to boost the efficiency of power to methane. So in this project, we are some of the partners are working on power to gas, power to methane plants, so that we can increase their efficiency. And the other objective is to deliver a versatile and energy management at building and district scale to enhance the energy network synergy through the provision of multi-scale IoT energy management platform. And once we do all these things, once we develop these two things, then we demonstrate and assess their performance on both on simulation scale, and also doing some experiments on a laboratory scale district networks. So the energy management platform of Pentagon consists of 4 main modules. So I will briefly go and talk about each of them. So first is smart connector. So it connects with the district energy management system. So it acts as a translator. So it gathers the required data from the district energy management system, and also it also translates. So once we optimized and we have optimized set points or optimized schedules of different equipment within the building, then this smart connector also interpret and apply these control strategies and make it available for the district energy management platform. The other module, which is prediction module. So as we know, the predictive analytics play an important role in the management of multi-vector system. So therefore it is very core component of smart thermal and smart electric grids. In Pentagon, we use artificial intelligence techniques to predict different key performance indicators. It could be the energy generation from different renewable energy systems, or the consumption of different buildings or a district overall. Then we also have multi-vector system, multi-vector optimizers, which Joel talked about. So it optimizes different set points and schedules of different equipment within the district energy system. And they have different objectives. For example, it could be minimizing the cost or CO2 emissions within the district, or it could be maximizing the human thermal comfort within different zones of the building. Then once we have optimized set point available, then we have to find out whether these meets different constraint within the electric grid, because we don't want to unstabilize the electric grid. So we have to check whether they will meet different constraints of the electricity grid. So there is another software or module. This is internal to another partner who are involved in the project. It's called Smart Operation. So this module then receives output from prediction and multi-vector optimizers, and based on these outputs, it checks different grid constraints. And if these grid constraints are within the limits, then these optimized values are being translated back to the district energy management system through smart connector. So in order to do that, we have a domain model of Pentagon project, like of a district that we deal with in the Pentagon project. And this data model is made up of different type of information. So for example, the typology of different networks, so it could be heating network, gas network, or electric network, and associated any parameters, whether it could be for the optimization modules, or it could be the parameters of nonlinear model of smart operation. So the way user input all this information is in an Excel template. So the engineers who will be running the simulation and analyzing these results will be running different scenarios. Will be filling this Excel template file, and then this Excel template file, which is the model of the district, will then be uploaded into the database. So therefore, it is in this way we try to be very flexible, and it's very fully configurable, so that it's very easy for the engineers to work and run different scenarios on the platform. As we deal with very sensitive data, so it's the energy consumption information of different consumers. So we would like it to be very secure. So in order to deal with this, there are two types of authentication that we have, or measures that we have taken. So first is it's secured through username and password. So they have to enter username and password for each user to log in. And also this communication security is further enhanced by using HTTPS protocol. And just to mention the semantic information or semantic modeling that we are doing for sensor and actuators and their data. So we use an existing ontology which is called semantic sensor network ontology to describe this data obtained from different sensors and meters within the district. Just will quickly go through this. Pentagon data model is we try to deliver or drive interoperability with and within the platform by maintaining consistent semantic throughout the whole Pentagon stack. So it is from the APIs that are exposed to different modules to the database, underlying database that we use. This is a very simple representation of some of the entities within Pentagon model or district model. So just to give you an example, for example, we have a district model in between here, and this district model could have different equipments. For example, in this case, what I'm showing here is it has two converters. So it has two converters. So these are semantically represented. And then these two actual converters could have different properties, different attributes, and could have different sensors which are represented within the Pentagon data model. So once it's developed and it's nearly there, so what we are the next step are we would like to implement this on two pilot sites. So one will be based on the simulations of Egovan Eco District, which is in Wales, and the other experiments will be run on CA in its facility, which is in Chambéry, France. And on simulation, we have used different simulation tools. For example, in order to simulate the heating network, we have used Modelica library, and so we can model different equipments of heating network. And for electricity, we are using smart operation of tractor. Just to conclude, in this paper we presented a platform for intelligent management of multi-vector system, multi-vector energy networks. The platform, as I said, consists of different modules which are coordinated through a shared semantic understanding of a given energy network. We also believe that the platform will enable different social entities to collaborate and effectively manage district energy consumption. And it will also allow to shift from reactive rule-based control to predictive and anticipatory control by using different modules, for example, the prediction modules of Pentagon. And this is, as I said, this is achieved through a combination of real-time data retrieval and organization through the smart connector prediction module, deployment of advanced optimization technique, and adjustment or to real-time grid constraint through simulations. These all modules are underpinned by a center coordinating ICT infrastructure. Thank you very much.
So I'm currently doing preparation for a smart city project, and I came across the issue that it's very hard to get the data from sensors, not because of the technical problem, so you will explain there's technical solutions, but because people simply don't give the information, or organizations don't give the information to, let's let's say, a platform like yours. Do you come across this problem as well, how to manage?
Not on these projects, because we have already assigned agreements with these partners. But the thing is, the issue is real, because obviously this is very sensitive data to different building owners or energy managers. So they will always be reluctant to provide you this data. So the way we could achieve, or we could do that, is to you anomalize this data, so that you don't know if this data is coming from which building, and no one else will know about this. So this could be solved by this way.
Do you this approach as well? So if you use cases legislation,
No, not in this project, but we have done another smart city project.
Yes.
How can actually, when it could service involved, of course, I know this is zero funded, there's one thing that you do, you see and you for that.
I think
what you've done is like a whole system. This is not really the quality needs, but also being obviously one thing that puts in our looking at how we can drive optimization through those having insights and feedback to humans, business, culture, and that will actually help development. That's one how you fit this to
yeah. So obviously we can't exclude human. They are an important part of this this whole energy management. So, and also the behavior of human has a quite good impact on energy consumption. So in this project, we are not dealing with this behavior aspect of different human within the building, because we are looking at the overall district. So we are not looking into each building on its own. So we are managing district or different district as a whole and their generation unit. But obviously this should be included in
this display.
Yeah. Yes. Yes. In this project, we are there is an interface, but it's very command line interface. So it's not very user friendly, because this is not requirement of the solution at the moment. But obviously, in another project or within our group, we have another platform or the same platform, but we have developed user interface which is quite advanced.
If I talk to my colleagues of Pascal energy engineers, they will tell me that, okay, this is a problem of control, distributed control, and most optimization. So they don't need quality networks at all. So if I want to convince them that quality networks can play some role here, what is your answer for this? What makes it different from just traditional distributed control?
In here, as we moving towards smart grids, so there are different entities that are involved within the management. So, for example, a district energy network might be managed by a company, but the electricity is coming from another company. There might be another company which is bidding on the electricity by using different prediction models, for example, developed within the project. So they can use these prediction models to predict electricity price and bid. So there are different social entities or physical entities that are involved, which can collaborate by using this platform to actively manage energy of a district or multi-district.
Also consider collaboration of the consumers, where to add control device?
This is something where we have to keep in mind. For example, we also have to convey these control signals back to the consumers. For example, if there are equipments which are specific to the consumers, like for example within the building, then obviously either they give us full control. If they are not giving us full control, then obviously all these controls should be translated to them, and based on their experience or their preference, then they are free to make these decisions. So whether they want to implement this control, or whether they want to step back and say we don't want to do this control, this may harm our comfort. Something else?
As I understood that we have different operators using the platform, and the goal is to have one optimized solution, not only for the one district operator, but also for the next operators. And now my question is, because on the part of looking at energy consumption in the factory and trying to predict that, for us it's very hard, it's a challenge to define the right level of defining our simulation components or our prognosis algorithms. So I can try to have it on plant level or on a manufacturing line or build a single machine, and in terms of building I can try to model the building or everything, the air condition inside the building, or so on and so forth. And I guess if we put such a system into practice, probably the key challenge is also to limit the maintenance of the system, so that you still have a good, high quality prognosis, but like I said, a limited effort to keep the prognosis model itself up to date. So how did you manage that challenge so far, defining the right level of the prognosis model, not going too much into detail?
So for this, so for example, there are different ways we can model. So are we talking about the data model or the physical model of the buildings?
Well, probably more the physical model, but the models that you use for doing your energy consumption purposes. I mean, it's not directly the data model that you have to use, but yeah, the physical model that you use to derive the energy consumption purposes.
Yeah. So for here, for example, we came up that there are different ways of doing it, but for example, for building energy consumption, there could be a detailed model, for example, different software like Energy Plus that we use, and there are different data-driven models that we are currently using within the project. But we found that for detailed model, it wasn't very realistic to run real-time optimization on physical models, because they are very detailed, and that's what wasn't required for this kind of application. So that's why we went for the data-driven model to model buildings and different equipments.
But then you still have a data model per building, so to say. So we have historic data for each building, and then you have some kind of neural network or some other engine that you use for that?
Yes, we use data-driven models, like neural networks or random forest for different techniques.
Thank you all for being here in the session. Next is you want to participate in what tour, and as far as I know, is 6 at the Cardiff indicator for the after the unit on those who contact my call, let's say, operation at 7:30.
news about
Habe ich jetzt die Videos auch gesehen, aber Zahlenstecker reicht nicht für die
This registration process was a bit chaotic. To pay the registration, so it was very strange. Participate, someone has to pay. Yes. So I assume maybe the situation in university is a bit the same. But I always assume that how in this message from the university? Yes. The paper that he sent was very nice. I mean, thought-provoking. So I was really looking forward to his presentation. Yes. Yes. Okay, let's see through the session.
that somebody in the breakfast room said, well, I'm going for breakfast. I said, hey, we have our 9 o'clock. No, breakfast now. Business as usual. So this is low and
Okay. Good morning. Good morning, everyone. And today we are in the first position session. It's a relatively new idea developed by Louis and Hamida. The idea is that we have two presentations today with a substantial amount of time for interaction and discussion. I will do my best to moderate it. Among the audience and the speakers. And we have two speakers today, as I said. The first speaker will be Volker Stich. Volker Stich is professor at the RWTH Aachen, managing director of the Research Institute for Industrial Management, if I'm right, FIP. And he will speak about the need and solution to transform the manufacturing industry in the age of Industry 4.0 capability maturity index. So thereafter, we will have the talk from Americo Atlepelo, he's coordinator at the UNESCO University in Portugal. So I propose we just start with Volker speaking about this topic.
Thank you very much,
Hans.
Hans. Thank you. Thank you very much, Hans. So, good morning, ladies and gentlemen. I'm very happy that you are the group who has been here on time. I know somebody else who is still at the breakfast at my hotel saying, I'm coming later on. And I promised him I don't repeat what I'm doing right now here. So, good morning to everybody. My name is Volker Stich. Thank you, Hans, for this nice introduction. And thank Louis to the new idea to give Americo and me the chance to talk about what's going on outside there, what's going on outside in industry, in our surrounding around us, and what's going to change. And the big question is, and you can't say we don't have to deal with this, is how looks our future? Perhaps like this? We don't know. Smart commercial buildings, big buildings, perhaps
We know digitalization is a new normal. Those of us who are having kids, we know that they are not able to survive without any mobile. And please remember that the iPhone has just been sorted out 10 years ago, no longer. So to the older of us, the big question, how did we succeed in surviving without always being connected? So you see here the babes are already on this. And we are thinking about new technologies like additive manufacturing. We are thinking about additive manufacturing on the moon, on the surface. So complete things which change and are changed by new technologies that were made possible. Around us, the world is changing. The world is changing. Now we are in UK. I don't say any word about Brexit. But the world is changing. So we have new balances. We have a speed. We have a balances in economics. We have new competitors. Those of us who have been in China or in the eastern areas, we know that there's real competitive growing up. And we are living in we call this a VUCA world. VUCA world means it's volatile, it's uncertainty, it's complexity and ambiguity. I did give you some examples, volatility. About the companies dropped out in Fortune 1000 index, there is an in and out. And those of us who are engineers, who are related to asset-oriented companies like BMW, Bayer and others, we are absolutely surprised when we are hearing that Google and Alita are worth more than 1 billion on the bourse, which is nothing but on the asset, but on the expectation of the business of the companies. Complexity, I just can take Mercedes, I just can take others. These are no longer cars, these are running software platforms. If you're looking into your car, and if it's not an old car, you will see that most of the points in this car are sold through internet, connectivity, and all these so the software development costs of these rolling chassis for the internet are exploding. Uncertainty, my beloved one. 1% likelihood for Trump to become new president of the USA, without any comment on this. So this is in terms of how to be able to predict what's going on and how to predict what will be the next situation. And ambiguity, just look, ambiguity being both sides, not having a concrete decision-making process. 1998, only 20 years ago, Yahoo declines to buy Google for 1 million, only $1 million US. You should have been in this business. Yahoo offers 4 years later $3 billion US for Google, rejected. 2008, 10 years ago, Microsoft offers $40 billion US for Yahoo, rejected again. And 2 years ago, Verizon to buy Yahoo for $4.6 billion US. You see, there's not a concrete, like we love to decide on being engineers. A plus B is C. There is some fluctuality and there's a speed of what's going on there. And this speed leads us to a point that we have been discussing yesterday several times. I was very interested in some of these very, very good presentations, tackling to the point of agility. What is agility? We are coming from the age of flexibility. When I was a young engineer, our saying was doing budgeting, being flexible. Then we had to adopt to rising market. So I was working for a French company, and you know French companies, they love to do budgets. Quarterly budgets and all these. We never met the budgets, but we were flexible enough and adaptive enough to follow our budgets more or less. What today is going on is what we call agility, disruptive and uncertain business system. That could be the curve, for example, for bitcoins. Those of you, I don't expect you that you have invested in bitcoins, I do not hope, so otherwise you lost already in this year 35% and more. This is a typical curve that we are naming under agility, which is learning for real-time behavior, speed, speed, speed. You can't wait, oh, let's see the next 5 years. You have to speed up, act versus react. You can't wait until something has happened and then say, okay, I will adopt. And holistic decision-making with the speed to implement, to realize. And I think this is one of the points that I will be highlighting later on again. The digital transformation started focus on the internet, that's for sure. Nobody of us could say or deny that he's not connected. Nobody of us can say that he's not LinkedIn or whatever. This morning I got a charming LinkedIn. Thank you very much for this wake up on LinkedIn. So this is absolutely normal. Shaving and LinkedIn. So we are in these platforms, and these platforms like Amazon, Google, Alibaba, we must remind they are asset free. If you compare Google and Amazon, 40, 50,000 employees, with a Volkswagen, 500,000 employees, and it's 20 times more worse than an asset-oriented company. We must understand that the mechanism of these platforms coming from the Silicon Valley is completely different compared to the mechanism of an asset-oriented company that we are, all of us, dealing with and have to deal with. And that leads me to the point that the digital transformation in manufacturing is not a matter of fact of startups. Companies tend to help themselves by speeding up, to join a startup, to buy a startup. But the digital transformation is not the mechanism that we could see and learn from Silicon Valley. It's completely different. And this is what I want to go in my further presentation here. The EU is always picking up the finger saying, you have, you should, there's a high potential. I think all of us, we have read all these studies, and we're wondering why industry in Europe is so hesitating. Because EU, the digital transformation of EU business presents enormous growth. Wow, that should be a starting point. If somebody's telling me it's enormous growth, normally I start into it. Second, the European industry can build on its strengths in advanced digital technologies. Yes, ladies and gentlemen, we are not starting. Sometimes we are listening to those saying, okay, you are in industry 1.0, 2.0. No, the European industry is deeply already in the digital business. The only point which is missing is turning value out of our digitalization efforts. This is the last point. We are big in Internet of Things, big data, robotics, 3D printing. We know about the technologies because we are engineers. What we don't have understood is to turn this into the value of the end customer who is willing to pay for it. We are still selling a machine. And it's very hard for us to understand that the end customer doesn't want to have a machine. He wants to have a service, he wants to have an added value. It's not worse to sell a harvesting machine like Klaas is doing. The farmer is not interested in being the owner of a beautiful harvester machine for 500,000 euros. He is interested in optimizing his harvesting results. And that sometimes gives us the problem to shift our mind in this area. So currently EU businesses are not taking full advantage of these advanced technologies. That's correct. But, the big but, we have the chances. Just look at this. The digitalization is an almost unlimited network of objects. See here in this 2008, only 10 years ago, for the first time we had more connected objects than people living on Earth. In those times we were only 8 billion people, and we are rising. But the rising of the object will be much steeper. This is a study coming from Cisco and others. They are telling us the same. We will come up to about 50 billion of these objects until 2020. 2020, ladies and gentlemen, it's tomorrow. We are at the end of 2018. So the possibility, the technological, is there. Second part is, if we are looking about maturity in the asset-oriented companies, yes, media and commerce, they are far up front. Nobody of us is still collecting these beautiful black-labeled Schallplatten. I even don't know the translation of a Schallplatten. Huh? Long play record, huh? Something like this. I have still drunk off. I even don't know the translation of it. We are streaming. We are streaming. We have thousands and thousands of musics on our iPhones. Healthcare and mobility, yes, they are speeding up. If you are looking at healthcare and mobility, last mile logistics, if you're looking at infra-urban problems and how to solve them, if you're looking at electric cars, we're speeding up. And production and energy, well, just let's call them friendly followers. What we have seen, we have done some cooperation because we were interested in an worldwide study, what's going on really here, to understand what's going on. What we found out, that currently the automotive, the electronics and the process industry have the highest maturity level. So we measured this on a global scale. We had a global study with an Indian IT company, it's Infosys. Most of us, we haven't heard about Infosys. Infosys is just a small IT company from India with more than 400,000 collaborators. Wow. We came to contact them and said, what? Never heard about Infosys? And they said, yes, we are worldwide active, and could you do, together with us, this study, which shows the impact and which shows a certain kind of asset-oriented companies. That leads me back to one big question. We have heard, and following here, beautiful presentation projects. But those of us who are working in industry, those of us who are in close relation to industry, if we're coming down to the shop floor, do we really know what's going on our shop floors worldwide? No. We are doing a high amount of planning. We have a high amount of IT systems. We have ERP system, MES system, all kinds of systems. But what's really going on the shop floor, we don't know. What is the transfer times fluctuation? What is the overall equipment effectiveness of a single machine? We are not able, which machine currently produces which order. And last but not least, I was in charge for a long time for the planification of the Saint-Gobain plants. And I know that planification is just turning an assumption into an error, nothing else. If you hit the pace, if you hit exactly the number, the quantity, it's just a stochastic event, nothing else. Because there are so many influences here on quality. Somebody who is ill, the machine is out, the maintenance has not been done, that you will never come up and reach what is your planned situation. And the big problem that companies are facing today is to optimize the throughput, to understand the deviation from the planning, and then what to do to come back to the planned optimized situation, which is coming back to speed, changing constantly. So, being able to generate knowledge out of data, we decide on winner or losing. That means reliable data, integrating, synthesizing data in real time. We had a very good discussion yesterday evening on the quality of data. Ask yourself and your customer about the quality of the data. The quality of our data that we are having today in our production plants is awful. If it's correct what I'm telling, that the number, the volumes of data are increasing, and we don't do anything against the quality raise of these data, we will be producing, sorry for this shit. We can't rely on this data. We have more data, but relying on data in terms of pattern and big data analytics should rely on the stage that the quality of the data is okay. So data analytics, data visualization for decision support needs a certain amount of quality on this data. And we decided yesterday evening that could be a topic to go in, because this is a starting point before a company goes into their journey on digital or industry 4.0. Our way of thinking, this is a way of thinking, a small model that we are trying to follow in Aachen, is why should a company go into industry 4.0? Because they want to raise the business value, and the most hindering part is what we call the latency time. I'll just give you an example. There's a business relevant event. Let's say that's a machine that has been planned for production for tomorrow morning from 10 to 12. The machine starts, and after 5 minutes you have a breakdown. Typical, normal. It takes us, we call this data latency, very long time to understand until the event data are available. Maybe minutes, half an hour, and even up to a shift. Then it takes us, the analysis latency, a certain amount of time to understand what has happened. Is this just a matter of solving the problem in 2 minutes? Or is it a big breakdown that the machine will not be able to produce for the rest of the week? The decision latency, again, is until we have understood what action we should do. Repair it or not. Take another machine or not. And that, you know, takes another time. Big discussions. The man, the experienced leader on the line is saying, hey boss, believe me, my stomach is telling me everything is okay. Do you believe him or not? It's a bit between experience and data. And until we have the action accomplished, we have all this time which has been consumed until, fortunately, the machine is running again. And if you turn this, in the sense of speeding up and optimization, into a relationship to Industry 4.0 elements, we can say the Internet of Things connectivity and the real distribution will reduce the time of the data latency. We will be much quicker on a reliable basis that we come to understand something is happening. Possibly business analytics and big data, artificial intelligence and machine learning topics could help us to reduce the analysis latency, to understand what has been happening. Yes, for sure. This is a typical domain of us as being researchers. This is not driven by companies. That could be driven by us. Machine learning. If you're talking to our industrial guys and you're talking about artificial intelligence, they're looking at you and, well, at least they're smiling. But how to turn artificial intelligence and machine learning into the optimization that's here. Or assisted work automation of decision processes could help us the decision latency to reduce it, and vertical and horizontally integrated software and cyber-physical systems can help us to implement, to reduce the implementation latency. So it's all about, and that's shown by, that should be shown by this thinking frame, it's all about the stepwise approach. Sometimes we are talking to companies who have been attending to a conference, and the CEO of the company is saying, okay, now we are going into the cyber-physical systems and platforms. Well, good decision. Because they didn't understand that if you're following this bit by bit, then you can reduce the time. Let's stay with an example of the machine breakdown. And if you reduce the time between business relevant event and the action accomplished, and you spare this time, this is added productivity without investment. It's added productivity where the machine is running, let's call it preventive and predictive maintenance, running much quicker again, and this is added productivity. And this is a real sense of Industry 4.0. It's not being cyber-physical systems able to talk about. It's the optimization and it's the speed of the productivity of our asset-oriented companies. So that means that information is a key enabler of the digital age, connecting systems and users. Because without this glue, we will not be able to handle through the next steps. We are calling this, you know, from the 6 R's, from the physical logistics, having the right object at the right place and all this. We just transformed it in the 6 R's of information logistics. Having the right information, which is pretty difficult. We had some beautiful talks about this yesterday. Having the right information at the right time, at the right place, for the right recipient. The recipient and CAO recipient is completely different to a workshop or a workshop player. In the right quality at the right costs. And that leads us to our thinking, coming from the raw data, we must gather, we must store, we must analyze, and at the end, we must be able to visualize. This is the decision-making process. I'm not talking about emptying the workshops. I'm not talking about making everything autonomous. I'm talking about that in an increasing complexity of our companies and production source, we should help our colleagues in optimizing the deviation from planning, what has been planned, in terms of how coming back to the optimized path again. And this is what we call the decision support systems. We derive it from there, an approach that we is a majestic we now. That's not us, that's not only us, but these are about 50 professors coming from informatics, material, machine, all these. And these professors, they have risen up this framework saying, okay, if a company is going for this new approach, they have the development cycle where new products and values are developed. They have the production cycle, the value turning, and they have the user cycle. This is after selling a product. So these are the typical 3 cycles. Developing a new product, producing of a product, and perhaps here addressing to your partner by smart services, digitalized services through platforms. Second part is that most of our companies, production and manufacturing companies, are deeply involved in this. We call this the raw data and the expert system. So we have product data, CID data, simulation data, process data. We have an enormous amount of this because we as engineers have been working on this since 40 years. SIM, computer integrated manufacturing, our first attack in the early 90s, where the PC power was not enough. So we have been thinking about this, let's say, 40 years. The expert systems is now in high concentration in all companies. So we have the PLM, PDM systems, we have the ERP, MES solutions, and we have CRM and CRQ solutions. So if we are entering in our consultancy business into a company, we are always asking, how many IT solutions do you run? And the answer is 1. They are lying without trying to lie. There's one core, yes, there's one core, sometimes coming from Waldorf or elsewhere. But normally a company of today has about 25 to 35 not integrated IT solutions running on the place. And now coming back to the quality of data. Could you imagine what's happening if the bad quality is not integrated with this solution? And this is what we are going for, what we are trying to develop. It's a middleware plus. We are no longer thinking about data warehouses. We want to establish a middleware plus, which is the management of data access to proprietary systems. Then the overlay should be defined, whereof we are talking about the digital shadow. There is no one digital shadow. There are digital shadows for different purposes. A digital shadow for maintenance of machines is completely different compared to a digital shadow for economic issues or for sales and after sales. So how to do this through correlation, clustering and data modeling to end up at the end on the smart expert, which can support by decision support systems which are event driven, which are more or less able to be autonomous and which could be supporting us in adaptive processes. And again, I'm not talking about getting rid of our colleagues. I'm talking about using the possibilities to end up at this higher level to reduce the latencies in being more productive in our manufacturing areas. Companies are facing tremendous problems when implementing IT, so we are doing a lot of studies. IT projects are enormous, and all of us who are dealing with our customers on IT projects, we know that they are neither in expectation, nor in time, nor in budget. All IT systems are more or less trying to be in line. We have resistance to change from the employees, and we have the lack of resources. Normally a CEO says, hey, Mr. Lütgendorf, you are my guy for my, sorry for this, I know it. You are my guy for IT. Please take over this IT project, which is a new ERP solution, which is a new MES. But thinking in a total way on an IT strategy, what kind of strategy helps me in terms of formulating the path towards Industry 4.0? It's a completely different thing. It couldn't be done by the day-to-day business of an IT office. It must be done by those who are absolutely experts, who are experienced in project management and know about the new possibilities coming up from the technologies. Early adopters, we have been, during the last year, very often in China, and I don't want to menace, but I'm menacing. These guys are quick. They have a central plan, which is called China 2025, and if they decide to invest money in a certain topic, they are not investing money like we are doing in the European Commission with a water can. They're going for it. The battle on artificial intelligence is already done. When we are dreaming that we will play an important role on artificial intelligence in Europe, well, first we decide on this, thank you, Mr. Macron. Then we are building up a building, which takes us 3 years. Then we are putting people inside to start thinking. The battle is done. So the battle will be done and the artificial intelligence between the US and China. We see UK, German-speaking countries, and France, that we have early adopters which are reduce, and the rest are followers. And in this business of manufacturing of tomorrow, a follower is the one who is just grabbing on the rest, which the early adopter hasn't just forgotten. That's the case of the business. So, the fully digital and agile business require high transformation costs, that's for sure. Following my small slide on latency of adjustment for the Industry 4.0, we must take into account that we are now, and Hans, you mentioned this yesterday, interdisciplinarity. The form of interdisciplinarity. This is not a battle for IT guys. This is not a battle for engineers. This is a battle which is on resources, on information systems, on organizational structure and culture. Why? You can't come back from a conference telling, okay, now we are going for Industry 4.0. The rest of your group will laugh at you. You can't come back and say, oh, I've understood now what a cyber-physical systems is meant by. We have just two new colleagues, data scientists. A data scientist himself, it's nothing worse. It's only the combination between a data scientist and the use case. The data scientist is the one to use the tool, but he needs somebody who is very experienced in the use case, in the shop floor, in the real case. And both of them working together. 5 minutes? I just started to get warm, okay. So, these are tremendous costs, and sometimes companies are hesitating when they are understanding that they are, through Industry 4.0, not reducing costs. At the end, the performance is high. At the end, the output is higher. But first, there are transaction costs. You have to invest in the qualification, in the culture, and into the organizational structure. So, from there, we were very happy that in Germany there's a very famous AKTech, German Academy of Technics, Technology, Science and Engineering, thanks to my Portuguese friend who knows better about this. Thank you. And this architect is normally supporting Ms. Merkel and his politician groups in what should we do in Germany to become more competitive. They were rising the first step about 7 years ago already, Industry 4.0. They launched a small booklet which you can find on the internet, which is very interesting. It's only 60 pages to read about supporting action in Industry 4.0. They understood that the second part should be smart services, and we got the chance, now it's from here, to develop a maturity index for this AKTech on Industry 4.0 purposes, which is now used not only in Germany, and we are proposing this, we are inviting you, it's a maturity index to measure what is the position of a company actually, and from where we can derive the next steps towards Industry 4.0. The main thinking is that these are stepwise. The computerization gets started, the connectivity do the business, then the visibility, please remind again the latencies, is get inside, build a real-time digital shadow, then the getting and being able analytics in terms of having transparency, tearing apart the linen which is just covering my shop floor. So this is the run data analytics, understand effects, then being able and prepared for any kind of predictability, preventive maintenance, preventive sales. And we had a very good example from our colleague from Poznan yesterday. I don't know if it's here. I like this presentation saying, okay, we are doing preventive in marketing and sales in retailers. And at the end, being optimized, then going for optimization in terms of the adaptability. So we have a 6-step approach. Just in short how it works: computerization, connectivity, visibility, transparency, and adaptability is the development paths. And what we develop is let's call it a questionnaire. It's not a platform-oriented self-assessment. You can't do it on yourself. It's not helping companies on a strategic level saying, your company should be. It's on the shop floor level. It takes us about 1 week to go on one shop floor of a company and understand through this questionnaire behind this, in these different levels, where this manufacturing site is actually, what is their situation in terms of the digitalization. We have these 4 dimensions that I just mentioned: resources, information systems, organizational structure, and culture. So we are looking at this. And this is for sure, you might understand why this is not a self-assessment tipping on the internet. If you're doing this on a self-assessment, all of the companies will be 4.8, 5.5, that's for sure. And the repeatability of what they are seeing is very, very, let's call it subjective. So we are doing this in workshops, going this, and behind this there's a questionnaire like this, just giving an example, and then we are hitting 2 points like horizontal integration, system transparency, and user interfaces. We have done this right now on an international basis. We have about 25 companies compared, and now we are able to search out the most important thing, and this is a digital roadmap. And if you want to talk about the digital roadmap, you will see that companies are finding a lot of projects normally. That's all of us who are doing consultancy, it's normal. Huh? We advise you, we support you, we would like to help you with this project. But the idea behind this is that we are allocating these projects in a very precise consequence, what you should have to do first, and what are the next projects. This is a digital roadmap. That means blue, green, yellow and red are projects relying to organization, IT, resources and culture. And you may laugh or not, but companies very often lack the possibility to understand, to pass from A to the end, what kind of project they should do in a certain consequence, one after the other. One of the first projects very often is personal development, you see here. Yeah, you must be clear about the skills you need, and then you're going through this. After now running more than 20 projects, we have found out that there's a certain kind of pattern in this project aligning. So if you're doing this several times, you understand that companies more or less have to follow a similar path. It's not the identical path, but there is a similar path. Which are the projects allocated to connectivity, which are the projects allocated to visibility, and which are the projects allocated to transparency. And the assortment of this project, they are getting a more and more similarity. That's why we are interested in partnering with other countries. We just had a proposition for Portugal, for example, for your, in Portugal it's COTEC. And COTEC was asking us, and we are very happy that we are able to pitch. They are needing for maturity index. We are just coming back from South Korea. They are needing maturity index. So we have partners worldwide. It's not a Nobel Prize approach, that's for sure. But it's proved. It's a pathwise approach, and it helps companies to define for themselves the speed how to go through this digital roadmap. You can imagine if you're a big company, you can have all these 20 projects in 1 year. If you're a small medium, you can only afford the first 3 or 4 projects related to resources, time, and prices. So the speed of the companies is relevant for this. And this is what we are going to. We are finding how companies are in the situation. We are helping them, not we are doing everything. We are partnering and giving hints to come up to have a decision which are based on likely future scenarios. So this is a link between what I just wanted to sort out here, between what is coming up, and we have understood through new studies that companies, as soon as we have first a prototype, these are the top performers in all kinds of digitalization. So it's not a company like we are, educated engineers, just end up with 120% of the solution, then come to the market and present a solution that nobody is willing to go for, being the last one, being quick on the market. Coming to the end, last minute, 30 seconds, 45. Conclusion 1, the problem. Transformation means fundamental pattern change in your head, in your mind, in your IT. And Jörg Hoffmann, he will report on this in his presentation today on our idea of the Internet of Production. We have trained this ourselves. We have developed an electro car, not to have an electro car, but to understand the pattern change, and even our young researchers, they have understood that this pattern change is a fundamental pattern change in terms of thinking. But this path is irreversible. You can't start a digitalization in your company and say after 1 year, oh sorry, we are going back to lean. Conclusion number 2, the problem is how to design and implement an organization which is smart enough for future. Most of the companies are working on operational excellence. Most of our companies have in invested a large amount in lean management, continuous improvement. Yes, for sure, this is operational excellence. But the innovation leadership with this new potential that we have heard very beautiful presentations yesterday about, agile innovation, open innovation, is the one to shoot the company into a smart organization. And I think we have much more to explore still in an open innovation process combined with Industry 4.0. So that leads me to the last point. The last point is we are doing a lot of studies, and today's companies that we are in concrete contact, most of them are aligned between connectivity and visibility. Now, you will find some of them being a bit more experienced in transparency. Nobody is in real predictability. Yeah, but most of the companies are working and tugging around here. So I would say we as researchers can support them if we're open and listening to what are their needs. We can help them with open innovational approaches to be quicker to this end. Thank you very much that I could do this presentation. What we are doing in Aachen, Hans, you just mentioned it, we sorted out 2 cars. One was a street scooter that we sold to the German Post. The new car is now the Ego, and we are not developing the car in raising up the volumes. We developed the car with a complete set of bricks, stones, machines, and IT infrastructure, and we want to sell the complete production engine worldwide to be ready to produce these cars. And through this, we have learned a lot in terms of what it means to go for digitalization, and I must say this is a hard step to go, but our companies, our industry must go through it. Thank you very much for your attention. I hope I could give you some ideas what's going on.
Thank you very much, Walter. Very interesting, wide-ranging presentation. Lots of issues to discuss, I guess. Yes.
No, it's you. No, it's you.
Yes. First, we will have some discussion, and
okay.
There are a couple of topics, of course, that you easily can identify, which require some discussion. I would first like to invite the audience. Would you have any issues that you want to bring up already, right now? So, any questions which we could discuss already? Yes, on the left, yeah.
Thank you very much for this enlightening presentation. So in mind, we have a lot of
So then I have to be more precise. This is nothing for citizens and elsewhere. This is only dedicated for manufacturing plants. So we are going into a plant, workshop-based, and we are talking together with those collaborators who are producing on the plant side. We are not able to do a maturity index for smart cities, for electromobility or whatever. So this indication here is purely dedicated from our long-term experience from manufacturing sites. And how does it work? Normally, if a plant is saying, okay, please make an analysis on my plant, which is a concrete area. We never do this, for example, if a company is having or running 20, 25 plants as a benchmark. Don't compare this to a benchmark. It's not a benchmark. But we are doing this plant-wise, and it takes us about 1 week to understand one plant in total. Not on the processes basis, but in the basis of the relation. So we are not able to do this outside the plant for civilians or other committees.
But maybe you meant also to bring in the aspect of workforce, people working in the workplace, for example. How does that relate to your approach of capability maturity? Let's say the capabilities that could be developed by people working in these plants.
This is done in these, we have this four-sectoral approach, which is organization, culture, resources. Resources means qualification. So there we are sitting together with human resource managers, and we are doing a match between needed resources, needed qualification, and qualification on site. And these are mostly the most intense discussion, because now a company has to understand if they are getting rid or if they're doing more qualification to qualify. And sometimes companies have to understand that during the last years, they should already have been starting with raising the qualification. So this is with human resource. On the organizational side, we are sitting together with those guys who are for processes. And this is another hard topic which takes us normally 2 days, because these guys are trained from lean management issues, continuous improvement. They are stuck into their processes, and to show them that digitalization, network organizations are no longer defining a process in terms of input and output. This is for these guys very hard. So these are the two typical parts. From both of these discussions, we derive in this digital roadmap, for example, qualification. We just opened an office in Mexico, where we are doing the training for the OEMs around Puebla, training their colleagues for Industry 4.0 issues, which is lean management for sure, which is digitalization, which is methods time measurement, the typical process oriented and others. And we just opened up an office there. This is a public funded project. Astonishing, but why not take it? Yeah, and this project is going for what are the needs in terms of the qualification to raise up the skills to be able to proceed in Industry 4.0.
Is it also part of the capability maturity approach?
It's beside the capability approach. We formed up a company. Yeah. This is the Maturity Industry 4.0 Center. It's a startup company, so they're doing business. And this one I was talking about, it's called EMAS, E-M-A-S. It's a public funded project, which is now going to be launched from Mexico to South Africa and to China. So this is the practical doing.
Yeah. Okay. Yes, please.
Absolutely, yeah. So they're both going together. So very often we are asked, should I stop all my activities in lean management and change over to Industry 4.0? No. This is what I wanted to indicate with this small slide, saying going for a smart company, you need the process orientation and you need the process optimization for sure, but you have to think about how to be able to get into the digital business. I'll give you an example. We are in close contact with some of these large manufacturing companies, and they are asking, how should we go into this business? Some of them have launched startups outside for the digital business. The SMS group, for example, they have launched an SMS Digital, which is a group of about 20, 25, which are outside the organizational infrastructure, because they say, if we are launching digitalization inside a huge, big ship, we are too slow to proceed, so we are launching this outside. Other companies have done this in an internal organization, which leads very often to the result that this internal organization is strapped up by the huge decision-making processes. And this is what it's going for with this 4 matrix approach, saying, okay, we need lean, and we have to think about the organizational approach, how to introduce the ability to get into the digital business. So both of it.
Okay. I would like to bring in also a somewhat different topic, collaboration. Because a lot of these changes most probably cannot be done in isolation by one plant or one company. For example, if you talk about changes in the supply chain, in the IT infrastructures that enable different companies to work together and use information from each other, also sharing data, for example. How does your approach relate to the need to create collaboration in order to innovate your processes and your systems? So what is the role of establishing collaboration in the process of change? Can you elaborate on that?
No, I can't, because it's not a topic.
It's not a topic.
And that was exactly why I was so happy to join again this conference here, because I think this is a big opportunity what Louis and the whole group is doing since years. Virtual enterprises, virtual organizations now are led to a complete new kind of looking upon this. And we had this discussion yesterday, open innovation, collaboration, productivity of collaboration. And your keynote from yesterday, blockchain and the relevance for the collaboration. We didn't tackle to this, and I would never say the maturity index is ready. Yeah. So we are working on this maturity index in enlarging it, and the collaboration part is not tackled right now. But to my mind, this is a complete new area of period where we can bring the ProVE into the business in defining what kind of collaboration do you need. Because now the maturity index is looking at one single workshop, but there is no one single service. You have suppliers, you have vendors, you have
a network.
The network. And we are not able to tackle on this. Perhaps this could be a
Should
very...
it be tackled?
Absolutely.
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 So, any ideas how to tackle these kind of issues? Any directions to go? Yeah.
You do have concepts of supplier cities in most companies, and what I thought about you do need very close proximity to the manufacturing facility and have the agility to respond. So actually, when you're going in and looking at specific production flow and specific organization, if you had a giant shed different elements of pieces of plant in the shed, you should be able to design a massive process flow that even down there can optimize the utilization of that machine to create other objects. And so they're looking at capacity management improvement, you're looking at specific production of products. And you get the benefit of both collaboration, bespoke production, and capacity management. It does require the financial transaction costs to be calculated as one part. If that transfer pricing between businesses, so I think the challenge will be able to fair transfer.
Yeah, I'm absolutely with you. You're hitting on the point. I think the problem is, first step, to make things clear that digitalization of Industry 4.0 doesn't mean more sensors and actors putting on the machine. Very often you're finding engineers who love to have more sensors in the machine. More sensors doesn't help us at all. That's the first point. And very often we are coming in contact with companies saying, hey, our machines, we have thousands and thousands of machine data. No, this is not digitalization. Second part is that the maturity index is, yes, that is a leak point, is only looking on one side, but we are right now having enlarged it on functionalities like maintenance, logistics, sales, purchase, development, and others. And this is for sure that we have to go further. Third part is that we are actually working on what we call the global footprint. So first we are looking at a company who has a global footprint for itself, and then getting in the correlation with others. The next part, this is still a lot of research to be done for this, is not the company-owned manufacturing shops, but the relation with others. And there is a huge potential to explore in this area how this does function. So we are at the one shop floor. We are now enlarging it to a global footprint of one company, comparing these. And then the next could be what you were estimating, having the relation between suppliers from foreign companies and going to the market. So we are not ready. There's still some work to be done. And we are inviting partners to work with us to enlarge this further on. This is the first part. This is very well accepted. So companies, they love this approach because it's practical. It's practical on one shop site.
I would like to thank you very much.
Thank you very much.
And then I propose that we go to the second speaker, we'll talk about collaborative transformation systems, path to address the challenges around the competitive
Thank you. Thank you, Jens, very much. Good morning. I'm very pleased to be here, and it will be difficult to add some value after this so nice presentation from North, but let's see what you can do. Yes, this talk is about transformation systems. In fact, we need to understand what is a transformation system, and mainly what we are saying as collaborative transformation systems. So, this is not a presentation about research, results of a specific research project. No, it's only some ideas that we are, in particular, in our institution at INESC, we are really interested to exploit with companies in industry, in particular with manufacturing. And I'd like to start this presentation with a short statement, but in our opinion so important, and it's about the European economy, and about competitiveness, and about the creation of new jobs. And the point is, this will be difficult to achieve without a strong and modern industrial base, with new knowledge, new technologies, in fact with a new manufacturing industry. At least we need to keep the manufacturing industry, we need to not only to keep but to guarantee that we'll be competitive. So let's talk a little bit about this set of topics related to this problem of competitiveness. And so only a very short definition due to the fact that I talk in mature countries, and we saw in previous presentation also mature economies is, mature countries, we are talking about countries with a very stable economies, but at the same time with older infrastructures. We are talking about countries that include the United States, Western Europe, Japan, and then we have other groups of countries. But in this presentation, we'll focus mainly in these mature countries, and so countries with a lot of challenges: aging population, limited economic growth, high national debt, high pension obligations, and so on. So this is a set of challenges quite relevant in the context, in particular in the context of Europe. So what is our understanding about transformation systems? And we talked in the previous presentation about value. Yeah, value is in fact the expectation for a transformation system. We want to create value at the end. Transformation systems is a combination of assets, equipment, machinery, what we have in the shop floor, and of course people working there. At the same time, we need really to define what to do in what kind of sequence, and this is processes. This is different. So, transformation systems is a collection, of course, of processes and resources. Usually, in some companies, the people mix both things that are really different. One thing are resources, other thing are processes. It means that any kind of transformation systems try to really to improve the quality, the speed, to reduce costs and so on. And the value could be understood as this delta between output and input. And this is quite important because any kind of company, manufacturing company, in our case, what it's trying to do is to increase this delta, is to increase this value. And this is, I really appreciate this value definition, is like a ratio, is a ratio between functionality for the market and cost. And these both things are always present. This is why, for one side, we need to increase what the market is asking, quality, speed, innovation, and so on, but always, we have the objective to decrease cost. Because when we decrease cost, we are increasing value. And this is so important to consider. It means that the transformation systems is a complex networks of activities, processes that are using resources. Well, what's the problem? In the past, we try to create value through what we call verticalization. So basically, we try to put internally all the resources that we need, all kind of activities that we need to create value. Well, but in the last years, we are, let's say, we are following different directions. We call the verticalization. It means that we are really focusing in our core competencies. It means that we are splitting the transformation system in a set of different transformation systems. Well, basically, what we are trying to really do is to maximize the optimization of the value creation in each stage in this transformation process. How? In fact, we are trying to select the best, let's say, player for these transformation systems. And this is the point. We are optimizing these, let's say, transformation systems, but then we have a new problem. We have really this problem of interconnection, how to manage these interfaces between this kind of collaboration. And this is the point. We know in industrial engineering that the main problems always are in the interfaces. This is the main problems, always. We are losing productivity mainly in the interfaces. We are losing efficiency mainly in the interfaces and so on. So, for one side, we need to, let's say, explore collaborations, transformation systems, but we need to really implement mechanisms to guarantee the right efficiency for these, let's say, interfaces. And this is a challenge to cope. In fact, the organizations are more and more focused, and this is true for manufacturing. This is really a trend, and it means that a company, when are trying to be more narrow, more focused, the companies will give up some control, and at the same time, it means that it will be necessary to create some new organizational strategy skills, and, of course, some new operating practices. It means that it will be necessary to guarantee, let's say, to implement, to develop, to use a collaboration framework. And as you can see, from vertical to the vertical, there are the partnerships and collaboration. This is really, really a key point. And the other point is, of course, the emphasis on virtual infrastructure, because you cannot control all the value chain, but at the same time, we need to optimize this value chain. So it's really very important to understand collaborative transformation systems, to understand also the problem of transactions costs, the problem of partnerships, and so on. So let's advance a little bit on that, and let's try to understand why this is really critical in manufacturing. First of all, manufacturing is really a keystone in particular in Europe. And we know that when we look for, let's say, for the last decades, we can see that European Union has losing, in fact, let's say, some share in GDP in manufacturing. And in fact, this is quite critical because, as you can see, industry is so central to European economy. So the challenge is, how can we really reshape this curve, trying to really increase the share in the GDP. In fact, the last year showed us that Europe is trying really to invert the situation, but the problem is what we need to do to be so competitive with China, Japan, Korea, and so on, and really to increase the share of industry. So this is one of the main problems, and in fact, as Volker talked before, we have really different challenges in Europe. At least two cases for let's say, the technology already in the market. One is how to increase the number of companies that can go to the market with these technologies already available. So we have a lot of research, but we are talking about how really to be innovative from this point of view, creating new companies with the technology already available. This is a case A. The case B is how can we increase productivity in already available companies in the market. It's the companies that Volker talks also in the previous presentation. We have a lot of companies in the market, we have a lot of technology, but there are a lot of problems to implement new technology, and this is a problem. So, to different situations for the technology already available. Another problem is that one. Yes, China is an example of global competition. In fact, this program of China is so big and so strategic. And this is also will be a challenge, of course, for Europe, is this increasing global competition. This is different from that situation. And then, and this one is linked to the first one, is digital transformation will change, of course, a lot of things, and in particular the labor market and the nature of the work. It means that it will be necessary to rethink a lot of things, and at least to cope with these challenges that we can identify in this digital transformation. Well, these are some ideas, and why this is so critical in manufacturing. Because what we have nowadays is something like these three different things. One is product. The product is really complex, much more complex. At the same time, a different things is the offer, the variety is also really impressive, the amount of different products in the market. One thing is the complexity, another thing is variety. And the third point is about complexity of the supply chain. So it's so complex nowadays to manage so different entities and to create products and to offer really a huge portfolio of these products on the market. It means that it's necessary to cope with flexibility, it's necessary to cope with response time, and it's necessary to cope with this kind of high frequency. And we are talking about what? Mass production, we are talking about to cope with variability, the famous, one point of the famous VUCA, to reduce life cycles, and in fact in a company we are talking about new ways of developing the products. We are talking about maybe new business models, we are talking about new ways of creating these transformation systems, and will be for sure much more collaborative. So this is the point, and in that context, to offer these high value-added customized products and to manage these complex value chains, okay, it's necessary to have capability to address different issues. One is, of course, it's necessary to know how to design these so complex and sustainable high-value chains, achieving at the same time business excellence, not only operational excellence. We are talking about business excellence. This issue of leadership innovation with operational excellence. This is business excellence, okay? And so it's necessary, of course, tools, models, whatever, to improve visibility. We need to, it's necessary to learn to see. It's like in the previous days about the learning to see in Lean. In this new digital world, we need again to learn to see. We need to really to improve the visibility in these value chains networks. We need to master complex modeling. And this is really a challenge because maybe it will be necessary to combine different approaches to really model complex things, either quantitative and qualitative, yet combine it to solve problems in the context of these transformation systems. We need also to implement new decision-making process to address in specific what we call high mix and low volume production towards one-of-a-kind environments, and this is quite challenging. How to take decisions in this type of environment. We need to think also how to explore this paradigm of PPS, product and service systems, so that everything are mixed together, and how to manage the life cycle and to perform life cycle assessment or even cost modeling to support both products and services. And we can continue to identify a lot of things. Of course, to master digital technologies, simulation, virtualization, but oriented to tactical decision making. And we need to link things to digital space, machine sensors creating true digital value chains. We need to deploy autonomous systems driven by advanced robotics, machine learning, and so on. We need to leverage knowledge-based manufacturing, creating knowledge from the data. And as Walker said, we have a lot of data, but we are facing a problem concerning the quality of this data, and this is also so challenging. And of course, we need to adopt human-centered manufacturing, because at the end we have people in the shop floor, and we need to, of course, to think about the new workplaces should be supportive, should be friendly, interactive technologies enabling workers' talent and capability. Well, this is so a point, and at the end, and not the least, we need to promote and to guarantee sustainability, because this is not a problem of achieving competitiveness, it's a problem of guaranteeing the competitiveness in the future. So we are talking about sustainability. Well, only a very short comment in digital value chains. About digitalization, in our opinion, we can, let's say, think from operations perspective, three different flavors, if you want. One thing is digitalization efficiency driven. So someone, a company that is trying to increase productivity, that is trying, let's say, to improve efficiency. This is different from what we call evolution driven. When a company can think in new products and new services, but grounded in this in the digitalizations technology and solutions. And the third one is market growth oriented. It's developing new business models, taking into account this let's say, digitalization approach. So it means that for a companies, if you go back to an SME, and this issue of maturity will be a key point, because it will be so different, and the companies are so different. In some companies, maybe you can think in developing new business models, but for other companies, you cannot talk about that. Maybe the companies are only trying to improve their productivity or their efficiency and so on. So we need to think, how can we address this kind of let's say, challenge? And so this is why we think there are three main types of digitalization. Well, only a very brief point about these key enabling technologies and technological solutions, not for maybe flexibility, it should be maybe for agility nowadays, but anyway, there are a lot in manufacturing. We identify a lot of technologies like advances in production technologies, robotics, collaborative human machines technologies, the issue around real-time decision-making process. This is also a very important point to consider for the competitiveness of transformation systems. Issues about taking advantage of advanced analytic methods and so on. And this is sometimes the people can think, well, this is only about technology, digitalization and so on, but no. This is also about new organization models and new operational strategies. And this is the point. Digitalization is not only about, of course, technology. And it means that this is why, and it was possible to show in the last presentation, to evaluate maturity of a company. We cannot really rely only in technology. We need to look for the culture. We need to look for the organization. And this is a point. This is really a key point in the adoption of technologies and solutions will imply for new, maybe, changes at the organizational models and at the operational strategy. Well, there are a lot of, particularly in Europe, a lot of, let's say, agendas and a lot of material that can support what we call the factories of the future. This is an example of one initiative, a roadmap for these factories 4.0 and beyond. So it's a document that builds the vision of the factories of the future for Europe. As this has been created and promoted by EFRA, and as you can see at least five main points: agile value networks, excellence in manufacturing, you manufacture sustainable, and the digital manufacturing platforms. As you can see, 5 directions, multidisciplinary, and that's really take into account, let's say, some of the challenges that we are discussing today. In particular in Europe, as you know, the innovation policy in Europe since 2009 was grounded in what we call the key enabling technologies, the famous CAT. And as you know, in 2009, it was identified a set of 6 key enabling technologies: advanced manufacturing, advanced materials, nanotechnology, micro-nano, industrial biotechnology, and photonics. And for the future. For the future, Europe will have to these 6 key enabling technologies: artificial intelligence, okay, and the issues around digital security and connectivity. This is the point. So it's important to see that in particular for manufacturing, we can see 3 main groups of technologies: production technologies, digital technologies, and cyber technologies. And this will be a nice set to be, let's say, explored for the next years. Well, I need to skip some slides because in order to avoid overlap with the presentation of Walker, but this transformation is so critical because it's necessary really to think about a strategic roadmap. This is not a problem of changing the position of a company. This is so difficult. When we are talking about change, we need to really address with the best strategy. So it's necessary really to have a roadmap. Otherwise, we cannot succeed on that. And so this is why a structured approach is a key point. And so, in particular, in the market, we can find different contributions in this field of accessing maturity. And really, the work from Germany in Acatech is so relevant. And why this is important, this issue of maturity assessment and so on? Because the transformation systems from X.0 to 4.0 or whatever, we need a lot of years. We still have let's say, between 10, 15 or 20 years, it means that we have a lot of years to address, and so this is not so easier, and this is why a roadmap will be also so critical. What is the problem? The problem is, for a company, we have a lot of requirements to cope, at least three. Priority, a company needs to know and to define the priorities, because we have always limited resources. It means that we need to identify our priorities. We need to have a vision. It means that we should be able to identify our capabilities that we'll need to consider, and of course the mindsets. We're talking about changing. Changing means to change the mindset. This is what the roadmap is a key point to consider in this journey. Okay? Well, just a very brief slides about some maturity assessments frameworks. This one is from Singapore, and this is the Singapore Smart Industry Index. Is based in 3 building blocks: process, technology, and organization, which is really, really interesting. And for each building block, then they define 8 pillars. Okay, this is the pillars: operations, supply chain, product life cycle, automation, connectivity, intelligence, talent, and structure and management. And for each pillar, we have 16 dimensions. Suppose in the context of ProVE, there are really some, let's put like that, nice dimensions. Vertical integration, horizontal integration, and so on. We are talking about collaborative transformation systems. As you can see, we have the shop floor, and when you look to the shop floor, we need to look to intelligence, connectivity, automation, and so on, enterprise, facility, and so on. So this is one example, and for each of dimension, suppose that one, we can really evaluate the index against a scale, and define a digital, integrated, automated, intelligent, and so on. Well, with some conditions in order to guarantee to do this assessment and that positioning. Well, I need to skip this one because, as already been presented, yeah, this one is from Hackatech. I really appreciate also this framework since the beginning. I think really interesting. This idea of creating this methodological analysis is really important because, as you see, the output is a digital roadmap. Yeah, it's a digital roadmap, and this is really nice to take into account. And then, why this is interesting? Because for these different main 4 areas, resources, IT, organizational structure, and culture, okay, there are what the framework consider principles. So there are different principles, 2 main principles for each area, and then in each principle, for each principle, we'll have different capabilities. It means that this is interesting because you can go deeper in different areas, then principles and then capabilities, and at the end will be possible to map the company. Well, about our institute, we have also a methodology that we are using also in companies, and it's about what we call technological roadmap. And we are talking about this maturity, but our methodology really identifies 4 main stages. One thing is to evaluate and to do the assessment. Other thing is to think about the vision, where the company wants to be in the near future. And we talk about the design, the organization. We need to design the organization for the future. And then we need to plan to achieve that vision, and then we need to implement. So this is our, let's say, dimensions. In the core, we have what we call organization, strategy, and leadership. It means that we need to assess within the company, it's so critical. And then we have mainly technologies related to particular, this is for manufacturing companies. This is about mainly resources. This is about IT, is a kind of resources, but due to the relevance of the IT, we need to think in a different way. This is about business processes. How the company plan, how the company react, how the company improve, how the company perform the maintenance, and so on and so on. And this is about culture and people. And so this is the first stage. In the second stage, we take into account the results of the previous one. We join what we have available now and in the future concerning advanced manufacturing technologies. We take into account the best practices and we find opportunities for the company. It means that having this set of opportunities, we can draw the vision of the company in a timeline, okay? And in the timeline, we can explore different dimensions: networks, operations, intelligence, co-creation, and so on. And so, after that, it means that with this, with the vision, we can really create an action plan. And this action plan will be split in the different dimensions that we have seen previously, okay? So I will skip that because it's a different one and we need to finish some final remarks. Well, what we are talking about is about mass customization, it's about one of a kind, and I really like this type of challenges, and it's so important to understand the evolution from the craft production towards the famous assembly line and then towards the mass production. And we are talking here about volume, but we are talking about, let's say, very low product variety. And nowadays we are returning home. We are returning home because we are talking about mass customization. It's possible to customize everything. And the next step is really the one of a kind. And in the one of a kind, we have a new competitive paradigm, okay? Active and collaborative participation of the consumer in the process of creation and transformation. And this is the point. This is the point. In fact, this is a piece for a particular consumer. It means that the consumer needs to be involved since the beginning. And so this is, in my opinion, the main point. Okay? So when you look from an operations perspective, this is interesting because look, we can think in a push strategy, volume push, really push, and now we are looking for a pull strategy. What is the point? In the mass production, we have mainly dedicated and rigid transformation systems. Then we are talking about flexible transformation systems, and this is true. It was during this customization, and now we are talking about in the future, collaborative transformation systems. And this is, in my opinion, one of the main challenges to consider. Basically, again, transformation systems is a value chain. What we are talking about is the interconnection of networks of different entities, and we are talking about different technologies that can, let's say, support these so collaborative transformation systems. The last slide. The last slide, and I'm sorry.
And then you have a backup of 10 extra
You know, this is the promising. This is the promising. This is a promising for the company. Digital transformation will be the source of the next horizon productivity gains. But we need to understand if this is true or not. And the problem is a company, when invests in technology, the company is really moving in that direction. We can get more profitability, we can get more results, but we are decreasing the asset turnover. When a company doesn't invest in anything, okay, they are increasing the asset turnover, but they are losing profitability. So the problem is when we invest in automation, as Volker said, this is not a problem of put sensors. Yeah, I agree, because if you put only technology, we are, let's say, going in that direction. So what is the challenge for Industry 4.0? The challenge is different. The challenge is we need to change that curve. And to change that curve means that we need to really reshape, to create a new border. And this is real improvement. It means that real improvement means that we need to think, to improve operations, to improve flexibility, agility, and so on, and at the same time to keep the turnover in the right place. Well, this is Promises 4.0. Thank you.
Okay, thank you very much. Thank you very much for your very nice presentation. Next time I need a red button.
Yeah, I'm sorry.
The idea was to have a little bit more discussion, and that is really difficult right now. But how much time did we go on? 5 minutes? All right.
We can talk during the coffee if you want.
Yes, that would be very good as well. Just let me first invite for any questions or points for discussion. Luis.
First of all, thank you both for very nice presentations. I think you were quite complimentary. Very good. And putting them together, you address an important part of the collaboration.
Yeah.
The other one that I somehow missed a bit in both presentations is the aspect of cognitive systems. So if you could elaborate a little bit of the role of cognition, cognitive systems, it would be good. And a second small question is that for you, you mentioned in the beginning that mature countries, one point is aging population.
Mm-hmm.
And then you talk about all this transformation and human-centered manufacturing. So how do you put the things together, aging population and this transformation?
Yeah, this is a key point in nowadays in Europe. This is really one of the main challenges in at least in manufacturing, how to guarantee that people can be active, creating really value, and that's working with these new technologies and so on. And well, this is a problem. I don't have really a solution for that. But as in the past, this issue of ergonomy, things like that, I think nowadays is necessary to think in new things. How to guarantee that the people can be active, because let's say old people, they have a lot of experience, a lot of knowledge, of course. So it's necessary to leverage, in my opinion, people with the technology, of course. This is not so automatic that you can press a button and everything will go, let's say, alone. But it's a challenge. I don't have, let's say, it's not my expertise studying these kind of things, but I recognize this will be really a problem.
How could it be experiment? You were also talking about roadmaps and the path to the future, but we all know that there's a lot of uncertainty. And a lot of things happening in between. So a path is never the path.
Yeah.
So that could be somehow balanced by thinking about how to experiment such solutions.
This is, in my opinion, this issue of maturity is really how to access maturity. To, let's say, to perform a maturity assessment, in my opinion, is the key point. Why? Because it will be possible not to only to understand what is the position of the company from, let's say, technological perspective or resources perspective, but from human resources perspective. And usually, when you go to a company, small or big company, of course, most of them, they have, let's say, plans to train people, to educate people, and so on. The point is what kind of training is necessary and how to involve those people, and how can we really put the people in the center of this value chain.
What kind of pilots could you foresee
Pilots?
to experiment such directions? What kind of experimental settings would we need in order to learn from what's happening and follow a certain, or redevelop, redesign the path that you are starting?
Let's say at strategic level, there are, we can see a lot of nice contributions. One thing is, let's say, this digital capability. Another thing different is the leadership capability, and Volker talks also about that. And I think this is a key point, is that leadership capability. And we can talk in leadership at higher level, but you can talk in leadership at the operational level. So the point is, how can we guarantee that the people can really be leaders in that context of their work? It means that it will be necessary maybe to change the structure, like the idea of the hierarchical structure, and to create a more collaborative structure, a more organic, but at the same time oriented to the goals that we want to achieve.
What would be the best examples, small examples maybe, that you already see happening? Where could we learn from this?
I think that in the last, just before you start the presentation, there are some questions about the issue of, let's say, digital transformation and lean and so on. In my opinion, I think that we can learn a lot with the strategies that companies implemented during their lean initiatives. Because lean is also about transformation. Transformation means how can we involve people in that transformation. So a very key point is to look to the experiences of that companies with these lean initiatives and to learn how it was possible to involve people. Usually in lean it's necessary to take into account a lot of things. One thing is better to start with some simple things that everyone can see, like a pilot, instead of trying to change everything. And maybe the roadmap, the digital roadmap is interesting because the digital roadmap looks for all the company and along the time, right? Is for the future. But for the implementation, it's necessary to define priorities. It's necessary to really define, to generate some quick wins to involve people. And in my opinion, some examples will be, let's say, to create some pilots, of course, and to implement a kind of, let's say, it's not PDCA, but it's something like that. We need to really plan the change, we need to implement, we need to check, and you need to really adopt. It could be something like that, but adapted to this digital transformation.
Does anyone in the audience have experiences? Yes, Volker, of course.
May I just allow to make two remarks? The first remark is, actually I'm trying to prepare a German study on the impact of digitalization. So nobody really is able to calculate the impact of digitalization. We are talking about the improvement, we are talking about lean, about optimization, and we are preparing a study which should evaluate if there is a measurable impact of digitalization activities, for example, in relation to GDP. Nobody has done this right now, and there's a big aversion against this. Because if you can measure this, it's very clear. Politicians were asked to put in. Second part is coming to the aging part. What we have tried out, and what we are trying out actually is, I've been talking about the business analytic guys. So if you're going for the next steps in terms of the future roadmap, sooner or later you need these business analytic guys, which are purely coming from mathematics, informatics, and there is, with these guys, a certain, let's call it a certain lack of experience on the use case. And what we are now negotiating with some companies is why, in terms of the aging society, not putting those who are not able to work on a shift system, 8 hours, turning screws and all these, and putting them together in development groups with these business analytics, because what these guys have, this is a large experience on what's going on the shop floor. It's a large understanding what's going on without being able to turn this into algorithms. And they have a good understanding mood if the result of a business analytic are correct or not. Yeah, so they can say, okay, I don't know how this business analytic has come to the result. I don't know, I'm not interested, I'm not able to do this, but I can understand if the result is feasible or not. And through this, I'm coming to the point that Luis was just mentioning. Our societies will not be able, even if we're improving our productivity at enormous extent, to pay for us growing older and older. We are growing too old. So somebody like us going out of the business 65 at least, and then becoming 90 years old, you have to shoot us down because society is not able to pay for this. So we have to find other possibilities to integrate this experience into the value, exactly the value, which doesn't mean that I have to work 8 hours per day, 5 days a week. But we have to find new ways of salaries, new ways of bringing in your expertise into this business.
To shape the value.
To shape the value. That's it. And we must be able to work until we are 70, 75 without being for 8 hours a week, a day, 5 days a week.
Are there any activities going on in this area? I mean, to explore the ways of working of elderly people and their involvement in business-oriented or creative or production type of activities. What is the current state of things in that respect? You? Yeah, please.
Let me just give you ask for an example. Let me just give you an example of a small company that we are looking at your portal that is struggling, trying to apply how to do in terms of all these high of industry programs here. They are machine tool manufacturers, and they are struggling with two aspects that you didn't mention directly in both of your presentations, which is a new business model in the scope of digitalization, and on the other side, the skills that you mentioned, the competencies and skills that you mentioned in your presentation, they are not only, let's say, related with age. On the contrary, they are related with young people that have now a completely different pattern of career. So, in the first place, they are struggling very much with, even though they already have some kind of systemization, data analysis, and so on, they are struggling with having experienced people. Because nowadays, you go to a company like this one, and you don't spend there 10 years, you spend 2 or 3. So 2 or 3 years, and you go away, and you have a much higher rotation of people than in the past, and in the future it will be like this. The patterns of careers will very much difficulty in having people, for example, for machine operator. And you mentioned the CIM from the early 90s, where there was this manufacturing utopia and so on. And today, we don't have a utopia because the shop floor must continue to have people somehow. So that is one of the problems, how to educate people for Industry 4.0 in a completely different panorama of professional arts.
Okay.
And the other thing is the digitalization in terms of business models. That it goes to the ambiguity part. Suddenly, you have a machine tool manufacturer that becomes a service provider instead of a manufacturer that just sells a product. And that's a different type of relationship with the customer.
think maybe one final point, and then we should close the session. Okay, thank you very much. I think with this a very positive message and challenge for us also to discuss later on in this conference, I think we can finish the session. I would like to thank you very much again. And I think we had a very nice, inspiring session. And let's discuss further during the break.
Thank you everyone. There's tea and coffee now in the cafe room. Because we got off a bit late, if we come back at 10 past, we have the industry session here and a paper session in breakout room 1. So 10 past we'll start again.
Yeah, one point.
Some questions on this. Thanks you for your moderation.
That was not so easy.
Yeah, see, the problem is
because we have value
This one. But who's sitting here?
Chair. This is something like maybe this is an inferior one, which is the secretary, or this is the most important one to say clerk.
Yeah. If you look to the American Senate, you see some kind of pictures.
Like this. Yeah.
Well, the chair is and then behind. So people.
Okay.
Hello everyone, I'm Masud Saleh from University of Tehran. Thank you so much.
My question is, can I have your presentation?
Yeah.
Can you have mine in exchange if you want?
Okay. Yeah, perfect.
Oh, sure.
Yeah, you know, this Mac is always a problem.
Satisfied with the Mac? What? You are satisfied with the Mac?
Yeah.
Because that's because there's two problems with the implementation. You have yours here? And mine?
Yes.
Yeah.
Drinking.
Yeah.
So now we have.
I need to check the.
Do you know what the industry session means? There's no presentation, there's only the chair.
Because maybe the process of
hear me clearly? I hope it will be great. So, good morning, and thank you for joining this session, industry session, in the framework of the ProVE conference. Then, today we would like to discuss with you about construction projects, construction industry as a whole, construction sector, having a view on how semantics can help managing or developing these collaborative construction projects, and specifically to meet the challenges we are facing today in the construction industry with the climate change and the need for promoting sustainable interventions at building levels as well as city levels. So my name is Sylvain Kubicki, and I'm working in Luxembourg in a research center called LIST, Luxembourg Institute of Science and Technology. My initial training is in architecture, building architecture, I should be precise, and focusing lately in construction engineering and construction informatics also, so the use of computer science and informatics to help the development of projects and the management of facilities and assets also. And LIST is a research center, so as I said, it's not a university. We are located in Luxembourg, and basically we develop applied research as well as services and collaboration with the industries. Yeah, I can try. Notably in the construction sector. So today we have the chance to have met some experts in the context of a European project we are managing. It's called BMIT, and we will use this expert panel to discuss these questions. But let me first introduce the context and the topics we would like to discuss with you. Basically, as I said, it's about construction. Today, construction projects definitely are physical assets related with physical assets construction, but are more and more developed, designed and developed, constructed and managed in virtual environments, making use of technologies. And I will also develop the context, but definitely the companies that are involved in construction are very distinct, very different, usually meet for the time of a project, which definitely make them virtual enterprises as a whole. To achieve the collaboration, the exchange of information, there is a need also to standardize the information exchanges, and that is where semantics plays a role, and definitely helping companies to work together more and more in these virtual environments makes the use of semantics or the development of common semantics very important in the construction sector. And the third, is better? Yeah. Okay, so the first challenge that the construction industry is facing today, as I said, is the climate change and the need to promote, to make building more sustainable, both at the level of their design as well as their operation, towards demolition also, and the use of materials, and this should be also handled at the level of districts. So to enter in a few more details about these questions, okay. First challenge is the construction projects that can be seen definitely as collaborative environments and virtual enterprises. So today it's important to keep in mind that the construction sector has a very large impact on the economy at the European level in particular. It represents 9% of the whole revenues, as well as the employment of a very large number of people. And it represents also a lot of companies at the European level, from which it should be also mentioned that I think 95% are SMEs, which definitely leads to important challenges when it comes to standardization of the work practices. So besides that, it's obvious that technology is more and more also progressing in the construction industry, And it's also known today that 40% reduction of project costs, as well as 40% shortening of the completion times, so definitely the planning times, could arise from the use of technology. These are questions that have been treated in the research and academic world for years, and that progressively are now coming into the work practices of the construction practitioners, especially with the introduction of the so-called building information modeling technology, BIM technology. So why a construction project is a collaborative environment? Basically because there are several actors that are involved. So you can see from these two pictures that over the life cycle of a building, of an asset, there are several actors that are involved, from the owners to the designers, the architects, the engineers, structural engineers, mechanical, electrical, and plumbing engineers, as well as more and more consultants that are required due to the increasing complexity of construction projects today. And then the contractors are also a very large part of the economic ecosystem in construction. And contractors also comprises a lot of workers, builders, so-called blue-collar workers, that need to be taken into account when it comes to technology, digitalization. And finally, the facility managers are also everyday users of buildings and also managers of the building facilities and assets. And this takes place in a range of activities that are very different the one from the others in the whole life cycle of a building, from building programming and conceptual design to the completion of the construction, and finally the demolition or the refurbishment or renovation of the buildings themselves. So this creates a context where the actors are quite heterogeneous. As you can imagine, the level of competencies are very different from the designer, the workers, the type of activities that are conducted are also very different. The time frame, the duration of the activities, so designing the building is a question of 1 year, 2 years, while using the building is 25 years. So this creates very different relationships to the building project itself. So various activities. And again, most of these companies, except perhaps some owners or facility managers, are SMEs. So there are a lot of SMEs in the different domains, from the architects that are mainly in several countries, very small companies, and sometimes one-person company or agency, to contractors that can also be a few people. So why does this matter? It matters when it comes to introducing new technologies that by default will create or will strengthen the collaboration amongst the stakeholders of the construction project. So when it comes to exchanging information for the design of the construction, as well as the management of a facility, of a building, there is a need to define standards that will facilitate this exchange of information. So today, besides the digitalization of the whole sector, BIM, so-called Building Information Modeling, is one of the standards that is emerging both in terms of technological exchange of information, technical exchange of information, as well as standardization of processes in the architecture, engineering, construction, and operation sector today. So what is BIM? So as I said, we can discuss BIM as this keyword that points out the digitalization of information in construction. In a more academic way, I would say that the BIM definition is the use of one or more virtual models defining the buildings digitally. They support design through its phases, allowing better analysis and control than manual processes, and when completed, these models contain precise geometry and data needed to support the construction, fabrication, procurement activities towards the use phase, the operation phase of the buildings also. So that's one of the most used, I would say, definition of BIM. That, in other words, refers to this 3D model of building objects that are also very powerful when it comes to managing geometry in three-dimensional environments, like when it comes to designing precise networks of plumbing, electrical systems, and so on. So this definitely brings new insights and better coordination amongst the trades that are concerned. And this building information model, beside being a single model, sometimes multiple models, representing the building geometry and elements, is also the heart of a whole ecosystem, of a whole information system at building levels, where you can link additional information. So you can see an example on this image on the right corner here, which is linking the planning, scheduling information from the construction site to the three-dimensional elements of a building project. So this starts to explain why this building information model is the heart of the database, of the building database, the building information system, where all the associated information can be linked. But as you can see also the initial steps towards geometry, which are the point clouds, like this one in this video. And as I was mentioning, when new technology is developing in such a construction sector, the management of the exchanges of information is really a challenge, because the technology itself is moving the usual contractual frontiers that are existing at the moment. So definitely, who should provide the information in the models at which time, from which actor should be provided, is a challenge. And you can see that in some of the guidelines for the deployment of BIM in construction, the notations like business process modeling notation here are used, and it makes sense because it really helps redefining, re-engineering the processes and improve them at the same time as the technology is evolving. Finally, besides increasing the productivity, I would like to strengthen the fact that using such digital technology is also in the pursuing the goal of improving the design of buildings. And a specific challenge that is addressed today in the different stages of a construction project is the energy performance challenge, and especially this gap that can be seen from the initial expected energy performance that usually is developed or assessed at design or pre-design stage through the use of simulation tools. So definitely simulating the energy performance requires accurate geometry models, as well as trends and simulations that provide some results that remain theoretical. And once it's come to measuring the actual energy performance, one can see that there are several reasons that can explain this gap. These reasons can be due to unadapted or not enough calibrated algorithm at simulation time, but these results also can be linked to human activities during the construction, as well as the use, the occupancy, and the way the buildings are actually operated at operation phase. So this is important to see the shift from this use of technology to increase the productivity of the construction sector that definitely needs some additional practices to make the whole construction economy viable in the time, and also using such approaches to improve the sustainability in buildings. Finally, if I come back to this building life cycle, building information modeling today is a tool, can be seen as a tool for improved multidisciplinary approach across the different trades in construction and across the different stages of a construction project. And what it comes to is that specific skills are required. So definitely we know we can identify the skills that are required from the usual contracts and missions that are used in the construction industry. BIM is already moving or changing the limits, the boundaries of these contracts, because some work should be done earlier to be able to develop such models because of several reasons. So technology changes some leaderships in the same time. And definitely we should look further, because modeling, authoring models of construction projects. It's also the whole digitalization of the construction industry that is in play, and for which new skills are emerging, and it's quite hard to identify them today. So you can see that from these few slides and this short introduction, building design, building construction, as well as building operation, today is about introducing the digital technologies to all the stakeholders in construction projects, and with the aim of improving the energy and the whole environmental impact of buildings and districts and cities and the environment then. And this requires skills that are quite difficult to handle. So there are probably several ways to do that, to improve the skills of the construction workforce, the engineers, architects, the blue-collar workers also. And that's what I would like to discuss with you in more details today, with a panel of experts that are accepted to join this session. So I would like to invite Richard Hartless from the Building Research Establishment in the UK. So if you can take place, Tarja Mäkeläinen from Finland, so from VTT in Finland, as well as Johan Petri from the Cardiff University. Thank you for joining. Perhaps we can start by a few words introducing yourself. The idea is really to have an interactive session, so I would say that we can let our experts presenting themselves, and feel free then to participate in the debate and involve yourselves in the discussions. So, Richard, please, can you in a few words introduce yourself and your expertise?
Hello, thank you. Thank you, Sylvain. My name is Richard Hartless. I suppose since that picture was taken, I've grown some fluff on my face, I suppose, just so I can grow some hair on my head, at least. I'm at the Building Research Establishment in the UK. I'm specifically part of the BRE Academy, which is the training and dissemination side of things. I'm part of the BIM project and looking after the task, which is specifically looking at benchmarking existing energy efficiency and BIM training throughout the France and the EU.
Good afternoon, everybody. My name is Tarja Mäkeläinen, as Sylvain introduced myself, and also the picture is, I think, 10 years old from one of the BIM seminar held in Finland. So I have been a researcher at the VTT, which is the technical research institute in Finland, and areas has been building information models, modeling and management, and especially the process implementation to organizations, and what it actually means when you use the possibilities of integrated information management on projects in design and in construction especially.
Hello, my name is Johan Petri. I'm from BRE Institute of Sustainable Energy. I'm a research fellow, and my expertise is really in using computer technologies to address engineering problems or challenges in the IAC construction domain. So in relation to the session today, I have been involved in two different research projects on building information modeling, one of which has a particular relevance for this session with regards to how can BIM can be used as an exchange environment between different collaborative entities. So discussion about collaboration, construction projects, the use of semantics is something really challenging, and I'm looking forward to discuss more.
Thank you. Thank you. So, as I said, this should be, we hope, having an interactive discussion with the whole audience, with all of you, having in mind that we are progressing in this European project called BIMIT on the identification of what are the skills required to improve the adoption of such technologies in the view of the sustainability, performance, and energy efficiency of buildings. This obviously can be done from the bottom-up approach. We have experts involved in the actual BIM training, the actual training of the workforce. So it's really important to have the insights from what should be done today, what the market is expecting. Definitely we need expertise in this technology and processes, but we also look from the research perspective on how research can today improve this discovery, in this case, discovery of new skills, but also delivery of new knowledge to practitioners in a market that's quite difficult. Construction sector is a sector where usually people don't have time. People don't have time to train and to mobilize themselves for this kind of purpose. So, do anyone of you has some experience in either construction sector or city development? No, so we should look from the, let's say, academic view on how to support these developments of technology. So, I suggest starting with a question for you, Tarja. So, Tarja, you come from Finland, right? Can you elaborate a bit on how the BIM education is organized today in Finland? So it's important to mention that Finland is one of the most advanced countries in Europe to involve and to deploy BIM on the construction projects. So I would like to ask you what's the status of the BIM education, and also I think it's important what is the role of the public authorities, public owners in the process of standardizing, the digital use, the use of digital tools, and what is the impact on the workers in the end?
Quite a
lot.
Yeah. Now we had so many questions. I don't know where to start. Are you hearing me? Well, is it okay? Good.
I think it doesn't work.
It doesn't work. It doesn't work? I don't know.
I'm not sure. Kind of echo.
There's no light. Well, okay, I try to speak loud. The story of BIM in Finland started a very long ago, and I think EU project and some national research programs were very, very essential platforms to also raise the question of new skills, new roles, but of course it started with technology and the process change in project life, and what happened in Finland was something that we could call a middle out implementation or middle out adaptation, so that the building owners really stated that okay, this is interesting technology, we will try to do differently in our building projects. We will try to change the processes. So the public owners, some of the big cities, Senati Properties, which is owner of the state buildings, state-owned buildings, and some construction companies like Skanska, they tried to open this possibility for their employees to really pilot on real construction project that what does this BIM mean. And the research was important because there were some interesting software development done, and the software were able to help the model-based processes. So I would say that it was also middle out very strongly because the owners and the clients enabled the training on projects, and also bottom up that there were so many professionals who wanted to test that what they can actually done, and these pilot projects were the starting point in Finland. Thinking about the education, then I think the holistic picture is still developing in Finland. We have educated our professions, designers, people on site very much by this method of learning by doing. There have been some courses in the University of Applied Sciences and some professorships on the universities, but it's still something which is really which needs to be really structured and used in wider scale, and that is why also BIMED project is so important from our side, that though there are a lot of professionals who actually know what to do with BIM and can work with it, so they don't have any degree from their skills or knowledge.
Okay, thank you. Thank you. So I would like to switch to Richard, because I think the UK is known for pushing the boundaries of the use of BIM in construction projects, especially with these so-called BIM level 2 regulations, or let's say, I don't know exactly how to call it, contracts. And then the question I would like to ask you, from the professional point of view, how do they react to such ambitious, at some point at least, policies? And does the certification of skills, of these new skills, is it required? Is this certification of skills required in this context?
Yes, thank you, Sylvain. I suppose it's where you go back to the involvement of the UK in BIM. It sometimes goes back as far as the 1970s, really, although it wasn't called BIM in any shape or form at that time. It was, interestingly, waving flag for my own organisation, BRE, looking at the paucity and the poor quality of design drawings and trying to communicate what the design had intended to the person building it on site, and then the person that was then subsequently required to manage that. And it was recognised a long time ago that there were challenges here and led to inefficiencies on a construction site, led to duplication of effort, led to just poorly coordinated projects. Fast forward 30, 40 years, and you've got a formal recognition of this, the development of BIM, and in terms of some of the standards that the UK has developed, particularly the PAS 1192 set of standards, which are there to sort of encapsulate the processes. Ooh, I think I'm wired for sound. I could now do it in a wonderful echo, but I'll try and keep it sensible. The development of PAS 1192, particularly parts 2 and 3, looking at the processes of the delivery of the project and then the subsequent management of the asset. And these were the two standards that particularly formed the basis of BIM level 2 that Sylvain alluded to. And the main reason for alighting on that, which effectively is just a sort of a 3D model of the building to be shared collaboratively amongst the project partners, is a way to address some of those problems I alluded to way back in the 1970s and before. But there was a particular driver associated with that in 2011 the UK government basically mandated that all publicly procured construction projects need to be done to BIM level 2. And this requirement was that this should be done by April in 2016. And the government has quite a lot of clout in this respect, considering something like about 40% of construction projects are done under the auspices of public procurement. So this is not just buildings, but also infrastructure projects too. And as we're probably aware, there's a large growth in infrastructure projects in the UK. So this was a very big driver for the industry to basically smarten up its act. And so a number of organisations, ourselves, that's BRE, Building Research Establishment, British Standards Institution, have provided training in this arena, showing how organisations could achieve level 2, and also introduce certification processes by which they could demonstrate to their peers that they are, for example, an informed practitioner to level 2, or they can actually be, they're an informed professional, or they're a certified practitioner. And yes, we saw a huge growth in the amount of training being delivered in this space with individuals and large organisations, the Skanskas, the Kias, many of them household names. I'm not sure Carillion worked with us, but less said about Carillion the better. But certainly there was a great deal of interest in the level 2 and the associated certification. But it's April 2016 has come and gone, and there's been no great sort of change since then. But we don't sort of stand still. Unfortunately, the training has dropped as we're waiting for the next development in this space. Ultimately, we've got the launch of the Digitally Built Britain strategy in, I think that was in 2015, and that is sort of just taking it to the next step. BIM is part of that. The Digital Built Britain has, one of the key aims is to help implement the construction strategy for the UK, where we're seeking to achieve significant improvements in efficiency, cost savings, carbon reductions, generally puts us on a more sustainable footing. So it's part of the Digitally Built Britain's a big initiative with BAYS, the Business, Energy and Industrial, I can't remember now, too many acronyms. That's one of the problems with BIM, it's a wash with acronyms. But that is the role of Digital Built Britain, to take forward the digitisation of construction, introduce cybersecurity, improve sustainability, predictability, etc. of construction projects. But it'll also look to set out the agenda for level 3 of BIM as well, which is that next step where we're all going to be using the same model for construction projects, integrate life cycle costings, etc. within that. But that standard is still to be set. So yes, we're seeing a big uptake in BIM certification as well, but there's no sort of requirement for that yet. And so we're looking at how the next couple of years will see how these particular initiatives pan out.
Thank you, Richard. Any comments? Perhaps at this specific time of the assembly? No, not yet. Thank you. Next Richard. Next Dario. Just want to contrast the two different approaches that have been adopted in Finland, for example. Tarja has mentioned the middle-out approach. In fact, I'm tempted to say it's more bottom-up, driven by the end users. I can take the example of Granlund, which I've mentioned to you before, where Granlund, I've worked with Granlund in 2002-03, and they already had a suite of BIM-compliant tools. I think the UK has adopted different approaches, very much
top-down, with trying to regulate through BIM level 2, the processes that lead into the use of BIM into the construction industry. Now, in '95, Frank Gehry has designed the Bilbao Guggenheim Museum. It was completely based on what we call BIM. It was CATIA at the time. He didn't need any of these processes, It was a very much architect-led approach. I just want to contrast the different approaches we have in Europe. Maybe which you can relate on the UK experience, but certainly what I'd be interested to hear is there any good approach, or whether we should try and have a top-down push for using BIM, whether it's bottom-up, whether it's middle-out. Just wanted to have your views really and have a good debate on this.
That's a very good questions. Been also discussed in Finland, because we have been lacking the top-down approach, which been now done sort of. We have had a 4-year-long program led by the Ministry of Environment, and it did some good. There were some harmonization of standards, and some law issues were tackled, and then there was also a lot of experimental test cases done, and the continuation will be, this is totally, no one knows exactly what is going to happen. This is a very new thing. It's called an InnoHub for real estate and construction, and the story will continue this top-down and a little bit mixed the middle-out area also. I think we need all, but I think in the order of which it will start to really work will be different in each countries because of the different cultures in construction field. So in Finland it was a lot about bottom up and middle out. The owners needed to give some space for the enthusiastic professionals, and we cannot go further without the top down some regulations and structuring the whole system. So I would say every aspects are needed, but in different ways in different countries.
I suppose I haven't really got a lot more to add to that, really. I think I referred to some of the drivers that we've had in the UK in terms of trying to sort of pull the industry along. The construction industry in the UK is very conservative indeed, doesn't like change very much, is very much sort of lurches from boom and bust. We're still climbing out of the bust phase at the moment. So you've got these sort of minimums, bottom-ups coming through, as I've said, the level 2, but there's also a lot of investment coming from UK government initiatives. We've got the Digitally Built Britain approach, as I say, looking to certainly provide, upskill the industry. So there's a lot of investment in AI, in modern methods of construction. One of the biggest challenges we've got in the UK is we're simply not building enough houses. And so it's a case of, can we try and accelerate that process? So modern methods of construction is often held up as a sort of an example of what to do there. And so those are examples of the initiatives that we've got. And of course, the inevitable government reviews. If ever there's a problem, let's have a government review on the situation. And certainly we have the Modernise or Die review that we had recently, which very much looked at the sort of the rather staid nature of the construction industry, pointing out the very sort of very aged profile of it. And so there was Mark Farmer's review very much was pointing out the ways forward, looking at the housing sector as being should be at the forefront of trying to take forward some of these initiatives, have a government pipeline of construction projects. For example, as I said, they're responsible for the lion's share of construction in the UK. So it's a mixture of carrots and sticks, if you like, a way of trying to accelerate the uptake of this, but at the same time having a sort of a lower level to try and basically pull the laggards along.
So I think it's quite interesting, and before moving to Johan, I'm trying to summarize the main points in this discussion. So it's not about transforming the way we represent our assets, the way we model our buildings, definitely. So it's going towards this digital built environment, and probably the ultimate goal is to improve the way we build, use our environment in a smart way, obviously. So the way we see it, this transformation, this digital transformation, is from bottom or middle approaches, like pilot projects from which we can draw experience, from policies and standards that will guide the way the sector and the contracts are signed and made, which also lead to certification, definitely, or require certification. This is a trend in large organizations, meaning that there is a demand from the sector, and definitely because of productivity reasons, economical reasons, and community, you mentioned the InnoHub, is a way to address these changes and provide some insight. But I'm wondering, I mean, beside this vision from the sector, the vocational training development that is ongoing everywhere in this field of BIM, things are going beyond, definitely. So, going beyond, I think I had two images just to show this shift or this move. So we are going from a status of BIM training today, which is mainly focused, or we have seen that, on using the software and defining the processes. So adapting, in most of the cases, the working processes as we have them, towards going further, let's say. So modeling for providing new services to the different actors, customers, users. So I would like to ask Johan now, for developing such new systems, such innovative environments, is there a dynamic in the skills that is required? I mean, can we look at how we build today and how we manage the buildings to anticipate what are the new skills related to digital technologies and so on? Or are there some other ways? Or first, is there a market, is there a trend in having new skills that are more and more required in the building industry and further?
Okay. So let me start with an analogy. So let's make a comparison, okay? Before giving a vision on what BIM is going to be, which neither industry or research really knows, okay, just proposing, but so what is building information modeling, right? So is a way to model information or organize information for construction projects, mainly for buildings. So what happens, for instance, if you go in another domain, for instance, what building information modeling, believe it or not, is an acronym also for business information modeling, okay? So what does it mean in business information modeling? It means that there's another information system that enables a company or companies to organize the entire activity of creating, developing, and implementing a project, okay? So, and I can go with other examples. For instance, in medicine, there's medical information systems, okay? So, obviously, what the community really and the different domains have looked over time is to find a way of formalizing a process or a way of managing a project or solving a problem in a more organized way, in a way that everybody understands. Okay, so in this field, in construction, building information modeling is really, I'm looking at this as a way of organizing information associated with projects, but also exchanging information and leading to the creation of a open collaborative environment. So this is exclusively how I'm looking at this. It may not be how this has been created early stages, but to me, if we're looking at how to organize information and how can we create data artifacts that everyone can understand, and how can construction projects can be developed in a collaborative community, my next step is how you can automate this. Okay, so this is something that I see coming now. Right, I've been involved in a BIM project sponsored by Innovate UK, and BRE was partner in this. But that for me was in particular interesting. Although the final outcome wasn't, so visionary, but at least the overall demonstrator had facilitated a way of interacting between different types of disciplines involved with the construction project, from start to handover and demolition, if you want. Okay, so imagine that we all have roles in a construction project. I'm a structural engineer. Okay, you're an architect. Coincidence is you're an architect. So, and everybody has a role. Now, my question to you guys is how can you facilitate collaboration, virtual collaboration, on a construction project where everyone can work based on their competencies and skills, but this environment would aggregate our competencies and skills and deliver a common understanding on the construction project. So the architect would only be able to see for instance, the BIM objects that are in his area of expertise. The structural engineer would see only objects that are associated with a structural engineer. The client will see the entire model. Okay. So my question is, how can you facilitate this environment which is automated, which is project agnostic? Okay, is generic, gives flexibility to all actors and roles, BIM roles involved in a project to action and to use their own expertise, and has a number of objectives, for instance, to reducing time, right? Reducing costs, reducing error or risk associated with the project, reducing delays. Okay, so now the way how I see it really is you also need to take into account, I think this was what the question is meant, the dynamic nature of BIM. Okay, so BIM is static because when it has been created, or when a community has decided the creation of BIM, at that point technology was evolving. Okay, so probably the dynamics part of BIM, they could not be seen entirely, but now when we assisting to an explosion of technologies, okay, technology explodes everyone. So everyone, if you have an idea right now, you can go and find technology and you can implement your idea. So if technology accelerates and there are new solutions on the market, technical solutions mainly, the question is how you capture this. Does this have an impact on BIM? Is this BIM vision required to adapt to technology, which is a common process in all other domains. You know, let's think about medicine. I mean, medicine 20 years ago was a completely different process. Now it's nearly automated. You go, you know, with the IBM Watson, you link yourself to a number of devices and sensors, and they say that you have a migraine or you have a headache straight away. So put it in a context of BIM. Can be construction projects, can be something dynamic, and can we capture this dynamic nature in construction projects, and how can you actually, what technology we need to use in order to address this. So really, going next, I would say that integration, looking at what technologies are available, in particular, you know, here's a question that I have now, which is, you know, often in research. Now, if you're looking on Google Scholar, you can find a number of papers, but the community on BIM, they're you know, rarely discussing this. How can you integrate BIM with RFID? Okay, would it make sense to integrate it? Of course. Can you integrate it? Sure, it has been done, but is there any construction projects that are implementing this now?
There was.
Okay.
It has been tested, but not widely adopted.
So if you put this in a larger context with the Internet of Things, okay? So everyone talks about the Internet of Things. It's a buzzword, and you know there are so many specialists, but Internet of Things is not a generic term. Internet of Things involves Internet of Services. Okay, so if there are services and relating this to BIM, what services can we identify in the field of construction projects? Okay, so Internet of Services, Internet of Construction services, or put it even more specific, Internet of Building services, and Internet of People. Okay, so if you have a BIM service, how can you associate a BIM actor? And is there any implicit correlation, and can you determine this correlation? So what do you need to do in order to understand that this role and this actor has a particular skill, and that skill is used to deliver a particular service for a construction project? So I think these are the kind of questions that I see that you know, the research community, at least, there is vehiculating this and is often is very much discussing. The industry is, you know, reluctant, but I think an instance of this vision is going to be implemented for the next decade or so.
Thank you very much. Do we have any comments at this stage? Can you help us in a way? Please. Any comments on this?
As a teacher and examiner in a subject called infrastructure asset management, I'm wondering whether we've got the wrong hat on. The primary goal of the hand-built drawing collections, SuperCAD models, etc., is that my clients who are building and utility owners can look backwards in time and say, how did we build this? How did we build it to be maintainable? And what are the steps in maintenance on a health and safety basis that are required? And actually, we seem to always push it from design principle forward rather than from end use backwards. And I see some very dangerous things being designed and proposed, which should be headed off in the past, particularly in areas that you might think about enclosed spaces, sewerage tunnels, underground facilities, etc. So maybe if we embrace more the owners and insurers of the buildings to say what do they require as the output, that will be step one. Step two, which I'm intrigued on the Finland model, is who's paying for all this? See, if I'm a client and I say I want some as-built computer models that are in PDF forms or CAD form going to be sustainable for decades, then got to accept that that is a very expensive part of what I'm buying. Like the instruction manual you expect with a modern telephone, etc. By the government's intervening, saying thou shalt, it puts a lot of pressure on these small businesses that we talked about earlier to train at great cost people up to do what? Because they don't see, in the old days, they don't see the cathedral built and used, do they? If you go back hundreds of years. So I think perhaps we need to start mandating percentages of our project and project use, cost in use, like the old DBFO systems, is put aside for this. And that therefore the clients are prepared to sponsor the prime contractors and their entourage to undertake these best practices to give me what I want, which is high quality, as-built, functional drawings in 3D, like that there, that I'll be able to use in 2050 on my new airport terminal. So, I wonder what your views on that is.
Just to expand on what Andrew was just mentioned, if I take a sad example of one of the Grenfell towers in London, fortunately, how many people have died, it's a disaster. I mean, with the use of BIM, let's think a second, with if the, at the time, BIM was used, would that make a difference, as to the outcome of what we know now? Something I want to highlight really is the importance of what Johan has mentioned, which is the Internet of People. For sure, the residents of the Grenfell Tower have been complaining on social media about some of the problems they're facing on a daily basis, including, I should say a lot because the investigations are going, but certainly in the press there were reports that people have been complaining about the fire system, about the number of issues, and certainly haven't, no one has reacted. So the question really is, what is the role of BIM in preventing these disasters, and whether BIM on its own is sufficient, and whether we should not really expand on what we really do BIM and involve people more into the specification and use of BIM. So using this example as a, I don't know, just like a few more.
I'm afraid I haven't got the answer to that. It's a very relevant question. I think part of our scope of our project is those sorts of individuals are able to fulfill their tasks. There's a need to work with directors and owners of SMEs to raise the importance of this, get them to properly embed apprenticeships in their own training program as part of this sort of a sea change. And so this is all about this bottom-up and top-down. It's trying to facilitate this particular change in mindset, but also having the regulatory minimums to make sure that these things are properly done. I'm sure you'll see some significant changes coming from the training that was Grenfell in terms of enforcement and compliance, for example.
I'm not sure if I understood the question or the idea right, but I was thinking about BIM also reaches to the use of buildings and the maintenance area, and it's totally possible and also tested that in future you can monitor indoor performance, indoor air performance, energy performance in a very easy way, and it will not be too expensive to have your facilities monitored. And with that data, if you have it all in we can call it a BIM platform to organize and to analyze that data, then you can be sure that your environment will be healthy and safe and energy efficient. In that way, we come closely to end users and their environments with data. And in building automation area, this is being studied a lot. So it's actually called information ecosystems.
Thank you.
This is better.
This one's better. Any comment in the room? It seems to me, just to add to the discussion, that this is about traditional engineering, any other meaning than defining the knowledge about the different behaviors we need to analyze, take care of. When there are some events, then the engineering processes can be updated, questions improved definitely. But I think here, I think that beyond using this BIM platform, the challenge is not to manage the risks that we already know and have improved in the past, but this perhaps in the case of a risk at least, to discover new ones. And that could be also something that can happen not only from engineering analysis, but from the treatment of a lot of data. And part of this data, an important part is human-based data, so the perception, the way the people, the users, the occupants behave in the buildings, and how they use it, and what's the impact eventually on health and safety and other kind of services that the building should provide. So this is a shift both in the management of the information, but also in the management of the use of the built environment itself, buildings, districts, and defining the new or designing the services that should be provided by this environment. So I think should we pursue a bit the discussion? Although we went quite large already, but could be interesting to have some insight, perhaps on the way professionals should upgrade the skills. So I would like to go back for a few minutes to Richard and Johan in particular. First on the way the professional career can be developed today, and what are the current status and expected developments in the training, in the form of training. What are the gaps that are identified today in the the building industry. So if you can elaborate on this topic, please. I would say that we can start with you, Richard, if you agree, and then pursue the argument.
Yes, if I understand the question, it's looking at the training provision of BIM and energy efficiency within the project partners and the EU in more general terms. That was part of my particular task in this project. When it comes to BIM training, I think we're reasonably well served, particularly at the design construction phases of a project. I think the main gaps seem to be in terms of in getting better informed clients and also those who are responsible for the operational maintenance of the building. That seems to be where BIM training is a little light, but it's certainly something that is growing, I wouldn't say like Topsy, but is being developed considerably through training organisations, private training organisations offering the BIM services, particularly, as I referred to earlier, BIM Level 2, but also within universities themselves are bringing bespoke master's course, and waving a flag for the scene. We've got one at Cardiff starting for the first time this September. But there are others up and down the country, all with a particular bias towards innovative products, project management, or whatever. So the student community is starting to get reasonably well served, and also a lot of the traditional construction disciplines, be it civil engineering, structural engineering, architects, planners, surveyors, all have BIM as part of their syllabus, either as a sort of a standalone module, or perhaps as a phrase, sort of golden thread that runs through all of the modules. It's a case of trying to pull together all the separate disciplines. So there is a lot of training out there, other than the obvious gaps that I've mentioned. When it comes to BIM and energy efficiency, the picture is rather different, I'm afraid. It's a lot more, there's a paucity of training. That exists probably, again, is in the design community, playing around with the models, the lovely pretty models that we saw earlier about bringing together energy efficiency and BIM. But the particular challenge is sort of in the management, facilities management, maintenance of buildings. That seems to be where the key gap is, and that's where the apprenticeship market is looking to up its game in order to better equip individuals to manage buildings in a more efficient way. Although the focus of our project is energy efficiency and looking to address the sustainability challenges and the performance gap, it is a much wider situation in terms of the general health and safety and performances of buildings, as we've already touched upon earlier. So that in broad terms is sort of where we are with BIM training. That's about it.
Yeah, so I think to elaborate further and just to introduce or ask you the question, the new skills that are perceived or identified, what's the best way to discover them? I mean, today to follow these new technologies and new ways of new practices.
Okay. So, leveraging on my previous discourse and on feedback from Richard, BIM is dynamic, so I think it is going to be dynamic. There'll be, right, so a domain or a sector is obviously, you can look at it in two ways, right? You know, buildings will be buildings. You know, your buildings will have to play the role of a shelter mainly, and then should give a comfort to occupants. Buildings should have some efficiency in terms of cost and energy. But I think more importantly is that buildings are going to change in future. Construction, I think, is going to change in future. Don't know if you disagree. If you disagree, yes, we can talk later. So BIM is going to change in future. There will be new roles and new skills, right? The question is, two questions here. What will be the new roles and new skills and competencies that will be required? And secondly, how can those be captured in an automated way? Because you know, user behaviors and construction projects, they are not now, they're obviously they have their own traditional approach of developing, but I think this is going to change as well. So the way how a construction project is going to develop, it will change. So for instance, Constrain, that they are doing now highways, okay, they had a particular methodology that they were employing 10 years ago, but now if you're looking at Constrain, how they develop highways and how they model everything and what simulation they perform and how they implement this, you can straight away see an evolution, which is going to be more, even more obvious in the next few years. So the question is, how can you respond? I think this is the question to this transformation of the industry by identifying novelty in BIM and identifying new roles and skills. Okay, so we know several roles and we know several skills in association to roles, but the question is, can this be automatically captured and can be this captured in time so they are addressed in time by trainings and by other type of educational forms? So what we've done really in the BIM project, we've looked at sources of information, alternative sources of information, right? So information now, as in computer science and in other domains and in engineering and in medicine, information is available on different channels. Some of the channels are considered to be non-traditionals, and people simply ignore it, those channels. So, you know, you can have, for instance, if you want to identify new roles and new skills for BIM, you can check the scientific publications or the standards and say, okay, there's a new standard, and that here's a new role, here's a new skill, and then you adapt your project and you possibly implement that. But what we've done, we said that you know, construction professionals, actors within the construction domain, they are more and more active on social media as regular users. I mean, you know, I've told this example in the morning, I'll reiterate this. If a British citizen goes home at 5 p.m. in the evening on a rainy day, opens the house, gets in and says, oh, this is really cold. You know, my boiler really doesn't work well. So the question, and he tweets this, he posts this on a Twitter or in LinkedIn. The question is, okay, this is a good behavior because, you know, the behavior is to externalize a reality. I wouldn't know from my department, I wouldn't know that that citizen is experiencing some comfort problems in his home. But at the moment he's externalizing this to a social media channel, I can do mining and understand a number of things about him. I can even understand when he's watching the TV, you know, how many kids he has. So my question is, are construction professionals or construction projects that you see now, especially with the European Union, they are externalizing these sources of information on data on social media channels. For instance, we get a new project on sustainable energy. Our new BIM training program has been successful and we've delivered this. So if you do mining on this, can you understand something? So what we've done, we've identified a number of Twitter accounts in relation to BIM in Europe. So we've taken from all European Commission, we've taken all our partner suggestions. We have done some forensics analysis on some web activity, and we've identified some companies that activate in the field of BIM. And then we looked at their Twitter graph and Twitter profile. And we fetched their entire Twitter social activity. And we've managed to aggregate around 40 million tweets about BIM training, skills, competencies, professionals, projects, and so forth. And we've applied analytics on this. So we've applied some language processing and expression analysis, and we come up with a set of new roles and skills for BIM projects. So, interestingly enough, you know, in my previous intervention, I mentioned this IoT and Internet of Things. One of the roles that we've identified by crawling Twitter, social media was, and perhaps we can discuss this, I mean, I'm putting this as an open question, it was IoT expert. So IoT expert was identified by our algorithm and as being a role for BIM training and education, and BIM implementation, really. So we've identified an amount of different sets of and skills and their correlations, which are quite novel to BIM. So from this, we've drawn the conclusion that BIM is dynamic. BIM is not static. You know, roles and skills that are applicable now, probably they will be, they'll be extremely not unuseful, but probably static for future construction projects and future, this vision of digital Britain and digital cities and future cities. So this is how we use social media channels, but really my impression of this is that the community and the construction industry is on one hand very open to hear about new technologies and new methods to address a particular problem, but is very reluctant in adopting a particular technology or a computer science method or algorithm which can significantly improve the process management, the time and risks and so forth. For instance, and another open questions alongside this dynamic and social media, the open question is, has anyone envisioned to evaluate the risk or to assess the risk associated with the construction project utilizing a BIM-based methodology? Okay, so has anyone, risk is something, that is something needs to be managed, and risk has, significant implication on a project. By the simple fact that you know how to manage risk or assess risk correctly, there's a direct dependencies to a project being unsuccessful or successful. If you don't manage your risk, probably sooner or later the risk will have an impact on your project. So here's another open question. How can you manage risk in construction project using a BIM-based methodology? So I'll stop here, but let's see if the audience would like to participate in this.
Really glad to raise that. A guy set up a business in the late 90s ended up with a contract to digitally map the electricity distribution grid of one, London, and two, the northwest of England. in a way that he was, if he wasn't careful, double encrypted multiple server access, a bit like GCHQ, which he built in from the start, because he realized he was concentrating knowledge on potential terrorist and related risks for the entire nation. Because obviously if he knew where all the electricity redundancies and systems were, say for the underground or parliament, etc., government departments, then that was an enormous risk. One of the things we need to be very, very careful of is the assumption that collaboration is some form of open network, Twitter, etc., when actually half the time we're dealing with mission-critical infrastructure. Another one to think about on the same basis is airports, obviously, where you've got the plans of new terminals and access points of airports and the underground tunnels that you can access behind the scenes to get to the maintenance depots, etc. So maybe we need to think of security in the round and come in the modern world more from our, how can I best describe this, in my 6GCXQ approach to how much information do we need to disclose, who's defining what is critical in information terms, and therefore, is the corollary, is that critical information only available for licensed, fully trained operatives who have signed confidentiality agreements, etc. So we have a sort of contradiction. We want freedom of information, but we want our information on critical assets to be secure. So where do you stand on that?
From an owner perspective, we want the more information as possible, not to share it, to use it internally for their own purpose. And this leads to reluctancy in modeling the information first, as well as sharing definitely information.
About BIM and risk management, I think there is, should be already finished, doctoral thesis going on, led by, or the professor, one of the professors has been Arto Kiviniemi from Liverpool University about BIM and risk management. And it's difficult if you really go deep into looking for the data and information and where you how you really could somehow predict in advance that what you should do to avoid risks. But an easy way, a more pragmatic way is to concentrate also only on design quality risks, because it's quite of easy and there are possibilities to visualize them better. You can use an easy visualization in transport infrastructure areas. In Finland there's been one case study to try to visualize design-based risks just on a map, and they assumed it helped very much to understand the holistic picture of I think it was a highway project. And important is also if you notice the risk, you visualize them, you locate you have a location of them, then you also should have an evaluation if you can avoid them totally by design or just minimize it. And in that way it will become a more structuralized process during the design. But the other elements of risk management, they are more demanding.
I'm not a BIM expert, so I'm afraid I'm not able to answer your sort of questions in terms of the direction of travel, in terms of the availability of information and the security implications, although part of the digital building strategies, I think he's definitely addressing that. So I suppose I was able to watch this space, but I thought I would just add an interesting example from our own experience at BRE as an organisation that's been going since 1921. It wasn't known until about the 60s we were actually involved in the dam busters raid, in terms of we were doing some of the initial testing of the Merna Dam and seeing where you put the explosive devices to basically find that point of weakness. Our work was greatly assisted by the freedom of information on the blueprints of all the dams that have been published by the Germans back in the 1929-30 or whenever they were put together, holding it up as a sort of an exemplary example of engineering excellence, which of course they were, but made the information freely available to future aggressors, in this case the Allies, to basically find the point of weakness to try and blow these things up. So I just thought I'd add that as a sort of historical example of the sort of issue that we might be faced with the widely available information that BIM can actually offer.
I'd like to start by congratulating the panel and thank you for being here with us. I'd like to take 2 or 3 views on this. Perhaps are a little bit different, but I think nevertheless they could be somehow interesting. First, I'll start by a positive view, which is cities and towns represent a huge amount of assets with limited control, and they also represent a huge industrial sector in terms of economy. How BIM can reduce this risk of limited control, improving the control of this industrial sector and huge assets. So that is the positive view that perhaps BIM could have, but I'm addressing the panel to clarify this point. A negative view, perhaps, is in which extent does BIM limit or control the marketplace to certain countries, to certain companies, to limit the access to other countries and other companies to this business, which is construction, that is going to grow a lot, especially in countries in development. And as you know, the big buildings, the big initiatives are controlled by half a dozen of companies. So are they becoming more greedy, even trying to control the rest of the business? That is going to grow in the next years. So that is my negative view, because I'm a little bit old and suspicious. Sorry about that. The neutral view is about control and about the taxes. So since that BIM enables the full digitalization of these assets, the building assets, so this is going to enable a much bigger control by the local councils. I'm saying a neutral view because in principle taxes are good for people and not really a bad thing, hopefully. So what about local councils? How are they going to deal with this problem? Are they becoming greedier even, or are they going to use the money they are going to collect because they can charge in real time? Oh, you changed this door, good, now you pay tax for the new door, and so on. So I don't want to spend more time, so thank you very much. These are my questions in my mind right now. Thank you.
Very interesting comments and questions. I'm sure.
There were so many questions. Thank you. Thank you for your ideas. I would start from the fear of transformation of the industry from the legal processes. We have building permit processes in construction, and they are going to be digitized also and BIM-based also. So from the authorities, I think it will, when they are also involved as one main stakeholder in the digitalized built environment, then I think the market will be changed in a way, more or less totally. First the new buildings and the construction, the renovation and the refurbishment buildings will follow a little bit later because they are more challenging. I see this as a total transformation, but of course it should be there should be enough time to adapt and learn and train and change the market. If we take Singapore as a case, it's a town and it's a state, and they have actually done this more or less. They require everything BIM-based. They collect the data to their town planning or needs and all the stakeholders who are going to design or build in Singapore will have to do it BIM-based. They will be given training. They will be given time to adapt. They will be given money for the softwares. I think it was something like 3 projects you can train, and then you need to show that what is your rate of efficiency. And even if you cannot achieve them, then you have to then pay some money back. So they go really hard way, really like this is the way to do. In different countries, in different cultures, it will be a little bit different story, but I believe in total transformation because of 2 processes are expensive, very, very expensive. We don't have any organizations or building owners who can have 2 processes at a similar time. It has to be totally digitalized, or then you have the old manual process. But if you have them both, then we don't have any future. That's how I believe. But when this all happens, and which will be the next technologies which will help us to do this. BIM is not enough alone. There will be new technologies, artificial intelligence, IoT, semantic web, blockchain. All these new emerging technologies will help to go forward. I think it's we are still lacking some good technologies to really do the big change. But already at the moment we have some technologies which are mature enough so we can do our business more efficiently and more collaborative also, and that means should mean more quality also.
Some other aspect, I'm not sure if this will be addressed, is regulatory risks. Large projects
obviously the context is evolving, construction projects are changing a lot during the design and construction phases. What comes now from both scientific activity but also industrial activity, largest construction project is a mix in between the use of BIM, which requires and by the largest experience, and the definition of lean processes in management, in construction. So using the traditional industrial lean management processes, planning system and so on, as well as in design where BIM and the planning of information delivery processes themselves is a way of improving the processes.
One of the things that I've come across is that there are a number of projects that are looking at existing buildings. And if you think about existing buildings, the great majority of them don't have BIM models. However, we're going to have to live with those buildings, they're not going to go away. And there's a lot of projects that in the real world as well as in the research world that we're looking at refurbishing them to make them more energy efficient. There's also other projects that we use buildings for, like indoor positioning systems or, you know, various different applications. And it would be really good to have BIM models and people have expressed the like of that. So I'd really like to hear if anybody's got a wise solution for overcoming that challenge. How you be able to share information with BIM models or create them in a quick, pragmatic way, but also your thoughts about how we can with existing buildings without BIM models.
Does anyone want to answer?
The current practice is that there are technologies to do the BIM model. It's called, you can call it initial data model or inventory model. The problem is that I don't know who has not been active enough, but clients normally hesitate to produce this model, which is technically quite possible to do, because it will cost a little bit. But if the project in question is something that you need to study for several possible alternatives for renovation or it will be an infill building or something like that, then it will be worth making the inventory model. There's a technology of using drones and laser scanning the existing building and in that way to build a rough BIM model. What is also important to remember that normally you will also demolish some part of the buildings and then you need to do a more detailed model. So it will bring some extra.
Actually defining which processes they will need such information. So it can have very different needs in terms of what is modeled. And if you don't know exactly what will be the processes that will use this information, then it's usually require the modeling outsourcing or something. And in several cases, I was in contact with facility management teams that wanted to have scanning and initial BIM modeling, let's say, of their existing buildings, but they didn't know exactly what the processes would be for using this information. Like if you think to electrical plugs, you can have it in the model, you can have it placed in the room, placed on the wall, placed at the exact height on the wall, and this will complexify the modeling process and then the associated cost. So if you don't know prior to the modeling process or contract what you need, then it's complicated to say contract it and be sure that you will finally get the information you will need. So often it's about re-engineering the processes themselves before the project.
So next is lunch over in Aberdeen. Also, once you finish.
So the main explain them that this is not easy because it is required also a big investment from them. But it is, I think it is interesting, this feeling to be isolated from the rest of the Europe and to ask for help in order to open their businesses and to create a new collaboration opportunities with other countries. The funding opportunities are not strictly related to the Horizon 2020 calls program, but also to opportunities that can come from our Italian government or the regional authorities that they can have. In the newsletter that they receive every 2 months, they are informed about this. Okay, we are in the program together with the bank. Okay, the interest to this kind of agreement comes also from the bank, because it is important for them to have an evaluation, also a technical evaluation of the enterprises, in order to understand if they can invest and they can help these enterprises from a credit point of view. They are able to do their financial analysis of the enterprises, so starting from the financial data that they can collect from the enterprise, but they are not able to evaluate if an innovation idea is a strong idea or not. So together with them, we help also the bank to understand if the idea that the enterprise want to develop is a good idea in order to be also financed from the bank. experience together with these big enterprises in order to be considered also by other clients. So they have these kind of problems. And this creates them a big problem during the financial crisis, and so they have to reduce their staff, their employees. With them, we are trying to help them towards new technologies for their products, and also we are trying to introduce them in some research project together with these big enterprises in order to start a collaboration that can help them to open new markets. The last one that I'm going to present is a company that deals with the production of special balls. Again, in this case, they start with the co-design together with the automotive company to which the product is destinated until the production of the products of the final company. Okay, the enterprise is organized with three, we can say, three different departments. The problem of this enterprise is that they have very old machines. Okay? Almost all the machines exceed 18 years. So it is hard for them to apply new opportunities to exchange information also between the machines because they are very old. And one of the proposals support initiatives for small and medium enterprises and to support them to have the same opportunities that the big enterprises can reach by themselves without the help of other institutions and mainly the help of a bank that can give them the power to start new programs. Thank you very much. I have the last slide.
Okay. Thank you very much. So, yeah, we can start the discussion and then we should go for the second presentation. So we have time to do that. So if you have any question to, yeah, for Teresa, welcome. Yeah, please, Ricardo.
Actually, I'm just curious. One of your statements said that most of the entrepreneurs feel themselves a bit, let's say, separated, isolated. So, after 30 years of VC-based funded projects, so companies still feel like this. So, and I knew, for instance, in the last edition of ProVE in Vicenza, we have heard about many governmental programs to support the industry, etc. So even though companies feel themselves isolated, so what helps the feeling about
Yeah, good question. I think we share the same feeling. And I'd like to really hear from Teresa about that because usually in SME this is a problem. In fact, but let's.
Okay, we met the owner of a very small enterprises. Okay, some of them coming from the agriculture background. I remember during one meeting, I entered in the room and I felt the smell of the house because they used to.
Yeah.
Okay, these kind of owners with not so
business oriented.
Yes, but also sometimes it is hard to communicate with them by mail.
push.
listen the proposal. When we started to meet the owners, we understood that the one that were really interested in this kind of program because they felt themselves isolated from the rest of the industrial community, where this kind of owners, this kind of we can call them manager, but it's hard to use this this one. Really far from everything that is a frontier for the daily business. Okay? So we met this kind of person, and I think that it's true their feeling that Europe and that the European opportunities are for the one that are able to read in English, for example, or that are able to use ICT opportunities, or just that are able to use smartphone or computer. We are meeting entrepreneurs that don't have immediately these abilities, so they must be able to also this.
Okay, nice question. I think I share the same, let's say, the same opinion. Usually in SMEs, I think it should be more or less the same, like in Italy or Portugal or even France. Usually they don't have specific staff to follow these kind of opportunities. And so there is, let's say, a sentiment of something like, well, usually this kind of programs is for large companies. So the people usually doesn't have, let's say, permanently someone looking and participating and so on. This is why I think in this project your department is a kind of mediator, like a kind of broker, let's say, to show the advantage maybe and the opportunities that these so small companies can.
Sometimes they don't have the human resources that can be dedicated to this. When they ask us for Horizon 2020 opportunities, the first thing that we clarify is that you have to do a lot of work before to ensure that you will be financed for this project. This means that you have to dedicate a human resource to work for 2 or 3 months to prepare a proposal.
But who is responsible to, let's say, to design and to prepare the proposal? Is the company? Is your department?
Or our department, or we look for, because it is not possible to develop several proposals.
But the promoter later on, the promoter will be the company.
In the program there is also, I can show you, but there is also a group of professors in this area that focus on this program knows, and that has accepted to help the development of this program. Some of them, if they find a topic that is particularly of their interest in the research, they can accept to be front university in the proposal preparation. So enterprises together with enterprises belonging to other countries.
And in that kind of projects, you try to, let's say, to involve more than one company, because there are companies from different sectors that they can share, let's say, most of the time the same problems. It means that the solution for one company could be also interesting for another, from another sector. They are not competing directly. So this is interesting, let's say, to explore this kind of cross between, let's say, different sectors and to take advantage of the results.
Sometimes they can be different case studies of particular idea. So it is interesting.
So they can
These
apply.
Also
Yeah.
if we are to share abilities or to share
role of the banking group is to guarantee enough support to funding. This is mainly, I suppose, for local projects, right?
Yes. The help from the bank is, first of all of these enterprises are the clients. And we have seen that the relationship that the owners of enterprises have with the bank is really a personal relationship, because to every enterprise, the bank associates a dependent, I guess, sort of they call but a person that start a very close relationship with the owners. Sometimes they look like friends. This means that the owner in this way really trusts the bank and the interest of the bank to really help them. At the same time, the bank want to help them, but obviously they don't want to take new risks. So they need also a technical evaluation of their businesses. And the second one is for particular innovation or development maybe not innovative. It is important to have the help of the bank also from a financial point of view in order to give advice. If the bank knows that the idea is a good idea, an evaluation about the future, they can reduce their risk, and this way they are more
Okay. So, more questions? Yeah.
As any system, SME they experienced before growth, and maturity and decline time of the evolution. And of course, they are different not only by sector of industry, but by these phases. I have a question. When you analyzed your SMEs, did you take mostly SMEs from the phase before growth or from all the phases?
We consider all the phases, we consider also this it depends on the kind of enterprise. Since the relationship with them is very close, we are also able to evaluate the entrepreneurship abilities of the owner, which is the one that decide. Okay, they don't have administrative concepts, so you can have the feeling directly with the person that is speaking with you, if he is open or not to new opportunities, and this can influence also the development in the future. So we consider the history, we consider also the abilities of the main decision of the enterprise in order to see if he's open or not to new opportunities.
Yeah, because the role of innovation in different stages is different.
Yes.
Before growing, okay, they're building kind of startup. So after, when they're growing, normally they say, don't innovate here. We are growing, everything is okay. And when they start maturity and decline, they start to look new opportunities. So that's why I posed my question. Because according to examples that you showed me, probably I'm wrong, but I have feeling that those are just kind of startup. That they have idea, but they have no idea how to make business out.
I think, yeah, this is a very interesting point, but I think, and Teresa can confirm or can, let's say, details, I think these kind of programs are relevant for stable companies. It means for mature companies, not startups. This is interesting for, let's say, family-run business, things like that. So it's companies who very well established in the market, but maybe facing problems to, let's say, they don't know how to upgrade concerning technology, something like that. So there are, but from market perspective are quite stable. So it means it's a little bit different from the startups, and I agree with you.
The example about hydraulic company, if is a lure, you know. Yeah. If the company, they enter to the market, they make a patent. That's,
yeah.
It's a rule of business.
Suppose a company with 25 years, something like that.
It's not so much years.
I think this is the most common situation, maybe 20 years, 15 years, I think like 40 years, something like that, are so stable, but then they are facing problems because there are a lot of changes in the market from technological perspective, and sometimes, or most of the times, that companies they don't know how can take, let's say, how can explore advantages and opportunities, take into account the programs available in the market.
They don't know, sometimes they fear that
They think they don't know. Yeah.
They don't know. Here in this case, we met the owner that was the father together with the son. And the son has a different approach.
Yeah.
But the father was very fear about something that
Yeah. This is why the feeling of isolation.
Because it's a company.
This is why they feel this kind of isolation, because in a startup usually it's so different. The people that, let's say, are involved, there are a lot of contacts with research institutes, with universities and so on. It's really different how they can, let's say, explore opportunities.
we also met two very young guys. They inherited from their parents a food company. The parents very young also, 50 years. But when the guys was up, they were about 21, 23. The parents decided to leave the company to the sons. And they came in order to be helped to change the business of their parents in order to do something new. And so this was the origin of the new opportunities that we wanted to find. So you need this jump.
Yeah, but this is a startup situation.
Yeah.
So probably in order just let me understand, next to your presentation, if you can make a distribution of different maturity.
Okay.
Because innovation play different role, different phases. It will be interesting to see, to understand better your findings.
Yeah.
Thank you very much.
Thank you.
So, I don't know if I have any, a last question.
First of all, thank you for the presentation. In my opinion, one main issue with SMEs is to distinguish the real innovation needs comparing to the consultancy needs, the technical support and things like that. So I just want to know how do you make the difference between
you, Teresa, for your nice presentation and to share with us this important initiative. And now we'll continue with the second presentation. So I invite Andrew to start the talk about collaborative networks and the 5 regions of the future.
Things that came to mind from my experience, Teresa, was working with a lot of small businesses in Yorkshire. Secrecy. People don't like to disclose their inventions and money. And secondly, the cost of bidding for large projects is so high that somebody's got to lead from the front. And classically, that needs to be somebody at the owner or director level or a consortium. What I've always found challenging is who's paying for that time. Because if you had a private company, you'd expect the bid cost to be absorbed within your organisation. So I thought I'd give some context here. Firstly, this is our, if you came over to Bristol, our beautiful Gothic tower that you can get up on Saturdays for a few pounds and give that to charity. Get a great view of the city. Many years ago, I went to a seminar in America and met a futurist called Joel Barker, a tremendous gentleman, and his book about paradigm shifts, I think, is one of the biggest selling business books in history so far. Anyway, he did some work with another futurist. This is a profession, believe it or not, futurism. And they collaborated to look at maybe some sort of ecosystems of technological development. Some of them to challenge the way we're currently thinking. So I thought, given we're supposed to have a bit of interaction here, maybe as I go through the talk, you want to, a bit like last night, write down some thoughts or ideas on some of the things that are going to appear here, because there's some interesting propositions. It's really the first question is, how would collaboration-based research work in each of these regions we're going to cover? And then what's the time horizon? At the end of our paper, we've written 0 to 5, 5 to 10, 10 to 20. So it's rather like that United Nations challenge we was set yesterday. So this is the cover of the book. And this little quote's interesting. 5 Regions in the Future is an original, serious and challenging book that deserves a wide readership amongst thoughtful people. So I bought it. So basically, that picture on the front, and I've got a more detailed version of that in a minute. The talk is this introduction as to what the concepts are. I'm going to go through these 5 regions as Barker and Erickson would propose, and then maybe look at the way forward. So, to write a book, I mean, I write books, but I don't undertake challenges of this scale. 25 years work, 2 world-class guys, researching 10,000 plus articles, hundreds of interviews with inventors, engineers, world-changing guys. And this is what they came up with, this terminology called technicology. Everybody has these fancy expressions. This is a challenging one where you're typing it out in a paper and an article because it keeps thinking you misspelt it to be technology, yes? So the number of times I had to spell check the paper was a lot. But it's just to absorb this from it. A complex ecosystem of technology where the individual elements are made of the tools and techniques invented by humans that interact in a mutualistic and competitive manner to increase the variety of technologies and the complexity of interaction. A very big paragraph with a lot of profound statements in there. what they're really saying is if there's a mutual reinforcement in a particular, let's call it region, that's what their definition is. It's not a geographical region, it's a change management region. Then you can get some tremendous quantum jumps in well-being. So, the first region that they call super tech is pretty much how we're living today. Yeah? We have our smartphones, our MacBook Pros and our battery chargers and electronic plane tickets, etc. And we just get so used to using this. But the general concept is, with the way we're heading, it's bigger, it's better, we want more of it. And ultimately, as I mentioned many times yesterday, fusion power, free power, limitless energy to charge all our devices. Limits tech. This is one that I'm personally very interested in. And it's saying, are we making the best of what we've got? Can we reuse materials? Is there a constraint on mankind's sucking up of the world's resources? And there's some very eminent scientists who work in this. Local tech. Now this is fascinating because this we touched on in our group yesterday. This is like my little village that Clark came over yesterday. Small, local, how can we support each other? The old high street, as you might imagine, the butcher, the baker, the candlestick maker, a coffee house or a pub. And of course that's how commerce was created. The mighty Lloyds of London started with a bunch of guys reading a newspaper in a coffee house in London. So there you go. Nature tech, that's where we're harmonized. Some people think, oh, what's this all about? This is really saying where we're living at one with nature. What can we learn from nature? And I guess as a potential future in big zones of the world where the promise of super tech may not be achievable, but what can be adopted from the principles of that super tech to help them out. Small example obviously is if you've got a farming community with one mobile phone that knows the price of grain, you've heard this story before I guess, they know when to harvest to sell the grain at the local market just from having text messages. So they're living and growing stuff in the countryside, but just touching on some technology is able to live well. And then finally human tech, that's very fascinating. And that is the super science that we're seeing in newspaper articles every day now. Genome tracking. I don't know if you saw, but some colleagues of mine at the university have sold an invention, something to do with insulin. I have no idea what, but my eyes popped out because I think it's several $100 million have been paid for their company. This is a guy who's just finished his PhD a few years ago in his late 20s and is a professor, and they had this enormous purchase of their company. Bolting all this together is this thing called universal technologies, which really can support many of these regions. Oh, killed it. I think the on-off button is very close to the button. So these are examples of universal technologies, and you're thinking, I did when I was writing this, oh, well, we know all this. This has been knocking around. You've got to remember, this was what they were thinking and publishing in 2005, so researching in the early noughties should therefore put in their book. So things like 3D printing for manufacturing, if you go back 16, 17 years, that was a dream. We're doing this now. We're 3D printing houses. And actually, as I walk through the laboratories of my departments in mechanical engineering, every student, they've got a rake of 3D modeling printers where they're doing prototyping and physically presenting these objects. And they might be wings for aeroplanes, they might be new hydraulic systems. It's absolutely astonishing. the ingenuity of, at a very young age, teaching them the technology and then being able to print that. Hydrogen fuel cells, well, that's the wonder dream of the automotive industry, I guess. Lab on a chip, I'll give an example of that in a moment, and space satellites, computer simulations. Obviously, we've got a lot of satellites, they've been around for ages. I don't know if you saw last weekend, but there was a satellite launched, is it called something like Nanostar or Navstar or something? It's an unbelievable satellite. It literally has the power to track ships in the ocean and work out where the potential risk of piracy, you know, other small, very small boats coming very fast at big ships. And it's a sort of commercial version of what we would normally class as espionage type systems, hugely powerful. And e-books. Joel in the late 90s was forecasting what we now treat every day, our iPads, our Kindles, etc. He developed the original concept. And actually this guy developed, with a company called IBM, the concept of a small computer that might sit on a person's desk that has the potential to empower people to do work in their own time. He did this in the late 70s using a paper system called the implications wheel. And this company was consulting with IBM and said, I'm not sure that'll fly, but we'll give it a go. And actually the original concepts of the personal computer came from some of these research. It is 25 years before this. So this is what the model looks like, and we simplify it by, because it doesn't fit on the diagram otherwise, NT is nature tech, limit tech, yeah, local tech. So the universal tech lives at the center, and our collaboration modeling, I think, is the glue that combines some of these. So as an example, you need nature tech, universal technologies, computers, etc. Human beings, because obviously we use all this stuff or we're designing all this stuff, and we create, let's use an expression, an aligned impact. Because if you don't do stuff with new inventions, etc., mankind doesn't progress. So that is a massive opportunity for us. And at the end of the presentation, I'm going to challenge you to say, which do you favour? You might take a vote on. So that's the example. So the aligned impact there, in this case and in the paper, I'm going to talk about something called galantamine. And I had no idea what that was till a chemist told me absolutely fundamental chemical for delaying the onset of Alzheimer's. Oh, right. So you get frameworks from everybody. You've got Joel's and my interpretation of Joel's, but this was really whizzy because this was in my Sunday papers. This is Imperial Colleges. I know you can't read it, but if you go to that there, you blow it up, make a poster the size of the wall and stick it up and challenge it. So, we have here a time horizon as you move out in time, and up that side, and this is just part of it, is like disruptive impact, social impact. This framework is saying some of these technologies, where it's looking at time and impact, might change the planet. And if you get way up right, you know, it's off the map here, you are literally like, you know, mining the moon, stuff like that, yeah? And I think somewhere around here is smart nappies. Now, I'm not quite sure what smart nappies are. I guess they've got some sensors about the well-being of the child. I don't think the nappies change themselves. So that's a very good framework, and I strongly recommend downloading that. And I've given that to my students, and they go, wow, there are people really researching this. And each of these, you know, this is like NASA, Johannesburg, talking about water pebbles. I mean, it's a fantastic resource. Anyway, it's a framework, but the issue here is it's not in an ecosystem. It's literally statements of the disruptive technology. So it's telling you who's going to cause the problem. It's not telling you what the impact is and who's affected and how it might fit. So this was a very entertaining task for a wet Sunday afternoon. Imagine having to go through the abstracts of the last 4 years' ProVEs and formulate which technology segment they live in. my best interpretation. Can you spot anything? Straight question. What's the dominant subject area that for the last 5 years or so we've been focusing on? Obviously because of the way we're funded and formal research. But we are often proposing super technology, collaboration systems based on interactive Internet of Things and I40, all that stuff we talked about yesterday. Very, very little about local, limit, nature and human. Very little. So my challenge is, if we're looking forward on a 10-year research program, perhaps some of this stuff needs to be considered. And maybe we ought to have chemists, scientists, physicists, doctors, people like that as part of our conference team. So a few years ago, 2 years ago I think it is, because I remember Luis kindly sent me the hyperlink. We had a session where I think there was 10 young researchers. It would be in Porto, yeah? And I was fascinated. They came up with these really great ideas. 5 went for super tech stuff, things such as regulation of 5G mobile tech. Well, that's absolutely brilliant because that's multi-billion-pound industry. Actually, the dean of my engineering department invented the software and some little hardware that created 4G as we know it, and so we've got big interest in 5G and mobile tech and laboratories at the university. 3 chose some form of limit tech. I like the one on constraints in the future employment of millennials. I'll tell you for why. When we wrote this, I thought, well, that's fascinating from the position of young people putting that forward. If I told you that I got an email yesterday from Joel wanting me to help him build a supercomputer model called the implications wheel on the impact and future of millennials in high public office. You might have seen some young people being elected as mayors and politicians. In fact, there's a young lady in our parliament who I think she's 22, something like that, and she's straight out of university, but a total breath of fresh air. So, she's looking obviously for the future of young people. And that's a really important issue. One chose local tech, localized power generation using renewables. I thought that was really good. We actually touched on that in our focus group yesterday. One chose human tech, mapping emotions and collaborative networks. Now that is actually where I spent quite a lot of my time with my American business partner, called Steve Dent, who works in this area, something called partnering intelligence. None chose nature tech, so poor old Mother Earth, look after yourself. So in super tech, in deference to my august colleagues, I thought that last year's paper, wasn't it? It was this, the first day, I think. You were talking about the 6 dimensions of collaboration in 4.0, and I thought they were really, really good definitions. So just as a refresher, I'll pull those up here. Well, there was something that caught my eye, and the reason it caught my eye is because I'd read all this Joel's work. I thought, now there's something, and it's in green. Seek inspiration in nature towards optimized solution, which is nature tech. Okay? So all this stuff at the top is how we deal with our computers, our organizational algorithms, etc., the passing of information, but actually this is very, very interesting. So on the super tech side, I'll push on here. A lot of this stuff is taken from the paper, so if you read the paper, I'll try and gain some traction. One of the concerns I have with super tech, and because I study risk, resilience, smart cities, super cities, etc., is what happens when you pile a load of people in a confined environment? What do we find? Straight question. transmission of disease, viruses, bugs, overcrowding, rushing to emergency exits. I hate to say it, but an opportunity for nasty people to do nasty things, like we had in Manchester, yeah, the singers' Ariana Grande's concert. Yeah, so we have to be very careful where we start piling lots of people into confined spaces. And the World Health Organization also has concerns here, because we're getting these huge cities growing up, and literally in these huge cities, Mexico City, there's have and have not, and the have-nots far outnumber the haves. So all of a sudden you've got a divisive society, so be careful. And being an asset manager, fire risk, Grenville Tower, drought, famine, contagious diseases, civil unrest and crime, and the polarization of wealth. Now, if you read the papers this summer, we've seen this, haven't we? We have seen droughts, we have seen fires, we have seen civil unrest, and we've certainly seen polarization of wealth and power. To supply the food that these massive cities of tens of millions of people, towers in the sky, are going to need, what is the supply chain? What's the collaboration in agriculture, food storage and distribution look like? And what are we going to do about it? Water security, probably the number one issue. My training was in geotechnics and water engineering, and I see the problems here. I take my hat off in the UK to the Victorian engineers who created our super water systems and sewers, and there's some fantastic documentaries you can read about that. Public health in Victorian Britain, how it started, the creation of the flushable toilets and things like that. And this author Montgomery refers to that. So they actually predicted, and we're seeing this sort of Tower of Babel thing. Let's reach to the sky. We can build our cities in the sky. So we have this huge building, the Shard in London. Have you seen it? I paid £35 to go to the top of it. You get a brilliant view of London. I'm thinking, with the wind blowing on me on this platform, why? I mean, apart from the brilliant view, it's like £1 billion or something like that to build this building. Why? What are we achieving here? It's a superb demonstration of mankind's technical skills. But actually, if you look from the beautiful vistas of the old London as I would know it, with all these skyscrapers emerging in the business area, it's not so nice. Anybody seen this film called Ready Player One? Yeah? Which is based on a book. So, I advise you to seek it out as a DVD, because you'll probably get it there. It's brutal. Actually, what we've got in Ready Player One, the film, is people living in a virtual world, playing games to win some prize, because the real world they existed is so dire, the sort of inner city, town dump type of affair, that it's escapism. And that's why our great cities need green spaces and parks and ability to get out of town. But it's a really good film. So in the paper we mentioned this Pearl River Delta, where you've already got some quite large cities, and they're looking at making this enormous super city with the infrastructure collection, and the city's going to have 42 million people. That is 80% of the population of the United Kingdom. Yeah? It's absolutely a huge number. That's like 4 times the size of some of the largest cities on the planet. Luckily they've got a bit of geography to play with. So is actually a city, or is it a city region? As I said, there's consequences and risks. So to push this one on, I think the research here needs to be in areas of social inclusiveness, community and individual healthcare, benefits of green spaces, as we've mentioned. And research is going to be needed into how do we protect critical infrastructure, because if all your people live in very few places and you have an enormous water pipe supplying them, like one water pipe supplies the water from Manchester, from the Lake District, it's actually about this tall, that is critical infrastructure. And 2 million people are depending on one water pipe, Victorian. So I would suggest that we need to look at that in the sort of now to 10-year time horizon. And I don't know if anybody stayed up late. So I watched the launch of the new Apple Anybody got one? I can't afford one. So here's a proposition for you. I've got two parents who live close by, next door actually, in their 80s and an auntie in her 90s. They pay for various devices that dangle off and emergency buttons, etc. 20, 30 pounds a month for a service that's an emergency notification, but they have to press the button. So do you know this new device does two things of incredible piece of technology. One, it's a moving electrocardiogram. So I've had an instance, some friends recently who've had heart murmurs and say, this has the record to be able to take to the doctors and link up to the doctors to tell you that. And it detects you falling over. The mechanism of your fall, falling backwards, falling off. My father fell over, broke 3 ribs, painting a table. Goodness knows how that happened. And then, at 83, he decided he was going to go up an old wooden ladder to prune some hedges, and the rungs on the ladder gave way, and he was back in hospital. And my mother, inside the house, didn't know he'd fallen for about 20 minutes. So I had to rush him in the hospital. He had a swelling where it's a person's story. But this is literally your lab on a check. And it's going to be cheaper for me to buy my auntie and my parents one of these and tell them how to charge it up, and then explain it's also a telephone. Yeah? £300? I know it's a lot of money, but in the big context of life and people's well-being, it's a very, very good product. So moving on. This is scary stuff now. On the left, this is the very latest United Nations graphing of population forecasts. I checked on the weekend and it is the latest. On the left, is this a pointer on the top? Is there a pointer on this? Oh, I can't point. This is developed regions, developed world as we would know it, and this is everybody else. Can you see a certain trend with everybody else? Huge population growth forecast going out to the next 90 years, yeah? Huge. What is the one on the left tell you? The current societies of the West are not sustainable, not self-sustainable. We aren't actually having enough children or young people in work to be able to look after this ever-increasing aged population. I was talking with 2 of the facilities management people here earlier this morning, and they were commenting, yeah, that's what they're finding as well. And to like clean a huge place like this, people have come from all over the world. There are cleaners in this building whose origins are Somalia. Now, isn't that fascinating? Care homes, my auntie's care home, can't recruit enough people to look after the older people. So there's got to be something that connects these two, and I'm hoping it's something that's positive. You know, I'm hoping that sense will prevail in the UK in particular on this issue of net migration. We need the hands, we need the youth, we need the people. Education, well, I think we owe it to the rest of the world to bring people's education up to at least a common standard. Access to technologies, finance, energy, resources, etc. And I put aging care as support. So we have to collaborate with people from other parts of the world to have a fair balance of resources. There are some actual technologies like renewable recycling clothing.
Urban environments. And this is meant to create some discussions and identifying some problems and some gaps in relation to low carbon energy transitions. This will involve the research community on virtual enterprises, collaborative networks, ProVE, and it will have panel members that would support these discussions and interfere with their expertise, especially on an industrial perspective on the topic of discussion. So, let me invite the panel members who are going to support these sessions. We welcome Anne Sutton, Associate Director of BRE Wells. If you can have a seat on the panel. Paul Wong, Director of EU Agencies. Tom Bardell, Energy Manager in Newport Haven, Port Authority, and Sean Lyons, Project Manager in Water for the Institute of Technology. I have a slide showing the photos of the panel members, and we can, what would be interesting to emphasize at this stage is that we want to cover two dimensions for discussion today. One dimension is high-intensity energy consumers, high-energy consumers, and this is covered by Tom Bardell from Newport Haven and Sean Lyons from Waterford. They are involved in projects where fishing systems which have high energy consumers, and then we're trying to cover low and medium energy consumers, smart cities and domestic sectors, expertise provided by Andy Sutton and Paul Wong. Now, really introducing the topic and saying a little bit more about the process of transition to for low carbon energy. We have a trend of technologies, and there's an era of new technologies and advances, new solutions, but also some problems and gaps in relation to urban development. So, in particular, we want to emphasize this low carbon perspective, as this has a number of implications on other domains and aspects, such as legal aspects, social aspects, commercial and financial aspects. So really what we're trying to leverage on today is how can we rethink and pave the way to a built environment or to a sustainable ecosystem where you have energy consumers, you have new technologies, and you have a multidisciplinary approach where you have people, processes, and technologies. And this this context is really complex. So, for instance, we have use cases that range from transportation, smart vehicles. We have urban resilience to earthquakes. We have water ecosystems and catchment regulation. We have smart cities, and a number of other scenarios which they fall into the same category of transformation of our urban environment. Now, in relation to this, we are assisting now to a stage where there's a population growth, there's shifting demographics and climate change. There are some numbers that this population will grow more than 6 billion by 2045. Obviously, future is, and cities and the urban environments, they will need to be resource efficient, they need to be environment friendly, they need to adopt this stakeholder perspective, but also looking at users and really people and what are their needs and how can they be covered by this entire transformation of technologies. So I'll give some facts which hopefully would raise, would accelerate the discussion. The Fukushima nuclear power plant, there was an event happening in 2011 where a power plant in Japan has failed and has produced a lot of damages. The people, costs, financial implications, and this was a result of no management, no sensing, no design, no resilience, and risk was something that was neglected. I think this is probably the main reason of this event. Now, we're also assisting to an era where new technologies are appearing, new energy technologies. So the flying wind turbines, that's
research says that new energy sources will increase, and there will be more and more renewable energy, and will be less traditional energy consumers. But more importantly, I think, with this process of energy production in the urban ecosystem, at the level of cities or large energy producers, communities have started to create. And there, in Scotland, for instance, there's a community of 300 energy projects where they created this open market of energy producers and consumers. So, a neighborhood, for instance, they started to install technology to produce energy, wind turbines, they started to install solar PVs, and the main question for this is really how can users monetize these technologies? Right? Is there any way when a user can sell the energy in an open market and can have an incentive or to produce renewable energy? And what are the mechanisms? Apart from legal implication, financial implication. Now, in answer to this, I think blockchain and application is something that has been intensively discussed by the research community and by industry also, as a way to allow people to monetize their energy. So, because consumers are increasing in generating their own energy, they invest in solar panels and wind installations. They're looking for a way to monetize the energy by trading in a market of energy consumers and producers. So, this is quite a change, because as in many sectors, I think blockchain has other application, but in particular in energy, blockchain, the benefit of blockchain is to decentralize the market. Okay. So now, energy consumers can adopt any sort of provision, any sort of charging models, and more importantly, they have now an incentive to produce energy for their own, but also for the community. Now, giving some facts about energy consumption and this transition process is that if you can see on the left bottom, the energy consumption has exponentially increased since 80s to 2016. Now, the way how is this divided for England and Wales, if you can see, there's a very small portion of primary electricity. Primary electricity refers to renewable energy, renewable electricity, or electricity from renewable sources. Where in Canada, you can see that there's also a process which is quite long, and this is going to fluctuate. I mean, the fluctuation happens in UK. Is a process which is 50 years old, but you can see that in Canada it's even older than in UK. And I'll give you some more facts on this, just to create an argument. If you can see in here, there's an electricity map where you can observe the carbon emissions per country. So the darker is the country, the more carbon emission produces. The greener is energy is produced from renewable sources. For instance, you can observe that Sweden and Norway, they're very green because they use a lot of wind and hydro energy. Where France is also very green because they use a lot of nuclear power. Poland is dark because there's a lot of coal. Estonia is the same. Russia, we don't know much about Russia, but I think they produce energy from a diversity of sources. I don't have the picture for China, but for China, from the report that I've taken this, China has increased in energy consumption and production in the last twice more than US is producing and is consuming twice more than US is consuming. So this is the scene really. Okay, so this is the context. Now, can we actually create a discussion today to determine these low carbon energy transitions for urban environments as a vision for 2050? And can we determine the financial implication of this transformation? Alternative energy markets, clusters, economic models. Can we identify legislative challenges, commercial challenges, social challenges, technical challenges? And really, what I would like to emphasize before I leave the floor is this should really promote problems, gaps, and requirements. So, and we'll use an industry expertise in this from the panel members to find these gaps and these problems. We're happy to have this industrial participation to get their view on this urban transformation. And then the audience would entertain the discussion by possibly giving some solutions and whether the research community has solutions to these problems and if there are no solutions, at least ideas and the vision on how to address this energy transition and transformation for urban environments, which, by the way, believe it or not, is going to happen. Okay, so I'm going to leave the floor for the panel members and ask randomly Andy Sutton. Andy, we know that you're with BRE and you have expertise in a number of projects. In particular, I know that you're involved in the Plenary project. And what we really want to know is your view on this transformation and experience with this transformation in the recent years, and how do you see this happening? Any sort of view on this is welcome really at this stage.
Can people hear if I go without the mic, or here at the back? Use the mic. Okay, fine. So in 30 seconds, the Flatline project is one of a number of projects that we've done through the BRE with partners. We were looking with a housing developer at some detailed analysis of 58 homes in the pilot study, but 225 homes in the final implemented version, where we install renewables, battery storage, smart tech to control all of the above, and then use the housing estate as a power station for an aggregator platform to deliver into the energy markets and provide balancing, frequency response, etc. Through the homes, whilst providing what the feasibility study suggests that the fuel bills for all heating, small power and lighting and hot water would be £30 or less for the average home per month. So we're giving the occupants, I think it works out at about 64% reduced bills, whilst providing an income stream to the energy management company that are made through the balancing markets, through the energy side of things. So it's the idea was a win-win in the scenario that the user gets cheaper fuel, cheaper energy. There will be some usage clauses about not getting carried away with their energy supply, but it's an energy as a service model whereby the energy provider makes their money from providing a balance to the network, hence the project name Flatline, to try and achieve that overall balance. I think what we found through that and other projects is that this isn't primarily a technical problem. There are technical aspects to it, but actually this is a financial and legal problem. It's a problem that we've built by our own systems in that we don't see values in the same way in financial terms that we do as a society necessarily. We know there are big existential challenges, but we don't somehow manage to value those in a way that the financial markets value them. And there's a behavioural aspect in there as well. And I think there's a lot of overlapping things, but not primarily a technical challenge. It's
I just want to have a first round of intervention, and we move into a particular structure of the discussion. So, Paul Wang, the question that I have is a more of a industrial view on this, or a financial view, or a commercial view. I know you are involved in, in a number of projects. You have expertise in a diversity of domains, of scenarios from your projects, and I know you have an understanding about this transformation. If you can say a little bit more about what is your view on the transformation, how have you observed this happening in the last 10 years, and what do you think will be the transformation in the next period? If you can emphasize any particular points, that would be great.
There's different ways of how do people change what they do. How do we change our behaviour? You can use legislation, and the government would say, no plastic bags, or 10 pence for plastic bags, and it works. We have dramatically reduced the number of plastic bags we use. You can use persuasion and say, this is going to be good for all of us. This is going to be good for the next generations. Works for some people, not others, and you influence some people along those lines. You can go for ease. It makes my life better. If I do something or use something, it's just easier for me. And a lot of us will like the easy route. So if I can use social media to communicate rather than having to travel, or video conferencing, I've got colleagues in the Middle East, I can't just meet them. It would take half a day to get there. So we video conference, and it's easier. So you can make life easier for people. And then a great motivator for a lot of people is money. If there's a financial benefit, it saves me money, makes it easier, then I'll look at it. Doesn't mean I'll do it. If you look at people in terms of changing their energy supply, we all know most of us can't be bothered to change our energy supply to something that's cheaper every year. Why? Because I'm not feeling any pain at the moment. It really is of little consequence to me right now. If I say 50 quid a year, so what? So there's a mixture of things that I think come into play as to how do we get people to change our behaviour. And as Jörn's rightly pointed out, this is a complex scenario, and you need to look at different levers that affect different people and society as a whole. And I think the challenge for us there, I think you people here are at that forefront of thinking of what's the future going to look like, and how do we get society to get to that point.
Thank you. Now, I think Sean and Tom, they're covering the large energy consumers' perspective, and what I would like to hear from them is how this transformation is going to happen for ports, for instance, for large energy consumers, where Sean has expertise with sites in Ireland, and Tom Wardell is coming from Mitchell Haven. So, what do you think this transformation? What are the important aspects perhaps we need to consider when discussing about this transformation and low carbon energy transition with regards to ports and large energy consumers?
So, as a little bit of background, obviously I'm based in Ireland, and
closed door, for instance, you could potentially turn it up or turn it down. And obviously, enabling a smart grid or any energy market is all about supply and demand and enabling a balance within that. So where you have a degree of flexibility within there, where you can potentially turn things up and down based on maybe a price signal or availability of renewable energy or battery storage or whatever, that's key to it. So solving those issues are really the technical side of it, which is all quite doable. The other side of it then is getting people to think in that way. They've always turned things on and off at the same time, or they just turn it off when the fish arrive or whatever, and they'll continue to do that unless, as Paul says, there's triggers there, whether they're financial incentives or whether it makes life easier for them. Now in most cases here, it doesn't make life easier for them, so we've really got to make it that the financial incentive is worth their while doing it. But then the technology has to be smart enough that it's safe to do it in the background and do without any intervention. So yes, I agree with you, it is going to happen, but there's a lot of obstacles to happen in the meantime. So there's lots of other issues regarding flexibility, how predictable to make that. I suppose the other side of fish processors is that they all tend to be located in clusters, which potentially also makes them very suitable for microgrids, where they can potentially in the future, where some of them may invest in renewable energies. At the moment, it can be quite difficult if they're only using that renewable energy for themselves, but if they're within a cluster or a microgrid, sharing that energy then makes the return on investment much better. It improves the grid because you're producing energy locally, and it all starts to make more sense. So there's something to
Yeah, so the Port of Milford Haven is the UK's largest energy port, so we import 25% of the UK's gas. Basically, we're an infrastructure services provider. That's what we do. So we put the infrastructure in place. We own the infrastructure that other businesses operate within. We can see that the writing is on the wall for fossil fuels. We have a diversification strategy in place. We're looking at all sorts of different business streams, but it always comes back to a business case. I think the challenge is for us, because we own the infrastructure, although we might want to invest more money in renewables, we already have a solar farm, 5 megawatt solar farm and 600 kilowatt of solar on our buildings. But because most of the buildings are tenanted, that business case doesn't stack up. If we want to do more energy efficiency, put more renewables on the buildings. So that's an ongoing challenge, and that's obviously not just the commercial sector, that's the residential sector as well, is that a vast proportion of our buildings are tenanted. Quite a lot of the tenants that we have might only have 12-month lease. And the reason for that is because we've got plans to redevelop the centre of Port, to bring in more tourism, to kind of improve the job prospects for the people there. But what that means is that the existing businesses don't have the security of tenure, and therefore they themselves won't invest in energy efficiency. We won't do it for them because we don't know the future of that building. And that's also the same for our own buildings that we occupy. The office buildings that we have, because we have grand plans for the future is to move into new buildings. We don't want to invest in the buildings that we've got. So we've taken it to the stage where we've invested a lot in renewables to make money from the subsidies. It sounds very hard-nosed, but that is the truth of the matter, is that the incentives were there to do it. Looking forward, we want to make the most of those renewable energy assets that we have. And obviously you've always got the time and the seasonal disparity there when renewables are generating. it's also to do with making the most of the assets that we've got. I think Johan touched on blockchain and these sorts of enabling you to use renewable energy differently or trade it differently. I think there's a real potential there. I don't know if any of you know Milford Haven, but the solar farm that we have is right in the centre of Milford Haven. So we've got Milford Haven on one side of the hill, and Haken on the other. We've got the solar farm in the middle. And really, it would be lovely to be able to have an offering to all of our tenants, and to all of the local authority housing there. There's also private home ownership. To have an offering whereby we can offer power from our solar farm, and then if they know that they're able to buy it from us at a cheaper rate, that then incentivises the behaviour change. We hope it does, because they can buy the power cheaper from us than they can from the grid. So I think the biggest challenges that we face are to do with making the most of the assets that we've got, and also how do you promote behaviour change within those tenanted buildings, or buildings where you have plans for the future to move out of, these sorts of things. Those are the big challenges as far as I can see.
Okay, thanks. We're moving now to some more specific discussions, if you agree. So, the next slide in here is to discuss technical challenges of implementing this low carbon energy idea. And what I've marked in here, there are two questions, and this is open to the audience now and also to the panel members. Is the technology available to facilitate the transition to low carbon energy and transformation of urban environments? And the second question is, what technology is required to support transition of such solutions? And which would be any other technical requirements really in two main scenarios, let's say two main scenarios. If I have a building, and I want to make that building more energy efficient. I want to reduce the carbon footprint. I want to maybe automate the building. And yeah, what would be the technical challenges, and if you see other challenges associated with technical challenges. And for ports, for large energy consumers, is what are the challenges in implementing smart clusters, smart grids? For instance, is there enough technology already to implement those? And what do you see as being also important to be discussed in association to these technical challenges? Are these technical challenges related to financial challenges, or commercial challenges, or legal challenges? If you can give a perspective on this, start again.
I think my instinctive answer to the first question is the technology available to facilitate the transition is yes, but I think there's a few nuances to that. So I think as a headline, we do have technology to be able to build a low carbon energy environment. It's getting better. It will be a better version in 5 years and all the rest of it. Fundamentally, it's achievable now. I think where perhaps the gap in the technology might be is around forecasting, in particular behaviour forecasting. We're bad at that. We're getting better collectively, but I think that's the biggest gap in the technology need. The hardware will improve, but ultimately is capable now. Some of the software is up to the job, but it's the forecasting element that's the weakest part. Right? The easy example would be my heating system allegedly can geo-tag me and knows when I'm coming home, and can turn the heating on and work out the temperature outside and work out how long, due to the thermal lag in my property, how long it will need to turn off before I've arrived and all that. In reality, it doesn't always work, so I don't trust it. It's behaviour forecasting that isn't good enough. So that's where I'd say the technology fix needs to be improved.
Please.
Yeah, I'd agree as well. The technology is there, and I'll pick up on the point
is an open environment, so we can address questions from the audience if anyone has a question. Okay.
Thank you very much. I agree with some of the reservations that there's security and forecasting related. It's challenging, I agree. But my question is like, if we see, if we look around different universities and different research institutes, there is a lot of research going on. Like if you take ProVE, for example, there are like different control strategies, value bonds, there is blockchain technology coming up. My question is how willing the end users or the industry is to take up these technologies and implement them or use them so that we get real-time feedback, not from the pilot side, but from different sectors or different end users, so that we can improve if it's needed, rather than saying like, for example, I don't trust this technology. So if you get this real-time feedback, it will help research institutes as well, so that we can redirect our research to the right people.
I'll try and answer a bit of that. I think in essence, I think the question you're asking is how does something get commercialized? In other words, how do we get people to take it up and use it? One of the key aspects on commercialization is you have an idea, something that is brilliant. You guys in the research field, I'm sure you're all doing brilliant stuff. Whenever I go to Cardiff University, I say it's like a sweet shop. You walk in, loads of nice things going on. Look at that over there, brilliant. But it's just something in a university that's an idea and a piece of research. Well, so you then go, how do I get it out of the university and into society? And that's commercialization. Now that requires something called investment, by and large. Someone's got to buy into that idea and say, I will spend X amount of money to get it to the point where society, people as a whole, will buy it. Now for someone to say, I'll invest in that, they've got to understand how much do they need to invest, and then very crudely, how will I get my money back? So if I say, if you had a research idea and say, look, this is great, this will change society, fantastic, how much will it require to get it going? £10 million. All right, I've got £10 million. How will I get the £10 million back? With interest. So that's a financial view of how you look at it. When you come then to commercialize something, you're trying to persuade people this is worth engaging with. It's going to make your life better. It'll be good. So typically, let's take an example from films. If you spend $200 million on a film, you probably need to spend $200 million on marketing. Trailers, posters, interviews, magazine articles, etc. That's the commercialization of a product, to persuade people, go and see that film. If you make $400 million, you've broken even, and you're at the same point as if you'd never made the film. So you then got to look for, I need to go past that in order to actually make money and get a return on my investment. So you're trying to persuade people to take something up. You came at it from quite a technical perspective of how will they understand it, the technology. Society is not interested in how electricity is made, just that you plug something in and it always works. So there's an intermediary bit, which is the commercial component of somebody needs to take that on, commercialize it, and get it to the point that society will buy it because it works all the time. That's, I think, really the change. And if it's something like the iPhone, I saw the documentary on the BBC about Nokia, the 7th of January 2007, they knew their business was over because Apple launched the iPhone. And it was completely each other, and they knew it, and it has. So that's, I really think, the question
it is inevitably an iterative step process, and the early adopters are the early victims that are the keen people that try it, and their data then influences how the forecasting goes forward, and more people adopt, and you get through that bell curve of adoption. So that's, I think, the only route that really works. The one thing I would pick up on, where it certainly overlap with Paul's view, is it's not going to be the end users that we necessarily want to show all of this. That's not because of some secrecy, it's because they don't care. And I take Paul's point, it's not even that they want to plug it in and know it works. They don't even really want to plug it in. They actually just want it to work, and it's only because we've trained them over decades to learn to plug it in to make it work. They'll very quickly give up plugging it in because they don't really care. They just want whatever they want to do on the device, system, music system, whatever it might be. And that's the ultimate thing. It's an enabler for whatever activity they're going to do. And the energy services, energy provisions will see, and we are already seeing, new providers in the marketplace, new aggregators, new actors on the energy scene that are beginning to realize that actually what people want is comfort and power. Well, actually what they want is to get on with their everyday lives and do that in comfort with power. So it's a service provision, and actually the service provider, those energy aggregators, the service providers that are doing that, acting in that market, will be the ones that we need to interact with over gaining the data. Just like we've probably all done with our various devices, the end user will tick the terms and conditions box without reading them. And actually in the UK we're worse at that than most places. We're surprisingly liberal with our terms and conditions ticking. Germany's a little bit more rigorous. They actually even read it sometimes. So I think it's the end user needs to see the benefit, they need to see the ease, and we will be doing that, I think, through market actors in the intermediary position.
Okay. If you have any questions, otherwise I'll oh, please. Great. I was about to ask a question.
constant dialogue with them, and we'll respond to their consultations and so on and so forth. So, you know, we have that two-way dialogue, but at the end of the day, we're not they're the ones that are making the decisions. So yeah, we try as much as we can to influence.
I know a little bit about the slotted time a little bit, but I think they want an 80-year offtake agreement from the government. Now, if I said to you, you can have this house, but you need to pay for it for 80 years, you'd probably say no, in terms of mortgage. So this comes back to this aspect of, technically, it could work, absolutely. But the financial, commercial model doesn't work. Now, you know, I look at Wales and go, we have great wind as a resource, solar, quite a fair bit of the time, obviously, and tidal. Technically, we could be self-sufficient on renewable energy, adding some battery technology to supplement and dampen down peaks and troughs. It is technically possible. So the question is, what is the investment required to get to that point? And let's say it's X billion. Who's going to sign off on a 4-year Welsh Government cycle on that budget? It won't happen. So we can't do the investment that could get us to the point of being energy self-sufficient. We haven't got the systems in place. So if I take the analogy of retail, let's look at retail. House of Fraser, Debenhams, John Lewis, all struggling because they're running the historic systems of retail. We've all naturally migrated to online. Amazon foresaw that 20 years ago, started with huge debt in terms of starting off Amazon, now making huge profits. But they have foreseen where the bell curve is, and they are now picking up the retail market. Now that's someone who can make a decision over 20, 30 years on industry. And these questions are much longer in terms of how they need to play out than our current systems work to. So we have to look at our systems, whether it's cross-party agreements, and you say we just have to do something that goes across parties, and whichever colour the government changes to, we will stick to this for the next 30 years. Which is how places like China and some of the other countries worked it. They have just said, we're going to do something for the next 30 years. There will be no legislative change because we don't change our government. Hence they can do longer term thinking. That's the dilemma that I think we have in our society of how do we address these issues? How do we get something like the tidal agreement to work?
Okay, yes. I'll move to a new topic of discussions in relation to this. So, technical, if I had to add the last 2 sentences for this discussion is, I think technology is there, right? But in particular, I can see areas where this is not entirely covered. For instance, I'll give you an example that I have in mind. For instance, if a Chinese company comes to me for help and says, I have this battery which will absolutely do amazing storage. Right? So basically, you can store electricity how much you want and for how long you want, but it's very expensive. So probably this is another aspect where I see, at least in the next few years, happening. Technology will be more and more available, but it's going to be very expensive, at least from this perspective. And I can envision other examples, in other fields. But batteries at the moment, I don't know if you agree, are very expensive, and they don't support entirely all the requirements, for instance, for energy producers. Would you agree, Tom, or would you?
Yeah, I think it's similar happened with solar until Germany brought in very, I suppose, lucrative incentives for people to put them in, which had a result of increasing volume. Increased volume, price reduces, and there's more of an uptake of technology increases. So I suppose on the battery side, I suppose from an industry point of view, you're probably hanging your hat on the Elon Musks of this world that his plans, whether they're financially viable or not, is questionable. But hopefully, as the volumes increase, and obviously with solar, obviously with battery, you have material aspects as well, because there's finite numbers of battery molds and materials that go into it. But what happens is that when volume goes up, price comes down, and hopefully technology improves. So our batteries required for fast reducer response, load balancing, absolutely they are. It's not a technical question, it's a financial question. It's a financial model. It's exactly what you're saying. I'm not familiar with that, but tidal energy is very similar. Will it make financial sense in 2018? No, but hopefully in 2025 or whatever, yes it will. With batteries, hopefully it will be a lot sooner. It's an economic question. Issue.
We will into financial challenges. So, I mean, I was hoping to get this. So, okay, if we move on the other side of the wall, technology is technology. Of course, it has some economic implications, but if we would have to discuss this financial challenges in association with this low carbon energy transition and urban intelligence, urban transformation, is there anything that is really big and can be easy to observe and is, for instance, I'm a domestic user. I have a house. I want to change my boiler and my smart meter, and possibly I can adopt a technology which would transform my home into a smart home completely. So I would have efficiency management of the energy, efficiency in energy consumption, optimized comfort levels, low carbon, a high order of living environment. But really, what are the financial implications of this? From a consumer, if you can give, and from a producer perspective, as a solution provider, what kind of models or what are the financial implications for this? And on a consumer perspective, what incentive I have to adopt it? Because, as you said, I'm already used with what I have. They work. I open the window. I don't need an automation in my window. I don't need an automation in my blinds or shades to get natural lighting where I have artificial lighting. So, commercial, economic, financial aspects in relation to this. And on the other side, if I can do, is large energy consumers, ports, fish processing industries. Somebody goes in Kilibags and says, I completely automate your fish factory, and by automating this, you can reduce energy consumption by this, you can reduce time, you can address risks and implement something which is safer. Would Kilibags adopt the new technology? What financial implications are with this? And from a technology provider perspective, what are the economics models that you can see functioning? Who wants to start?
I guess I'll take the heavy industry. Maybe you guys can take the residential or domestic. I guess when you're speaking don't see the whole euros on there, so is there really? Trump telling me it's not there at all, so okay, just leave it on, get the fish out the door. That's the way they think. So it's a holistic view. The technology has to improve such that it's just happening in the background, without them even knowing it. But to give that initial investment, I think governments need to be more proactive to run our risks climate change, which we're not. So it's not the best.
I think it comes down to uncertainty, ultimately, and that's a domestic scale and a commercial scale to an extent. In that your decision with your own home is down to uncertainty of how long will I be there, will it add value if I choose to sell my house later, will my home be worth more, will the market reflect what I've spent on it, because I value things differently to whoever buys the home. And I think commercially it's the risk and uncertainty of, well, there's a risk of fish. I think in some ways commercially I look at it as a bit of a failure on the insurance markets, because typically speaking, Lloyd's of London and the like ought to be faster at offering commercialisation of risk for that. So, for example, adoption of a money-saving energy scheme for a commercial centre, you could offset at least not the reputational risk, but the financial risk by taking an insurance policy. And I think the commercial markets that monetize risk should be moving faster to do that, to support the adoption of innovative technologies, because in the commercial market that risk can more easily be turned into a cost and put on an accounting line. For residential markets, that can still be done for those service offerers, but the individual home users, we need to provide them with an easier solution. They're unlikely to go and buy an insurance policy to say, I've got a new smart home and it didn't work. What they want is the provider to be guaranteeing it works, and they want to know it works, or the worst cases it's no worse than it was before. I think those are potential routes, but it does ultimately come back down to that uncertainty. And as Paul suggested, we have this, the world's now, the Western world and now the globe's solution is a continuous growth model for the economy. That has one or two practical issues, but that's the model we're on. And we've got a democratic model of decision making. Those two don't look like being variables anytime soon, but they do give us a significant challenge in terms of what investment wants is long-term certainty, and the uncertainty that those two models create fundamentally gives us a scenario where we can't make long-term decisions, and we have to make long-term decisions to make big investments. And that's why we're seeing this at a macro scale. That's the problem. How you solve that is potentially, again, using the commercial markets of insurance, perhaps using iterative steps, but that's the broad challenge.
Tag on a bit, I think on the domestic level, it's got to be a combination of discomfort and incentives. I think energy is pretty cheap. There's no discomfort in our gas and electric bills. We can consume as much as we want. It might add a few pounds on in the week, no more than a takeaway on a Friday night. It's not in a discomfort zone. There's no real motivation or incentivization to change that behavior from an emotional perspective. Yes, economically, you can show spreadsheets, it'll be better for you. But who can be bothered? You could say, all right, we'll make electricity more expensive as you use more of it. Instead of a curve where it gets cheaper to consume, a curve where it gets more expensive to consume. That'll change your behavior, because now you're introducing discomfort. The alternative is you say, we'll incentivize you to do something. If you buy renewables for your house, we'll help with that becoming an asset of the house that it can transition with the house rather than it's tied into some other provider. It will reduce your energy. Someone will manage everything for you. You can incentivize people on those parts. So I think there's got to be sort of a look at how we create discomfort, plastic bag charge, and how do we create something that people can gravitate towards. already been invested in, it's there. So renewables has to compete on that investment curve in order to get there. And therefore, it comes back to your question, it's a complex situation when you need legislation and behaviour change and financial aspects.
Okay. Thank you.
What I would plan to do then with these hypothecates is that VAT or price increase cannot allow the energy companies, those very much foreign-owned in this country, to take that money out of the system. That should generate let me call it investment infrastructure fund. It seems to be a very peculiar situation where we can speculate over you know what of a £80 billion railway line that by the time it's built will have 3D meetings on our computers. And we're looking at this fundamental need of people to have hygiene factors. So I'm wondering whether the investors here 20 odd years ago, one corporation, Australian infrastructure took over surveillance and all sorts of systems. Infrastructure funds, which are dominated by externally priced places, we need to, like the stable sector, generate our own rewards. The final part of this might be what we have accumulated quite a lot of something like a pension fund. And absolutely staggered. Pension fund, as I understand it, and I hope is long-term stability of income. Of course, there needs to be some investment. So rather like dead land, you know, where developers have land banks and don't use them, maybe there needs to be an incentive for pension funds to take a little bit of risk on funding long-term infrastructure and energy programs, or be penalised if they don't. Because we were looking earlier on population issues in this country, and it's forecast by the end of this century. Twice as many people in this country, and we're already overcrowded. So actually, the energy use in these areas as well, not nothing. So is there these sort of three chunks of potential investment? Either via VAT and hypothecation, putting the price up and getting money back. That one was enables you to run in a feed-in tariff and a rebate type system. So it makes it a fair platform for all and values electricity.
Thank you. Right. I'm going to entertain this a little bit, but moving this into my zone of comfort. So let me find a slide that is relevant. Commercial challenges, which is, they are pretty much related to financial challenges. Really opening this economic models, cost models, energy as a service, commercial exploitation of energy clusters, and then I'll go back, if you allow me, and give this context to you, right? So, if you're looking at this concept of communities, so we are a community of users, consumers and producers. We have our own energy sources, we exchange, and we have a price for energy in our community. This is in Scotland. What happens if in Wales there's another community, they have their own energy sources, producers and consumers, and they exchange energy, and they have a different energy price in their network. Let's use this hypothesis, right? It can be viable. Why not? whereas the energy is produced with lower costs, probably that the price with energy makes sense to be lower, where if in Scotland it's produced with a higher cost, the price will be higher. Okay? So you trading within a community, so I can share energy with you because we are in the same community. We are SMEs and local people to meet for heaven. We are a community, for instance. But in another community, there are users. So is this having any indication on cost models and economic models and financial models? And going further, the blockchain technology, I just want to give this perspective and maybe we can discuss a little bit on this. Blockchain was exactly meant to cover this scenario. So blockchain natively was used to monetize products, similar products with different prices. So for instance, old Japan, hundreds of years ago, or thousands of years ago, no trading mechanism, no trading, only bartering. Okay? A family is producing rice with a high standard, another family is producing the rice with another standard. They were issuing scripts, money, paper money, and they were trading that in a community by exchanging rice, tomatoes, and potatoes, and so forth. So it's the first form of money. Okay. So now if you're moving in the energy field, if I produce energy using wind and a community and another community is producing energy from geothermal or solar, energy prices should be different because the costs are different. Okay? So if a community is issuing, because blockchain would lead to this, monetizing and trading Ethereum, Bitcoin, there will be coins. Okay, so if I'm an energy producer, I produce something, I produce energy, I can issue my own currency, which I can trade in my community of users. A currency that is backed up on energy, my own energy. A currency which can have a different value to other currencies issued by different energy producers. So just to entertain this context, I don't know if it makes sense, but at least it's something that sits on the back of my mind, and I think, look, I mean, I gave this, when I was completing my PhD thesis, Bitcoin was inviting people to join the community for free, and you receive 1 Bitcoin for free. 2010. 9 years ago, a Bitcoin, 20,000 pounds. Okay, I declined the invitation. I said, oh, no, I'll trade my own. So I think this is the trend. Let me see your opinion on this. I mean,
I think it's an interesting potential future. The analogy that comes, or the example that comes to mind is when the tube in London, I think there was a strike, or there was an incident, and at the same time, the price for Uber went up 4 times. Now that's an unregulated market, and it's responding to market conditions. If you apply the same logical behavior from all the individuals forming an overall crowd behavior to the energy markets, and you remember that our energy demand is not stable. We always talk about it in terms of price for energy and things, but actually the demand is massively varied throughout the day and seasonally. Then your wind turbine generator's price will actually be really low when the wind's blowing, because there's a load of other people that he's competing against. But if all the other systems go down, their price will go very high. And I think it touches on how in a disparate energy market where individuals are selling point to point, which is entirely possible and manageable, it's the role of regulation to sit within that to ensure that there's some degree of consumer protection. when you get home, as the rest of the world does, and puts the telly or the oven or whatever it is on, and we get that 4 till 7 p.m. Peak, where the price is already at 10 times higher, commercial prices 10 times higher at that time than they are. We as residential users, domestic users, we don't see that because we have a company that shields us from it. But in an environment where it's point-to-point, we will see that. And there are a new array of service providers that might come forward to shield us from that again. But in a true point-to-point Bitcoin or whatever based financial trading system, we will see that. And that will actually mean that we are making life more complex for ourselves, because we are then having to think very carefully about what we don't want to think about. We just want to get on with whatever it was we were going to do. So I think the role for regulation, the role for how those markets are controlled or at least tamed is very important to think about when we're thinking about that model going forward.
Yeah, I agree with Andy. I think everything we've spoken about today has to work in tandem with. I don't think the answer is having 300 community groups in Scotland and then decoupling from the national pay that end up becoming more expensive. It's where remote areas or communities that make sense that they can supplement the grid. So that's where the rules and regulations come into the legislation, and you've got to design that in a way that makes it fair and safe and secure to everybody. But smart grid, I think regulators can work in a way that can do that. Blockchain then can be a facilitator to do that, but having it completely open without any rules probably lead to anarchy and a more expensive system. So, but with rules and regulation, it can be.
Okay, next. That's why we're moving into regulation and legal challenges. So, yes, if there's anything we can develop as discussions on this legislative challenges, if we're going on a centralized or a decentralized energy market, if we, this urban transition is going to happen, what are the, legal implications for suppliers, for providers? Should be any dependence for regulators, for instance? Should legal, the regulation take into account the benefit of consumers, or how do you see this happening? I mean, if we're going to implement something brand new, do you see a problem on the legal side? Are governments, for instance, open to blockchain? That was one of the topics in the Science Hub in Swansea Town. So, are the governments open to blockchain? Loads of Chinese people are coming into the UK to implement blockchain because in their own country they cannot do it, and in the UK they can. So,
I was going to give an example on the regulation on the energy side, so I can't comment on the blockchain just yet. I think the example I was going to give was back to the Flatline project, where we're working with a developer who will be on site early in the new year to build 225 homes. We'll be building them to be sort of energy positive, give or take, depends on the time of day and time of year and all the rest of it as we've covered, but they'll have renewable generation, renewable storage. The solution that we'll be building will be an aggregated system in terms of facing the energy networks. The technical and commercial best solution we can't implement because of regulatory barriers. And I think that's the key point. The best solution for 225 homes would actually be a centrally managed storage solution. It would be most cost effective, we could maintain it, it would be away from the homes, we'd avoid any future nightmare scenarios over instances with lithium and all the rest of it. So that's the right solution technically. Regulatory framework as it stands means that if we did that, we would be providing microgrid. That would of off-gen requirements on the supplier, which increases the burden of cost to them. They become significantly worse off. The offer they can make to the consumers becomes significantly worse. You add to that the right to switch for home owners, not tenants, thankfully, so we're going forward as a tenanted solution rather than a homeowner solution to avoid that one, but the right to switch means that the homeowners could change their energy supply, and they have a right to do that. Now, if you've built a microgrid where you're supplying them through your own network and it's all behind either a physical or a virtual MPAN, then you really don't want them to switch. Ofgen is quite right to say that they should be getting best value and you can't hold them hostage to your grid, but equally, if you know you're providing them energy which is 2/3 cheaper than anything they can get in the marketplace, there must be some form of regulatory arrangement which can allow that to be proven without actually enabling that uncertainty to the system to come in. Now, we've built the models to look at it, and we've also estimated the number of people that would volunteer to switch to a bill that's 3 times higher. We think that's quite low, but it is still a commercial, it's a risk when there doesn't need to be a risk. So I think there is a role in regulation, as we've talked about the other side of regulation, in that it is necessary, certainly in the blockchain kind of environment where you are doing point-to-point trading. But there perhaps needs to be some capacity in regulation to allow for exceptions, pilots, prototypes, demonstrators, at a scale up to a reasonable enough scale to prove it commercially. So that isn't a one-off research example. That's done at a scale where you can get 10 megawatts running through it and really see it work. That perhaps needs some degree of capacity for regulatory relaxation to learn from it, to provide the data that the gentleman over there talked about, so that we can then pull that into a commercial argument to then change regulations, or perhaps not, prove it wrong and learn from the mistake. But that's the mechanism where I think regulation needs to be a little bit more agile.
I think with regulation, we're looking at 2 aspects here. One is keeping you safe. That's part of regulation. We're now looking at regulation. How do we use that to motivate change, to incentivize it? That's a very different type of use of regulation, but we've got the same people running it. So keeping you safe is be conservative. Incentivizing change is be entrepreneurial. Getting the same entity to do both is a hard, if not impossible, task. But that's what we're asking for out of regulation, and therefore it requires a larger thinking space as to how we go around that to get to that point. Now, if I take an example I worked on 8-9 years ago, a very small company based in Canada created a street light which would save 60% energy consumption. You could put it up on a lamppost, it would last for 20 years, no maintenance. Street lighting is a $2 trillion industry, and the energy associated with that, think about it, we calculated, if Wales did it, it would save £1 billion over the life of the light. Took that to Welsh Government, and the person I spoke to said, I want to see it run in England for 5 years first. Why? He didn't want to be associated with something that might fall over. He wanted to stay safe. Let's stay safe with our street lighting. It's all there, it works. I don't need to change anything. I'm not going to change it. But if the government, this is one individual, but if the government had taken an incentivization view, all street lighting could be changed using less energy, and we'd actually have a better product at the end of the day. So I think regulation, we're asking government or public bodies to do very disparate things, and they're not totally geared up for that.
Yeah, so again, you reference the other areas when we're speaking about any of these, but I think regulation is the same. It encompasses other things. So I know from speaking to regulators, they're totally positive about
social housing area where they don't have money to put solar panels on the roof. Somebody still has to pay for the network to keep the lights and everything that's on. So they're, you know, you can't say regulation is the issue and therefore the technology. It's a holistic view where, you know, investment, regulation, you know, fuel poverty, all of these are put into. So, but there certainly is, you know, scope there for regulators to do a lot more than what they're doing, because a lot of regulators are in a political sphere where they're looking at year life cycle. A lot of them doesn't happen. But, you know, you have to be brave here.
I was just going to say about non-commodity costs. So 60% of people build different homes. So it's just, you know, any sort of trials that you're doing, you're looking at trading between clusters, these sorts of things. That's outside of that. Obviously, Ofgem's got a sandbox for that. That's the big challenge: is how do you you have a trial where bills are cheaper for people, where you're trading energy like that in that way, launch it and so on. But you extrapolate it out to the bigger. Think about it on a national scale, then those are the sort of issues you've got to get over, is the commodity cost and transmission on the network, balancing that out. So.
Right. So can you people hear well from the browser? Okay. Let's check the time. Fine. Still time to discuss all these great, ideas, but understanding where we position users, occupants, people, social implications for this urban transformation. So, low carbon energy transition of different scales, you know, micro and macro level. Can we actually achieve user-centric urban environments where users are prioritized, social communities with risk assessment? Can we look at user behavior and how can we leverage on the expansion of social networks to address some of the social challenges in this transformation, really? I should give an example, maybe. If you take a smart home solution, okay? If you take a smart home solution, it's great. I mean, smart homes can be realized in practice. I don't know if you all agree, but you can do it. You can have the lighting. I mean, Andre has done it. He has change of lights. You know, whenever he gets closer to his home, 2 miles away, the boiler starts. You know, I don't know what else. So you can implement that based on the cost. So it costs money. But the question is, and you can, you know, energy consumption is better. You can do efficiency on this. You can achieve other things. Maybe it's safer environment. But are all these aspects which involve users, are these social aspects? Users as an individual and users as a community of users. Are these taken into account when this urban transformation is going to be implemented? For instance, when digital grid concept will be delivered, will be users in the middle of the loop, or will be users at the edge of the system? So this is the question. So user experience, for instance, user preference, user behavior, you know, user perception, things like this. And for large, probably, yeah, for large energy producers and consumers, what are the social implications, for instance, for SMEs, for community of users? You know, if Haven becomes a cluster, is this transformation leading to social cohesion, or it leads to, you know, it affects the community and the social community properties or attributes?
fintech breakfast briefing last week over at the business school, and they were talking about security in the banking world, online security. And one of the examples they gave was companies that can track how you swipe on a phone, how hard you press on the keys, so they're getting a biometric piece of knowledge as to how you use it, so that if somebody else tries to impersonate you, they will swipe and press differently, and therefore pick up this may be someone who's impersonating you. That's happening now in the banking world, and you'll never know about it because you don't need to. You just know that your bank is looking after you security-wise on that aspect. Now, the question I think you're posing, Johan, is how consciously do we get people to engage? I think people in the room will engage with it because you're in this headspace. I think 99.9% of society is not in this headspace, and therefore won't consciously engage. And therefore we have to find ways which nudge them to change what they're doing because we're trying to achieve a longer term objective that they're not buying into.
Yeah, sure. I agree with everything you said there. We look at, split it into domestic and commercial. If you look at domestic, there's no real incentives. You've got a government scheme for the really most poverty-stricken in society for insulation. So the scheme that came out was the Green Deal, where the interest rate was higher than you could go into the bank and get collapsed the whole business replaced. So there's no commitment from top down. You don't hear about the issue that's facing. We all know about the issue at the root here, but as you say, societies don't necessarily know about that issue or know how to engage with it or know what their role would be. So if they don't even understand the issue necessarily, then why would we be motivated to do anything? Why would we be motivated to spend money on insulation for the house when the bill is going off anyway and it doesn't really matter? And if nobody's telling you this is really, really important to be doing this, it's not going to happen. And from a commercial point of view, as a business which looks at energy efficiency, it's all about the business case. We don't fall under resource, which is the mandatory energy efficiency scheme for businesses. We're not big enough. So we don't have anybody really telling us that we need to do things. So it just comes down to simple financials. We look at what incentives are out there, the IHI, the feed-in tariff, these sorts of things. Build business cases off the back of it. We look at a particular technology or a measure that we're going to do in poverty. Say what the savings that we can get from that, how long that takes to pay back. So it goes back to incentives. Fortunately, there's not. I would say that we've reached the point now where we need more of a holistic approach, or at least an informed push in the right direction, rather than the non-committal most of the lot.
Yeah, I just wanted to say a brief things about user experience and the cause why users don't change their behavior. Is firstly because they have like a conservative mindset. Let's say I'm okay with it, I can manage it, I have enough money to pay for my energy bill, I don't need to save anymore. So it was needed to be a big caravan in the city center to actually inform the population of Cardiff regarding smart meters. Even if they received like hundreds of newsletters probably, and they have hundreds of advertisements on their on the energy suppliers' websites where they saw the smart meters, the population is still skeptical. They think, oh, the energy supplier is going to scam me, the smart meter is going to send wrong data, the smart meter consumes energy itself, and I don't know, maybe it's not, I don't think it's just the lower income households who have this conservative mindset. So I don't know, maybe it should be like a central authority that is impartial from a
adjusting their behavior and upgrading to the latest technologies.
Okay. If there's anyone who would like to raise a question, we have 1 minute for a question and 1 minute for an answer. Okay. Otherwise, we're wrapping up here. I think I'll simply present. Oh, look at them. Extension to the question. Please.
I try not to answer this simply. I think, imagine we didn't have a health service now, and someone came along and said, hey, let's spend billions on a health service. It wouldn't win a vote. But someone did about 70 years ago, and they had this vision because it'll be better for all of us. Now, we need that kind of thinking, that kind of leadership, which says, look, we have to invest in something because it's going to be better for all of us. It's complicated, it requires legislation, it requires debt, but we will get to a better place. That's, I think, the challenge for all of us in answering your overall question, Joanne, as to how do we answer this complex question a little more sustainably. And I guess within the room, all we have is pieces of that puzzle as to what that looks like. But collectively, it is, what is that vision going to look like to get to 2050? How do we get there? How do we go through the pain barrier to get to the place where we get to a more sustainable way of life?
I'm just going to add a note of optimism since we're wrapping up. The NHS is a great example. London did it with its sewers, with the Great Sink. We've even done it in the energy sector with the switch from town gas to North Sea gas. It's achievable, but it will take some vision.
Yeah, totally agree. I think I probably said it a couple of times. It's a holistic approach. I think the common denominator to all that is the policy numbers.
I mean, I think the sort of projects that we bring in academia and business together, like places, really useful because the question about all this big research which is coming out about how to apply to business. So if you can look at a little bit at the problem and work together to try and fix it, collaborate together. And obviously we've had EU money to date to do that, so that's obviously big difficulty going forward. And actually, it's taking the eye off the ball as well, Brexit activity, and the ongoing. For all of that, it's taking everybody's eye off this much more important issue.
I thought we were going to make it through a talk without mentioning Brexit, but there you go. You sneaked it in at the end.
To chuck it in the last 30 seconds. But yeah, it's a frustrating thing, isn't it? And, yeah, I'm trying to find a way of ending on a high note.
I'll pass it back to you. You ruined it.
Okay, so this was it's our low carbon energy transition for urban environments session. We are ending on a positive note, saying that we have a vision for 250. If you're looking at the image, there are flying drones and flying cars, and you know, there's everywhere. You know, there's smart buildings, there's towers, you know, there's entertainment there at every corner. Yes, so I hope we all meet in such an environment in 2050, and we have another conference about the vision for 2100, and see whether we are still humans and not robots. Okay, thanks for the audience for being here and for participating in the ProVE. Thanks for the panel members for kindly helping us with developing the session, and yeah, hope you all enjoyed Cardiff. If not, you know, there's a number of things you need to see, but from all those from Cardiff, yeah, the summer has ended, so yeah, prepare for the winter.